Have you ever played with building blocks? Data engineers are like expert builders, but instead of blocks, they work with information. They put together structures that make data neat and organized, like creating a super cool puzzle where everything fits perfectly. A data engineer is someone who designs and builds systems to gather and store and manage lots of information. On that note, hello everyone, welcome to this session to the Data Engineer full course. Join us on the journey and discover how data engineers shape the future on decision making and innovation. We'll begin by exploring the data engineering and the steps to become data engineer. Next, we'll provide the overview of big data, followed by the guidance on becoming the data engineer and insights into the associated salary. Azure is essential for data engineer because it offers a range of specialized tools and services designed to manage, analyze, and scale data effectively. So as we will cover Azure topics such as Azure Data Factory, Azure Database Services, and Azure SQL Database and Azure Data Lake, advancing further, we'll explore advanced data modeling using Power BI and Azure, including Azure Databricks. As we progress to advanced topics, we'll explore Hadoop essentials, covering HDFs, Yarn, MapReduce, Spark, Pig, Hive, and HBase with its ecosystem. Following this, we'll progress to understanding Kafka streams. To conclude the course, we'll discuss the essential Hadoop interview question and answers to advance your career in data engineering interviews. Before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also visit the Edureka website for the Data Engineer Masters program, the link to which is given in the description box below.
Today I'll share you an engaging story about two friends, Alex and Bob. Hey, have I told you about the incredible data engineering journey of a multinational e-commerce company? No, I don't think so. What happened, Alex? Well, let me share this story with you, Bob. This company had lots of valuable data but struggled with scattered systems and outdated databases. Oh, that's a tough situation. What did they do about it, Alex? They embarked on a data engineering initiative, Bob. It was quite a journey. I can imagine. So what changes did they make, Alex? They integrated their data into a centralized system and automated data cleaning and transformation. It made a huge difference, Bob. That sounds so promising. Did it impact their operations, Alex? Definitely, Bob. They gained faster access to accurate data and generated real-time analytical reports. Impressive. Did they address data governance as well, Alex? Yes, they implemented data governance practices for data quality, privacy, and compliance. That's commendable. It's a great example of how data engineering can transform a business. What an inspiring story, Alex. Yeah, I thought you would find it fascinating, Bob. Data engineering truly has the power to drive success and innovation together. Yeah, thanks for sharing the story, Alex. It reinforces the importance of data engineering in today's data-driven world. Hello everyone, this is Sanya from Edureka, and in this video, we will be diving into the fascinating world of data engineering. So data engineering is all about harnessing the power of data to drive meaningful insights. In today's rapidly evolving digital landscape, organizations are grappling with massive amounts of data, and that's where data engineering comes into play. Now, let's take a quick look at the agenda for this video. We will start by the introduction of what data engineering is and why it is important for so many businesses outside. Then, we will delve into the key components of data engineering such as data ingestion, data integration, data transformation, and data storage. Next, we will discuss some of the responsibilities of data engineers and the comparison between data engineer, data analyst, and data scientist. After that, we will delve into the installation process of popular tools and technologies which is used in data engineering. Finally, we will wrap up with a glimpse of what data pipelines are. So, let's understand what is data engineering first. Data engineering involves the design, development, and maintenance of system and infrastructure to handle large volumes of data effectively. It focuses on the extraction, transformation, loading, and storage of data, which ensure its quality and scalability of analysis. Now, let's understand what are the key components of data engineering. Data engineering helps to collect data from the disparate sources and integrate into a unified format, which allows organizations to have a comprehensive view of their data. It also involves processing and transforming data into a suitable format, which ensures data quality, consistency, and applications. It includes the development of data pipelines and processing systems that enable the efficient processing and analysis of data. This includes batch processing for large-scale data transformation and real-time processing for immediate insights and actions. Data engineering plays a crucial role in enabling data-driven world. By providing clean, integrated, and accessible data, data engineering empowers organizations to make an informed decision based on accurate insights and analysis. Overall, it is used to handle the complexity of data processing, storage, and integration, which ensures that the organization can leverage the full potential of their data assets for strategic operations and innovations. Now, after the thorough understanding of what data engineering is and its key features also, we will delve into the importance of data engineering. So, here are some of the key reasons why data engineering should be important or why data engineering is important. So, our first reason is it focuses on building scalable and efficient data processing systems. By optimizing data pipelines, leveraging distributed computing technologies, and employing the performance tuning techniques, data engineers ensure that the organization can handle large volumes of data and achieve faster processing times. It provides the foundation for advanced analytics and machine learning initiatives. By structuring and preparing data in a suitable format, data engineers enable data scientists and analysts to extract valuable insights, build predictive models, and develop machine learning algorithms. Data engineering enables organizations to process and analyze data as it arrives. This is crucial in scenarios such as fraud detection, recommendation systems, IoT applications, and monitoring systems that require immediate insights and actions. As we already know the importance of data engineering, we will cover the real-world applications based on this. So our first application is e-commerce sites. So data engineering is used to collect and process large volumes of customer data, transaction data, and product data. This enables e-commerce companies to predict recommendations, optimize pricing strategies, and improve inventory management. Our second example is social media sites. Like data engineering plays a crucial role in collecting, processing, and analyzing social media data, which allows companies to monitor brand sentiment, track user interactions, and derive insights for targeted marketing campaigns. So our third example is in finance and banking sector. Data engineering is used to handle financial data, including transaction records, customer information, and market data. It enables fraud detection, risk assessment, algorithmic trading, and personalized financial services also. Okay, so now the fourth application is in the healthcare sector. Data engineering is employed to manage and analyze patient records, medical imaging data, and clinical trial data. It enables healthcare providers and researchers to gain insights, improve patient outcomes, and develop predictive models. So these examples highlight the diverse application and the importance of data engineering in various industries, demonstrating how it enables organizations to leverage the power of data for operation and innovation. Now, the data engineering process involves several key steps, including data ingestion, transformation, storage, processing, and integration. Let's discuss each step in more detail. So our first step is data ingestion. Data ingestion refers to the process of collecting and importing data from various sources into a data system or data pipeline. This can involve extracting data from databases, files, APIs, streaming platforms, or the other resources. The goal is to gather relevant data and make it available for the further processing and analysis. Second step would be the data transformation. Once the data is ingested, it often needs to be transformed into a suitable format for analysis or storage. This data transformation involves cleaning, validating, and restructuring the data to ensure consistency and usability. This step may include tasks such as data filtering, aggregation, normalization, data type conversion, or the application of business rules. So our third step would be data storage. So after the data is transformed, it needs to be stored in a structured manner, right? So this typically involves using databases or data storage systems that provide efficient storage and retrieval capabilities. Popular choices for data storage include relational databases, data warehouses, data lakes, or distributed file systems. The selection depends on the specific requirements of the project, such as data volume, SS patterns, and the analytical records. So our next step would be data processing. Data processing involves performing computations and analysis on the stored data. This step can include tasks such as data aggregation, data improvement, data summarization, statistical calculation, or machine learning algorithms. Data processing can be done through various tools such as the SQL queries, data processing engines, or the custom scripts. Next step would be the data integration. So, in this step, data integration involves combining data from multiple sources to create a unified and comprehensive view. This step is crucial when dealing with heterogeneous data sources or when different style produced data that needs to be consolidated. Data integration can be achieved through data consolidation or by using extract, transform, load process to combine and merge data from various sources. Next, our last step would be the data governance. So data governance is nothing but a framework and a set of processes which ensures the effective management and utilization of data assets within an organization. It involves establishing policies, procedures, and guidelines for data management, data quality, and data usage. All the steps in data engineering process are typically iterative and may require continuous monitoring, optimization, and maintenance to ensure data quality, reliability, and performance. Data engineers play a crucial role in designing and implementing efficient and scalable data pipelines to support data-driven applications and analytics. Now we move ahead with the key responsibilities of data engineers, which typically includes designing and developing scalable and efficient data pipelines which extract, transform, and load data from various sources to our targeted systems. Next would be the managing and optimizing data storage infrastructure for performance, scalability, and reliability. Selecting and configuring appropriate data storage technologies such as relational databases, data warehouses, or NoSQL databases to meet data storage and retrieval requirements. Data engineers are also responsible for applying data transformation techniques to clean, filter, aggregate, and structure data for analysis or consumption by downstream systems. They are also responsible for implementing data processing tasks using programming languages or data processing frameworks to manipulate and transform data efficiently. Now, after analyzing the key responsibilities of data engineering, we will proceed with our next topic and understand the key differences between these three roles, that is data engineer, data analyst, and data scientist. These three are the distinct roles within the field of data science, each with its own set of responsibilities and skill requirements. So, our first profile is of data engineer. So, data engineers are responsible for designing, building, and maintaining the infrastructure and system that enable data storage, processing, and retrieval. As we all know, they focus on creating and managing the data pipelines and architecture necessary for efficient data collection, transformation, and storage. Data engineers also work closely with software engineers and database administrators to ensure data is accessible, reliable, and scalable. They typically work with tools like Hadoop, Spark, SQL, ETL frameworks, and cloud-based platforms for data processing and storage. Then our next profile would be the data analyst. So data analysts are focused on analyzing and interpreting data to derive meaningful insights. They work with structured and unstructured data to identify patterns, trends, and correlations. Data analysts are proficient in statistical analysis, data visualization tools, and data querying techniques as well. They often use tools like SQL, Excel, Tableau, or Power BI to analyze data and create reports and dashboards. After that, our next profile would be the data scientist. Data scientists possess a blend of skills from mathematics, statistics, programming, and domain knowledge. They leverage their expertise to develop and implement complex algorithms and models to integrate data patterns or extract insights from large data sets. Data scientists employ techniques like machine learning, predictive modeling, and statistical analysis to build predictive models, uncover patterns, and make predictions also. They also collaborate with stakeholders to define business problems and design experiments to gather their data. So, to summarize this, data engineers focus on the infrastructure and data pipelines. Data analysts work on analyzing and reporting data, while data scientists concentrate on advanced modeling and extracting insights. So, to make all this happen, data engineers rely on powerful tools and technologies. Platforms like Apache Spark, Apache Kafka, SQL, and NoSQL databases, and cloud services such as AWS and GCP provides the building blocks for efficient data engineering. These tools help process vast amounts of data, facilitate real-time data streaming, and ensure secure and scalable data storage. Now, let's understand what are the data pipelines are. So here is the glimpse of what data pipelines are and why we use data pipelines. So data pipelines are the series of steps that extract, transform, and load data from source to destination itself. Okay. So they enable the efficient and automated flow of data through different stages, ensuring data quality, consistency, and availability. Let's understand each step one by one. So the first step is extraction. The extraction phase of ETL involves retrieving data from various sources such as databases, files, APIs, or streaming platforms. The goal is to extract the relevant data needed for further processing and analysis. This process typically includes establishing connection to the data sources, performing data queries, or using data extraction tools to pull the required data into the data pipeline. Next step would be the transformation. The transformation phase of ETL focuses on cleaning, validating, and reshaping the extracted data to ensure its quality and consistency. This step involves applying various operations and rules to the data, such as data filtering, data type conversions, data aggregation, data enrichment, or data normalization. The transformation process aims to make the data suitable for analysis, storage, or integration into the destination system. Next step would be the loading. The loading phase of ETL involves storing the transformed data into the targeted systems such as databases, data warehouses, or data lakes. Then the data is loaded in a structured format that aligns with the schema or format of the destination system. This phase may include tasks such as data mapping, schema matching, data partitioning, or indexing to optimize data storage and retrieval. After that, our next step would be or maybe we call it our last step would be the monitoring and handling. Monitoring and handling refer to the ongoing monitoring, management, and the maintenance of data pipelines. Okay, so now let's discuss about batch processing and real-time streaming pipelines. So in a batch processing pipeline, there is a delay between time data is collected and when it is processed. This delay can range from minutes to hours or even days depending on the scheduled intervals. On the other hand, real-time streaming pipeline aim to process data as it arrives, which results in a minimal latency. Data is processed, analyzed in near real time or within a very low delay. The second point is batch processing pipelines are designed to handle large volumes of data efficiently. They can process and analyze massive amounts of historical data in a batch mode. On the other hand, real-time streaming pipelines focus on processing data as it arrives, making them more suitable for handling data streams with continuous high-velocity data updates. Now, the third point is batch processing pipelines typically utilize batch processing frameworks like Apache Spark or Hadoop MapReduce. These frameworks process data in chunks or batches, which allows for parallel processing and optimized resource utilizations also. While real-time streaming pipelines often use streaming frameworks like Apache Kafka, Apache Flink, or Apache Storm. These frameworks enable continuous processing of data streams, supporting low latency operations and real-time analytics. Now, the fourth point is batch processing pipelines are commonly used for tasks that involve historical analysis, generating periodic reports, or data preparation for machine learning models. They are well suited for scenarios where processing time is not critical but analyzing large volumes of data is essential. On the other hand, real-time streaming pipelines are ideal for applications that require real-time monitoring, immediate response, or instant insights based on live data. Use cases include like fraud detection, real-time recommendation systems, network monitoring, or IoT sensor data analysis. So our last point is batch processing pipelines often require significant computing resources during the processing phase as they process large volumes of data in a batch mode. Whereas real-time streaming pipelines also requires computing resources but are more focused on low latency processing and continuous data streams, requiring efficient resources allocation and management. So it's important to note that there can be the overlap between batch processing and real-time streaming pipelines, and hybrid architectures combining both approaches are common. So that wraps up our deep dive into the world of data engineering. We have covered the essential aspects of data pipelines, governance, and security, giving you a comprehensive understanding of how data is ingested, transformed, stored, and processed.
Now, how to become a data engineer? The roadmap to become a data engineer can go like from being proficient in programming languages to learning automation and scripting, then understanding your databases and mastering data processing techniques, to studying cloud computing and internalizing infrastructure. Now we'll see how to get started with becoming a data engineer. To get started with the learning process, you can look into our Edureka YouTube channel to start with. Even with no prior knowledge of data engineering, one can just go through the videos and get an understanding of the whole subject. We even have Edureka blogs to help you with detailed information on the topics and can give you a clearer picture. Apart from these, we even have premium courses which can help you understand the topic at ease with a personal trainer and 24 hours access to lifetime content. You can learn here at your own pace with a live trainer who is extremely efficient and knowledgeable and experienced in the particular field. These courses can even get you certificates which you can add in your CV for better opportunity in your job market. So that's it for today. I hope this video helped you and will help you decide how to become a data engineer.
Now I feel, Saurabh, it's the best time to tell the story about how data evolved and how big data came.
Fine, Reshma. So we'll move forward.
So Saurabh, what can you notice here?
Reshma, I see how technology has evolved. Earlier we had landline phones, but now we have smartphones. We have Android, we have iOS that are making our lives smarter as well as our phones smarter. Apart from that, we were also using bulky desktops for processing MBs of data. Now if you can remember, we were using floppies and you know how much data it can store, right? Then came hard disks for storing TBs of data, and now we can store data on cloud as well.
And similarly nowadays, even self-driving cars have come up. I know you must be thinking, why are we telling that? Now, if you notice, due to this enhancement of technology, we're generating a lot of data. So let's take the example of your phones. Have you ever noticed how much data is generated due to your fancy smartphones? Your every action, even one video that is sent through WhatsApp or any other messenger app, that generates data. Now this is just an example. You have no idea how much data you're generating because of every action you do. Now the deal is, this data is not in a format that our relational database can handle. And apart from that, even the volume of data has also increased exponentially. Now, I was talking about self-driving cars. So basically, these cars have sensors that records every minute details like the size of the obstacle, the distance from the obstacle, and many more. And then it decides how to react. Now, you can imagine how much data is generated for each kilometer that you drive on that car.
I completely agree with you, Reshma. So let's move forward and focus on various other factors behind the evolution of data. I think you guys must have heard about IoT. If you can recall in the previous slide, we were discussing about self-driving cars. It is nothing but an example of IoT. Let me tell you what exactly it is. IoT connects your physical device with internet and makes the device smarter. So nowadays, if you have noticed, we have smart ACs, TVs, etc. So we'll take the example of smart air conditioners. So this device actually monitors your body temperature and the outside temperature and accordingly decides what should be the temperature of the room. Now, in order to do this, it has to first accumulate data. From where? It can accumulate data from internet, through sensors that are monitoring your body temperature and the surroundings. So basically from various sources that you might not even know about, it is actually fetching that data and accordingly it decides what should be the temperature of your room. Now we can actually see that because of IoT, we are generating a huge amount of data. Now there is one stat also that is there in front of your screen. So if you notice, by 2020, we'll have 50 billion IoT devices. So I don't think so I need to explain much that how IoT is generating huge amount of data. So we'll move forward and focus on one more factor, that is social media. Now when we talk about social media, I think Reshma can explain this better, right Reshma?
Yeah, Saurabh, but I'm pretty sure that even you use it. So let me tell you that social media is actually one of the most important factor in the evolution of big data. So nowadays everyone is using Facebook, Instagram, YouTube, and a lot of other social media websites. So these social media sites have so much data. For example, it will have your personal details like your name, age, and apart from that, even each picture that you like or react to also generates data. And even the Facebook pages that you go around liking, that is also generating data. And nowadays you can see that most people are sharing videos on Facebook. So that is also generating a huge amount of data. And the most challenging part here is that the data is not present in a structured manner. And at the same time, it is huge in size. Isn't that right, Saurabh?
Can't agree more. The point you made about the form of data is actually one of the biggest factor for the evolution of big data. So due to all these reasons that we have discussed, have not only increased the amount of data, but it has also shown us that data is actually getting generated in various formats. For example, data is generated with videos, that is actually unstructured. Same goes for images as well. So there are numerous, or you could say millions of ways in which data is getting generated nowadays.
Absolutely. And these are just few examples that we have given you. There are many other driving factors for the evolution of data.
So these are few more examples because of which data is evolving and converting to big data. We'll discuss about the retail part. I'm pretty sure that all of you must have visited websites like Amazon, Flipkart, etc. And Reshma, I know you visited a lot of times.
Yeah, I do.
And suppose Reshma wants to buy shoes. So she won't just directly go buy shoes. She'll search for a lot of shoes. So somewhere her search history will be stored. And I know for sure that this won't be the first time that she's buying something. So there will be her purchase history as well, along with her personal details. And there are numerous ways in which she might not even know that she's generating data. And obviously Amazon was not present earlier. So at that time, there is no way that such huge amount of data was generated. Similarly, the data has evolved due to other reasons as well, like banking and finance, media and entertainment, etc., etc. So now the deal is, what exactly is big data? How do we consider a data as big data? So let's move forward and understand what exactly it is.
Okay, now let us look at the proper definition of big data, even though we've put forward our own definitions already. So Saurabh, why don't you take us through it?
Yes, Reshma, sure. So big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database system tools or traditional data processing applications.
Okay, so what I understand from this is that our traditional systems are a problem because they're too old-fashioned to process this data or something?
No, Reshma. The real problem is there is too much data to process. When the traditional systems were invented in the beginning, we never anticipated that we would have to deal with such enormous amount of the data. It's like a disease infected on you. You don't change your body orientation when you get infected with a disease, right, Reshma? You cure it with medicines.
Couldn't agree more, Saurabh.
Now the question is, how do we consider some data as big data? How do we classify some data as big data? How do we know which kind of data is going to be hard for us to process?
Well, Saurabh, we have the 5 V's to tell us that. So let's take a closer look at what are those. So starting with the first V, it's the volume of data. It's tremendously large. So if you look at the stats here, you can see the volume of data is rising exponentially. So now we are dealing with just 4.4 zettabytes of data, and by 2020, just in 3 years, it is expected that the data will rise up to 44 zettabytes, which is like equal to 44 trillion gigabytes. So that's really, really huge.
It is because all this humongous data is coming from multiple sources, and that is the second V, which is nothing but variety. We deal with so many different kinds of files at all once. There are MP3 files, videos, JSON, CSV, TSV, and many more. Now these are all structured, unstructured, and semi-structured all together. Now let me explain you this with the diagram that is there on your screen. So over here we have audio, we have video files, we have PNG files, we have JSON, log files, emails, various formats of data. Now this data is classified into 3 forms. One is structured format. Now in structured format you have a proper schema for your data. So you know what all columns will be there, and basically you know the schema about your data. So it is structured, it is in a structured format, or you can say in a tabular format. Now when we talk about semi-structured files, these are nothing but JSON, XML and CSV files where schema is not defined properly. Now when I go to unstructured format, We have log files here, audio files, videos and images. So these are all considered as unstructured files.
And Saurabh, it is also because of the speed of accumulation of all this variety of data altogether, which brings us to our third V, which is velocity. So if you look here, earlier we were using mainframe systems, huge computers but less data, because there were less people working with computers at that time. But as computers evolved and we came to the client-server model, the time came for the web applications and the internet boomed. And as it grew among the masses, the web applications got increased over the internet. And everyone started using all these applications, and not only from their computers and also from mobile devices. So more users, more appliances, more apps, and hence a lot of data.
And when you talk about people generating data over internet, Reshma, the one kind of application that strikes first in my mind is social media. So you tell me how much data you generate alone with your Instagram posts and stories.
It will be quite a boast if I only talk about myself here. So let's talk including every social media user. So if you see the stats in front of your screen, you can see that for every 60 seconds, there are 100,000 tweets, actually more than 100,000 tweets generated in Twitter every minute. Similarly, there are 695,000 status updates on Facebook. When you talk about messaging, there are 11 million messages generated every minute. And similarly, there are 698,445 Google searches, 168 million emails, and that equals to almost 1,820 terabytes of data. And obviously the number of mobile users are also increasing every minute, and there are 217 plus new mobile users every 60 seconds.
Geez, that's a lot of data. I don't even want to go ahead and calculate the total. It would actually scare me.
Yeah, that's a lot. Now the bigger problem is how to extract the useful data from here.
And that's when we come to our next V, that is value. So over here what happens, first you need to mine the useful content from your data. Basically you need to make sure that you have only useful fields in your data set. After that you perform certain analytics, or you say you perform certain analysis on that data that you have cleaned. And you need to make sure that whatever analysis you have done, it is of some value. That is, it will help you in your business to grow. It can basically find out certain insights which were not possible earlier. So you need to make sure that whatever big data that has been generated or whatever data that has been generated, it makes sense. It will actually help your business to grow and it has some value to it. Now getting the value out of this data is one big challenge. Let me tell you why. And that brings us to our next V, which is veracity. Now this big data has a lot of inconsistencies. Obviously, when you're dumping such huge amount of data, some data packets are bound to lose in the process. Now what we need to do, we need to fill up these missing data and then start mining again and then process it and then come up with a good insight if possible. So if you can notice, there's a diagram in front of your screen. So over here we have this field which is not defined, similarly this field, and if you can notice here, when we talk about this minimum value, you see the other minimum values, and when you talk about this, it is way more than the other fields present in this particular column. Similarly goes for this particular element as well.
Okay, so obviously processing data like this is one problematic thing, and now I get it why big data is a problem statement.
Well, we have only 5 V's now, but maybe later on we'll have more. So there are good chances that big data might be even more big.
Okay, so there are a lot of problems in dealing with big data, but there are always different ways to look at something. So let us get some positivity in the environment now, and let us understand how can we use big data as an opportunity.
Yes, Reshma, and I would say the situation is similar to the proverb, when life throws you lemons, make lemonade.
Yeah, so let us go through the fields where we can use big data as a boon. And there are certain unknown problems solved only because we started dealing with big data.
And the boon that you're talking about, Reshma, is big data analytics. First thing with big data, we figured out how to store our data cost effectively. We were spending too much money on storage before. Until big data came into the picture, we never thought of using commodity hardware to store and manage our data, which is both reliable and feasible as compared to the costly servers. Now let me give you a few examples in order to show you how important big data analytics is nowadays. So when you go to a website like Amazon or YouTube or Pandora, Netflix, any other website, so they'll actually provide you certain fields in which they'll recommend some products or some videos or some movies or some songs for you, right? So how do you think they do that? So basically, whatever data that you are generating on these kind of websites, they make sure that they analyze it properly. And let me tell you guys, that data is not small. It is actually big data. Now they analyze that big data and they make sure that whatever you like or whatever your preferences are, accordingly they'll generate recommendations for you. And when I go to YouTube, I don't know if you guys must have noticed it, but I'm pretty sure you must have done that. So when I go to YouTube, YouTube knows what song or what video that I want to watch next. Similarly, Netflix knows what kind of movies I like. And when I go to Amazon, it actually shows me what all products that I would prefer to buy, right? So how do you think it happens? It happens only because of big data analytics.
Okay, so there is one more example that just popped into my mind I'll share with you guys. So there was this time when the Hurricane Sandy was about to hit on New Jersey in the United States. So what happened then? The Walmart used big data analytics to profit from it. Now I'll tell you how they did it. So what Walmart did is that they studied the purchase patterns of different customers when a hurricane is about to strike or any kind of natural calamity is about to strike on a particular area. And when they made an analysis of it, so they found out that people tend to buy emergency stuff like flashlight, life jackets, and a little bit of other stuff. And interestingly, people also buy a lot of strawberry Pop-Tart.
Strawberry Pop-Tarts? Are you serious?
Yeah. Now, I didn't do that analysis, so Walmart did that, and apparently it is true. So what they did is, so they stuffed all their stores with a lot of strawberry Pop-Tarts and emergency stuff, and obviously it was sold out and they earned a lot of money during that time.
But my question here, Reshma, is people want to die eating strawberry Pop-Tarts? Like, what was the idea behind strawberry Pop-Tarts? I'm pretty unsure about it. But yeah, since you have given us a very interesting example and Walmart did that analysis, we didn't do it. So yeah, so it is a very good example in order to understand how big data analytics can help your business to grow and find better insights from the data that you have.
Yeah, and also if you want to know why strawberry Pop-Tarts, maybe later on we can start making an analysis by gathering some more data also.
Yeah, that can be possible.
Okay, so now let's move ahead and take a look at a case study by IBM, how they have used big data analytics to profit their company.
So if you have noticed that earlier the data that was collected from the meters that you have in your home that measures the electricity consumed, it is actually sending data after 1 month. But nowadays what IBM did, they came up with this thing called smart meter, and that smart meter used to collect data after every 15 minutes. So whatever energy that you have consumed after every 15 minutes, it will send that data. And because of it, big data was generated. So we have some stats here which says that we have 96 million reads per day for every million meters, which is pretty huge. This data, the amount of data that is generated is pretty huge. Now IBM actually realized the data that they're generating, it is very important for them to gain something from that data. So for that what they need to do, they need to make sure that they analyze this data. So they realize that big data analytics can solve a lot of problems and they can get better business insight through that. So let us move forward and see what type of analysis they did on that data. So before analyzing that data, they came to know that energy utilization and billing was only increasing. Now after analyzing big data, they came to know that during peak load, the users require more energy, and during off-peak times, the users require less energy. So what advantage they must have got from this analysis? One thing that I can think of right now is they can tell the industries to use their machinery only during the off-peak times, so that the load will be pretty much balanced. And you can even say that time of use pricing encourages cost-savvy retail like industrial heavy machines to be used off-peak time. So yeah, they can save money as well because off-peak times pricing will be less than the peak time prices, right? So this is just one analysis. Now let us move forward and see the IBM suite that they developed. So over here, what happens? You first dump all your data that you get in this data warehouse. After that, it is very important to make sure that your user data is secure. Then what happens? You need to clean that data. As I've told you earlier as well, there might be many fields that you don't require. So you need to make sure that you have only useful material or useful data in your data set. And then you perform certain analysis.
And in order to use this suite that IBM offered you efficiently, you have to take care of a few things. The first thing is that you have to be able to manage the smart meter data. Now there is a lot of data coming from all this million smart meters. So you have to be able to manage that large volume of data and also be able to retain it, because maybe later on you might need it for some kind of regulatory requirements or something. And the next thing you should keep in mind is to monitor the distribution grid so that you can improve and optimize the overall grid reliability, so that you can identify the abnormal conditions which are causing any kind of problem. And then you also have to take care of optimizing the unit commitment. So by optimizing the unit commitment, the companies can satisfy their customers even more. They can reduce the power outages, so that their customers don't get angry more, identify problems, and then reduce it, obviously. And then you have also to optimize the energy trading. So it means that you can advise your customers when they should use their appliances in order to maintain that balance in the power load. And then you also have to forecast and schedule loads. So companies must be able to predict when they can profitably sell the excess power and when they need to hedge the supply. And continuing from this, now let's talk about how Encore have made use of the IBM solution. So Encore is an electric delivery company, and it is the largest electrical distribution and transmission company in Texas. And it is one of the 6 largest in the United States. They have more than 3 million customers, and their service area covers almost 117,000 square miles. And they began the advanced meter program in 2008, and they have deployed almost 3.25 million meters serving customers of North and Central Texas. So when they were implementing it, they kept 3 things in mind. The first thing was that it should be instrumented. So this solution utilizes the smart electricity meters so that they can accurately measure the electricity usage of a household in every 15 minutes, because like we discussed that the smart meters were sending out data every 15 minutes, and it provided data inputs that is essential for consumption insights. Next thing is that it should be interconnected. So now the customers have access to the detailed information about the electricity they are consuming, and it creates a very enterprise-wide view of all the meter assets, and it helps them to improve the service delivery. The next thing is to make your customers intelligent. Now, since it is getting monitored already about how each of the household or each customer is consuming the power, so now they're able to advise the customers about maybe to tell them to wash their clothes at night because they're using a lot of appliances during the daytime, so maybe they could divide it up so that they can use some appliances at off-peak hours so that they can even save more money. And this is beneficial for both of them, for both the customers and the company as well. And they have gained a lot of benefits by using the IBM solution. So what are the benefits they got is that it enabled Encore to identify and fix outages before the customers get inconvenienced. That means they were able to identify the problem before it even occurred. And it also improved the emergency response on events of severe weather events and views of outages. And it also provides the customers the data needed to become an active participant in the power consumption management. And it enabled every individual household to reduce their electrical consumption by almost 5 to 10%. And this is how Encore used the IBM solution and made huge benefits out of it just by using big data analytics that IBM performed.
But let me just interrupt right now. So since Reshma told us in the beginning as well that there are no free lunches in life, right? So this is an opportunity. But there are many problems to encase this opportunity, right? So let us focus on those problems one by one. So the first problem is storing colossal amount of data. So let's discuss few stats that are there in front of your screen. So data generated in the past 2 years is more than the previous history in total. So guys, what are we doing? Stop generating so much amount of data. And it is said that by 2020, total digital data will grow to 44 zettabytes approximately. And there's one more stat that amazes me, is about 1.7 MB of new information will be created every second for every person by 2020. So storing this huge data in traditional system is not possible. The reason is obvious. The storage will be limited for one system. For example, you have a server with a storage limit of 10 terabytes, but your company is growing really fast and data is exponentially increasing. Now what you'll do? Now at one point you'll exhaust all the storage. So investing in huge servers is definitely not a cost-effective solution. So Reshma, what do you think, what can be the solution to this problem?
According to me, a distributed file system will be a better way to store this huge data. Because with this, we'll be saving a lot of money. Let me tell you how. Because due to this distributed system, you can actually store your data in commodity hardware instead of spending money on high-end servers. Don't you agree, Saurabh?
Completely. Now we know storing is a problem, but let me tell you guys, it is just one part of the problem. Let's see a few more.
Okay, so since we saw that the data is not only huge, but it is present in various formats as well, like unstructured, semi-structured, and structured. So you not only need to store this huge data, but you also need to make sure that a system is present to store these varieties of data generated from various sources. And now let's focus on the next problem.
Now let's focus on the diagram. So over here you can notice that the hard disk capacity is increasing, but the disk transfer performance or speed is not increasing at that rate. Let me explain you this with an example. If you have only 100 Mbps input output channel and you are processing say 1 terabytes of data. Now how much time will it take? Maybe calculate, it'll be somewhere around 2.91 hours, right? So it'll be somewhere around 2.91 hours. And I've taken an example of 1 terabytes. What if you're processing some zettabytes of data? So you can imagine how much time will it take. Now what if you have 4 input output channels for the same amount of data? Then it'll take approximately 0.72 hours, or converted to minutes, so it'll be around 43 minutes approximately, right? And now imagine instead of 1 TB you have zettabytes of data. For me, more than storage, accessing and processing speed for huge data is a bigger problem. Okay, so Reshma has a very good example to discuss.
Yeah, so since you were talking about accessing the data and you told us already about how Amazon, different websites and YouTube, they make those recommendations. So if there was no solution for it, if it would take so much time to access the data, the recommendation system wouldn't work at all. And they make a lot of money just by recommendation system because a lot of people go there and click over there and buy that product, right? So let's consider that it is taking like hours or maybe years of time in order to process that big amount of data. So let's say that at one time I purchased an iPhone 5S from Amazon, and after 2 years, I'm again browsing onto Amazon, and since it took so much time to access the data, and I've already switched over to a new iPhone, and they are recommending me the old iPhone case for 5S. So obviously that won't work. I won't go there and click it because I've already changed my phone, right? So that will be a huge problem for Amazon. The recommendation system won't work anymore.
And I know that Reshma changes her phone every year. So if she has bought a phone and people are recommending, if she has bought a phone now and someone's recommending the case for that phone after 2 years, doesn't make sense to me at all.
Yeah, only it'll work if I have both the two phones at the same time. But yeah, I don't want to waste money on purchasing new iPhone case for my older phone.
So basically, it won't be fair if we don't discuss the solution to these problems. Reshma, we can't leave our viewers with just the problems, right? It won't be fair. What is the solution? Hadoop. Hadoop is a solution. So let's introduce Hadoop now.
Okay, so now what is Hadoop? So Hadoop is a framework that allows you to first store big data in a distributed environment so that you can process it parallelly.
There are basically two parts. One is HDFS, that is Hadoop Distributed File System for storage. It allows you to store data of various formats across a cluster. And the second part is MapReduce. Now it is nothing but a processing unit of Hadoop. It allows parallel processing of data that is stored across the HDFS. Now let us dig deep in HDFS and understand it better.
Yeah, so HDFS creates an abstraction of resources. Let me simplify it for you. So similar to virtualization, you can see HDFS logically as a single unit for storing big data. But actually you're storing your data across multiple systems, or you can say in a distributed fashion. So here you have a master-slave architecture in which the name node is a master node and the data nodes are slaves. And the name node contains the metadata about the data that is stored in the data nodes, like which data block is stored in which data node, where are the replications of the data block kept, and etc., etc. So the actual data is stored in the data nodes. And I also want to add that we actually replicate the data blocks that is present in the data nodes. And by default, the replication factor is 3. So it means that there are 3 copies of each file. So Saurav, can you tell us why do we need that replication?
Sure, Reshma. Since we are using commodity hardwares, right, and we know failure rate of these hardwares are pretty high. So if one of the data nodes fail, I won't have that data block. And that's the reason we need to replicate the data block. Now this replication factor depends on your requirements, right? Now let us understand how actually Hadoop provided the solution to the big data problems that we have discussed. So Reshma, can you remember what was the first problem?
Yeah, it was storing the big data. So how HDFS solved it, let's discuss it. So HDFS provides a distributed way to store big data. We've already told you that. So your data is stored in blocks, in data nodes, and you then specify the size of each block. So basically, if you have a 512 MB of data and you have configured HDFS such that it will create 128 megabytes of data block. So HDFS will divide the data in 4 blocks because 512 divided by 128 is 4. And it will store it across different data nodes, and it will also replicate the data blocks on the different data nodes. So now we are using commodity hardware and storing is not a challenge. So what are your thoughts on it, Saurabh?
I will also add one thing, Reshma. It also solves the scaling problem. It focuses on horizontal scaling instead of vertical. Now you can always add some extra data nodes to your HDFS cluster as and when required instead of scaling the resources of your data nodes. So you're not actually increasing the resources of your data nodes, you're just adding few more data nodes when you require. Let me summarize it for you. So basically for storing 1 TB of data, I don't need a 1 TB system. I can instead do it on multiple 128 GB systems or even less. Now Reshma, what was the second challenge with big data?
So the next problem was storing variety of data. And that problem was also addressed by HDFS. So with HDFS, you can store all kinds of data, whether it's structured, semi-structured, or unstructured. It is because in HDFS, there is no pre-dumping schema validation. So you can just dump all the kinds of data that you have in one place. And it also follows a write once and read many model. And due to this, you can just write the data once and you can read it multiple times for finding out insights. And if you can recall, the third challenge was accessing the data faster. And this is one of the major challenges with big data. And in order to solve it, we're moving processing to data and not data to processing. So what it means, Saurabh, just go ahead and explain it.
Yes, Reshma, I will. So over here, let me explain you what you mean by actually moving process to data. So consider this as our master and these are our slaves. So the data is stored in these slaves. So what happens, one way of processing this data is, what I can do is I can send this data to my master node and I can process it over here. But what will happen if all of my slaves will send the data to my master node? It will cause network congestion plus input-output channel congestion, and at the same time, my master node will take a lot of time in order to process this huge amount of data. So what I can do, I can send this process to data. That means I can send the logic to all these slaves which actually contain the data and perform processing in the slaves itself. So after that, what will happen, the small chunks of the result that will come out will be sent to our name node. So in that way, there won't be any network congestion or input-output congestion, and it will take comparatively very less time. So this is what actually means sending process to data.
So who's a big data engineer? Now, every data-driven business needs to have a framework in place for the data science and data analytics pipeline. And a data engineer is the one who's responsible for building and maintaining this framework. Now, these engineers must ensure that there is an uninterrupted flow of data between servers and applications. So in simple words, a data engineer builds, tests, maintains data structures and architectures for data ingestion, processing and deployment of large-scale data-intensive applications. Now, data engineers work in tandem with data architects, data analysts and data scientists. So they must all share these insights to other stakeholders in the company through data visualization and storytelling. But what does a big data engineer do exactly? Now, the most crucial part of a big data engineer is to design, develop, construct, install, test, and maintain the complete data management and processing systems. They are basically the ones who handle the complete end-to-end infrastructure for data management and processing. They build a pipeline for data collection and storage and funnel the data to data analysts and scientists. So basically what they do is they create the framework to make data consumable for data scientists and analysts so they can use the data to derive insights from it. Note that the data engineers are the builders of data systems and not those who mine for insights. So the data engineer works more behind the scenes and must be comfortable with other members of the team producing business solutions from this data. Now all their responsibilities revolve around this. They need to take care of a lot of things while performing these activities. Hence, one of the most sought after skills in data engineering is the ability to design and build data warehouses. This is where all the raw data is collected, stored, and retrieved from. Without data warehouses, all the tasks that a data scientist does will become obsolete. It is either going to get too expensive or very, very large to scale. Now, data engineers should always keep in mind that the system which he or she builds needs to be scalable, robust, and fault tolerant, so that the system can be scaled up without increasing the number of data sources and can handle a huge amount of heterogeneous data without any failure. Now imagine a situation wherein the source of data is doubled or tripled, but the system cannot scale up. Will it not cost a lot more time and resources to build the same system again, which is suitable for this kind of intake? Exactly. This is why the big data engineers have a role here. Next, he or she is the one that handles the extract, transform, and load process, which is basically the blueprint for how the collected raw data is processed and transformed into data ready for analysis. Now you're going to acquire a lot of data from different sources. How do you bring them together to one platform? ETL is your answer. Apart from all this, a data engineer should always aim at deriving insights by acquiring data from new sources. Some of the responsibilities of a data engineer also include improving data foundational procedures, integrating new data management technologies and the software into existing systems, and building data collection pipelines. And finally, one of the major roles of a data engineer is to include performance tuning and make the whole system way more efficient, which is pretty self-explanatory if you ask me. Now, most of us have some idea about who a big data engineer is, but there's still some confusion about their responsibilities. Now, this ambiguity further increases when we gain more information about the role. Now, let me help you debunk all your queries about it. So let's talk about some big data engineer responsibilities. First up, we have data ingestion. Now, this is associated with the task of getting data out of the source systems and ingesting it into a data lake. Now, a data engineer would need to know how to efficiently extract the data from a source, including multiple approaches for both batch and real-time extraction, as well as needing to know about the incremental data loading, fitting within small source windows, and parallelization of data loading as well. Now, another small subtask of data ingestion is data synchronization. But because it's such a big issue in the big data world, we are going to talk about it. Now, since Hadoop and other big data platforms don't support incremental loading of data, a data engineer would need to know how to deal with detecting changes in the data source, merge and sync changed data from sources into the big data environment. Next, we have data transformation. This is basically the T in the extract, transform, and load that we had discussed earlier. It is basically focused on integration and transformation of data for a specific use case. Now, a major skill set here is the knowledge of SQL. As it turns out, not much has changed in terms of the type of data transformations that people are doing now compared to purely relational environments. Now, imagine all this data that you've acquired from various sources. What would you have to do to make them all palatable in the same platform? You need to transform that data, and this is what a data engineer does here. And finally, we have performance optimization, which is one of the tougher areas because anyone can build a slow-performing system. The challenge is to build data pipelines that are both scalable and efficient. So the ability and understanding of how to optimize the performance of an individual data pipeline and the overall systems are a higher level of data engineering skill. Now, for example, big data platforms continue to be challenging with regard to query performance and have added complexity to a data engineer's job. In order to optimize performance of queries and creation of reports, the data engineer needs to know how to denormalize, partition, and index data models. He also needs to understand tools and concepts regarding in-memory models and OLAP cubes. Now let's quickly move ahead and look at the required skills to fulfill these responsibilities. Now we'll be going through these skills in a clockwise order, so starting with big data frameworks. Now with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing this framework. It not only stores big data in a distributed manner, but also processes the data parallelly. There are several tools in the Hadoop ecosystem which cater differently for different purposes and professionals. For a big data engineer, mastering big data tools is a must. Some of the tools which you will need to master, first of all, you have HDFS, which is the storage part of Hadoop. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with Hadoop framework. Next, we have Yarn, which performs resource management by allocating resources to different applications and scheduling jobs. Now, MapReduce is a parallel processing paradigm which allows data to be processed parallelly on top of the HDFS. Next, we have Pig and Hive. Now, Hive is a data warehousing tool on top of HDFS which caters to professionals from an SQL background to perform analytics on top of HDFS, whereas Apache Pig is a high-level platform which is used for data transformation on top of Hadoop. Now, Hive is generally used by data analysts for creating reports, whereas Pig is used by researchers for programming. Both are pretty easy to learn if you're already familiar with SQL. Next, we have Flume and Scoop. Flume is a tool which is used to import unstructured data to HDFS, and Scoop is used to import and export structured data from RDBMS. Now next we have Zookeeper, which acts as a coordinator among the distributed services running in a Hadoop environment. It basically helps to configure management and synchronize services. And finally, we have Oozie, which is basically a scheduler which binds multiple logical jobs together and helps in accomplishing a complete task. Next up, we have real-time processing frameworks. Now, real-time processing with quick actions is the need of hour. Either it is a credit card fraud detection system or a recommendation system. Now, imagine if you wanted a red dress today and Amazon decides to suggest it to you a month later. Now, wouldn't that be completely useless for you? In this case, you need real-time processing. It is very important for a data engineer to have knowledge of real-time processing frameworks. Now, Apache Spark is one of the distributed real-time processing frameworks which is used in the industry rigorously. It can be easily integrated with Hadoop leveraging HDFS as well. Next, we have DBMS. Now, a database management system stores, organizes, and manages a large amount of information within a single software application. Now, data engineers need to understand the database management system to manage data efficiently and allow users to perform multiple tasks with ease. This will help data engineers in improved data sharing, data security, data access, and better data integration with minimized data inconsistencies. These are the fundamentals that data engineers should know prior to building a scalable, robust, and fault-tolerant system. Next, we have SQL-based technologies. Now, there are various relational databases that are used in the industry, such as Oracle DB, Microsoft SQL Server, etc. Now, data engineers must have at least the knowledge of one such database. Now, knowing SQL is also a must. This structured query language, as SQL is also known as, is used to structure, manipulate, and manage data stored in relational databases. As data engineers work closely with RDBMSs, they need to have a strong command on SQL. Now next, we have NoSQL technologies. As the requirements of organizations have grown beyond structured data, NoSQL databases have been introduced into this environment. It can store large volumes of structured, semi-structured, or unstructured data with quick iteration and agile structure as per application requirements. Some of the most prominently used databases are HBase, Cassandra, and MongoDB. Now, HBase is a column-oriented NoSQL database on top of HDFS, which is great for scalable and distributed big data stores. It is also great for applications with optimized read and range-based scan, and it provides consistency and partitioning out of CAP. Now, Cassandra is a highly scalable database with incremental scalability, and the best part about Cassandra is the minimal administration and no single point of failure. It's good for applications with fast and random read and writes. It provides available and partitioning out of CAP. And finally, we have MongoDB, which is basically a document-oriented NoSQL database, which is a schema-free database. It gives full index support for high performance and replication for fault tolerance. It has a master-slave sort of architecture and provides CP out of CAP. It is rigorously used by web applications and semi-structured data handling. Next, we are going to discuss programming and scripting languages. So various programming languages can serve for the same purpose. So knowledge of one programming language is enough. I'm saying this because the flavor of language may change, but the logic remains the same. If you're a beginner, you can go ahead with Python as it is an easy language to learn due to its syntax and good community support. Whereas R has a steep learning curve, which is developed by statisticians, and it is mostly used by analysts and data scientists. The next skill we're going to discuss is an important one. It is ETL or data warehousing. Now, data warehousing is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply extract, transform, and load. Now, data warehousing is used for analytics and reporting and is a very, very crucial part of every business intelligence solution because this is the part which is going to take you most time. Now, it is very important for a big data engineer to master one data warehousing or ETL tool. After mastering one, it becomes pretty easy to learn new tools and as the fundamentals remain the same. Now, Informatica, ClickView, and Talend are very well-known tools used in the industry. Informatica and Talend Open Studio are data integration tools with ETL architecture. The major benefit of Talend is its support from the big data frameworks. If you're new to data warehousing and ETL tools, I would definitely recommend you start with Talend because after learning this, any data warehousing tools will become a piece of cake. And finally, we have our operating systems. Now, intimate knowledge of Unix, Linux, and Solaris is very helpful as many mathematical tools are going to be based off of these systems due to their unique demands for root access to hardware and operating system functionality above and beyond that of Microsoft's Windows or Mac OS. Now, some level of understanding of how to act upon this data is also very valuable for data engineers. For this reason, some knowledge of statistical analysis and the basics of data modeling are also hugely valuable. Knowledge of machine learning and cloud also will serve as a big plus. While machine learning is technically something relegated to a data scientist, knowledge in this area is helpful to construct solutions usable by your cohorts. Now, this knowledge has the added benefit of making you extremely marketable in this space as being able to put on both hats, in which case makes you a really formidable tool. Here you can see the job distribution per salary range in India for a data engineer. As we can see, people who get paid more than 5 lakhs in annum are about 33%, 730 per annum are 26%, 8,70,000 about 20%, which are very high salary brackets. Apart from that, the average salary for a data engineer is almost 8 lakhs in annum, and for a senior data engineer is almost 16 lakhs in annum. If we look at the same numbers in the US, there are 32% of professionals who make more than $90,000 a year and 27% professionals who make $105,000 a year. The average salary in the US for a data engineer is way more than $90,000, and for a senior data engineer, it is $124,000 per annum. Now, as we have discussed the salary of a big data engineer, let's look at a few factors in the form of skills and technology that they know on which their salary depends. Here we've carefully curated a table which lists out the skills and the average salary which can be encashed through them. You can see services such as AWS, data analysis, data mining, warehousing, machine learning, and even programming languages like Java and R. Apart from that, you can see BI tools and statistical tools like Tableau, database architecture, ETL, and structured query languages. Now, another influence on the salary is experience, because experience is also a very important factor in deciding the big data engineer's salary. The distribution of salary is like so. An entry-level data engineer makes about $85,000 a year. People who have 5 to 8 years of work experience bag nearly $103,000 a year. And people who are experienced, I'm talking like 10 years of industry experience, get over $118,000 a year. Now, this salary must be coming from somewhere. Presenting to you the companies that hire in this job role. As you can see, there are some very big names like Amazon, Google, Bosch, Microsoft, and IBM who hire big data engineers. Now, companies that hire big data professionals are companies that are invested in the future. And the worldwide big data market revenues for software and services are projected to increase from $42 billion in 2018 to $103 billion in 2027, attaining a compound annual growth rate of about 10.5%. That sort of a growth needs some kind of work. After going through multiple job descriptions, we found that the big data engineer's salary has many variables.
So let's go ahead and also understand the average salary of a data engineer. So in the US, the average salary of a data engineer is $133,000. But remember guys, this is basically an average salary, which basically means that there are people who are above this salary or can even be a person who is below this salary. Okay. But later in this session, I'm also going to talk about some of the job description which can tell you the kind of salary that you can earn once you start applying for a data engineer profile. In India, the salary is around 6.5 lakhs per annum or 7 lakh per annum, and the same goes for an Indian jobs as well, that the salary can be higher than this average package or it can be lower than the package as well. Now that you have seen the basic or an average scale of a Azure data engineer, let's go ahead and see the job description of an Azure data engineer. Alright guys, so thinking again about what a data engineer does. An Azure data engineer is responsible for designing, implementing, and maintaining data management and data processing system on the Microsoft Azure Cloud Platform. Now, they work with large and complex data sets and are responsible for ensuring that data is stored, processed, and secured efficiently and effectively. Now, when you basically define a job role like that, you have many jobs description which are floating in the market, right? Now, how can you identify which job description you have to apply to? Now let's go ahead and understand that. So talking about the job description which basically exists in the market guys, you will see a job description which is an entry-level job description. And then on the next slide, I will show a job description which is a mid or a senior level job description. Alright, so heading back to the entry level. So if you see the first job description which is an Azure data engineer, the salary is anywhere around 6 lakh per annum to 14 lakhs per annum. And these are the skills that you require. Now, as I mentioned before, these are the expected skills required for an Azure data engineer. Now, what are the skills which are expected? Now, you are expected to know NoSQL or a Cosmos database skill. Now, they are expected to know data lake, data factory, data warehouse, and strong experience in building pipelines in Azure data or an Azure data lake. Then you should be able to analyze and understand complex data. You should be able to understand business requirement and actively provides input from data perspective. Now, at the same time, if you look at these skill sets are all the skills at which you will basically know after you study for or clear the Azure Data Engineer certification. So once you're done with the certification, once you are done with the skill sets, which is just there in the certification, you can easily go ahead and apply for a job that lies in the salary range, which is for an Azure data engineer. Now, talking about a mid-senior level data engineer profile, the list is quite long, as you can see. Now you can see that over here, apart from all these skill sets, a lot of other things are also mentioned here as well. For example, you should have some 4 or 5+ years of experience in implementing or designing solution using Azure Big Data technologies. Then you should have an experience with an hands-on in Azure Data Factory, Azure DevOps, Azure Data Lake Storage, etc. Now you should have a knowledge of big data pipeline, then design and build modern data pipelines and maintain the data warehouse schematics, layouts, architecture, and relational or non-relational database for data access and advanced analytics. Now you should also know Java, jQuery, SQL or Scala or any preferred programming language, right? So over here, what we recommend to our learners is you should go ahead and learn Python, because although they have mentioned only these programming language, but companies are very much flexible. Now, if the target profile has any programming experience, but a strong one in any of the programming languages, right? Next thing that they expect you to know is advanced skill using one or most common language, for example, like Python, Bash, etc. So this Python will basically serve as a dual purpose, that is all a scripting language and a programming language as well. The next thing that they expect you to know is the ETL process using big data technologies such as Spark, Kafka, Hadoop, and others. Now, the next thing that they expect you to know is the ETL process using big data technologies such as Spark, Kafka, Hadoops, and others. And then you need to understand the data visualization experience using Python. Python here is a plus, guys, so you need to understand this. And then you actually need to learn Tableau or a Power BI. Any one of the tools or technology is a plus point. So you either have to have a skill on Tableau or a Power BI. So this again is an important skill to have, and this again coincide with what a data analyst does, right? Because he is also responsible for data visualization to some extent. Then you have a solid understanding and experience implementing cloud data platform in Microsoft Azure DevOps. So if you're a guy who wants to start off, you can start off with the fresher profile, and after having experience in the fresher profile and learn all the skill sets like big data, Azure, these are the skill sets that if you gain, you can actually apply to the senior or mid-level in particular. Okay, so guys, these are the few job descriptions which are related to the data engineer profile. Now that we are clear with why, who, and what are the career opportunities and salary of an Azure data engineer, we shall see the path towards becoming an Azure data engineer. So first of all, you will have to talk about the different Azure storage which are out there. Now you'll have to learn about these like the blob storage, table storage, file storage, and the queue storage. Now you will have to learn about the relational database options as well, which are there in the market, such as the SQL database, SQL DB warehouse, analysis services. Now you will also have to learn about NoSQL. You will have to learn about big data services in Azure like data lake analytics, data lake storage. Now you also have to learn about the data factories, Azure functions, stream analytics, IoT hubs, event hubs, etc. Now apart from that, you will also need to learn Redis cache and Azure search. So these are the services that are basically required for you to understand in order to clear the certification and go ahead and become an Azure data engineer. Now these are also coincide with the job description that we had a look earlier, right? Now all the services which are mentioned there is basically a part of what you have learned in order to crack the certification. Now apart from this, we also recommend going through the open source services of Hadoop such as Spark, Hive, and the Hadoop itself, right? Now let us go step by step to reach our goal in becoming an Azure data engineer. So in order to become an Azure data engineer, you will also need to have a strong foundation in data engineering and cloud computing. Here are some steps you can take to develop the skills and knowledge needed for a career as an Azure data engineer. So the first one is learn the basics of data engineering. Now, in order to become an Azure data engineer, you should first develop a strong foundation in data engineering concepts such as data modeling, data pipelines, data processing, and data storage. Now, you can learn these concepts through online courses or books or by working on practical projects. Now, the second is learning a programming language. Now, as an Azure data engineer, you will need to proficient in at least one programming languages, as I've already mentioned earlier. Now, Python is a very popular choice for data engineering, but you can also consider learning languages such as Java, C#, or Scala. Now, the next step is you need to learn an SQL. Now, as a data engineer, you will be working with a large amount of data. You've already known that since the name itself as an Azure data engineer. So you will need to be a proficient in SQL to extract and transform data. Now the next thing you need to learn is Azure data storage options. Now as you know, Azure offers a range of data storage options such as Azure Blob Storage, Azure Data Lake Storage, Azure Cosmos DB, Azure SQL Database, and Azure Synapse Analytics, formerly SQL Database Warehouse. Now you should familiarize yourself with the features and capabilities of these storage options. Now the next thing you need to learn is Azure data processing technologies. Now Azure provides several technologies for processing data such as Azure Stream Analytics, Azure Databricks, Azure Data Factory, and Azure HD Insights. You should learn how to use these technologies to build data pipelines for ingestion, transforming, and processing data. So the next thing you need to learn is Azure data management and security. So you as an Azure data engineer should learn about the Azure tools for managing and securing data such as Azure Data Catalog, Azure Data Lake Security, and Azure Private Link. So what is the next step? The next step is get certified. As you know, getting certified is very crucial and it's very important in today's generation because all the organization, as I mentioned earlier, if I just have to go back in my slide, I will show you the job description where they have actually mentioned that you need to actually pass the certification. All right, this is the certification you required, that is a DP200 and a DP201. But as for now, you don't need DP200 or DP201. You only have to give one exam, which I'll be further talking about it, that is a DP203. Right guys, so moving ahead again. So you need to earn an Azure Data Engineer Associate certification by passing the DP203 exam. Right? Now what is the next thing you need to do is you need to gain practical experience. Now the best way to learn Azure data engineering is by working on practical projects. Now we all know this, right? Now you can find data engineering projects on online platforms such as 𝐄𝐝, or you can work on projects in your own organization, or you can enroll with Edureka and they provide you tons and tons of live projects which are developed by the instructor who have already worked as a data engineer in their organization. Now the next thing you need to learn is continue learning. Now as a data engineer, you will need to keep your skills and knowledge up to date as technologies and best practices evolve, right? Now making sure to stay current by learning about new Azure data engineering features and participating in professionals development activities. Alright guys, so now let us understand the things that you need to know about this certification that I've just talked about, that is your DP203. So guys, if you're applying for an Azure Data Engineer Associate, there used to be 2 exams that you have to give, which I've just mentioned now on the screen in the previous slide, right? One is implementing an Azure Data Solution, and the next exam is design an Azure Data Solution. Now, after clearing both these exams, it will give you the Azure Data Engineering Associate certification. And these 2 exams basically have the code, like I've mentioned, DP200 and DP201, right? But now this exam have been retired on 23rd February 2021. Now you guys just have to give one exam to clear the data engineer certification, and this exam is DP203. Now what they have done is they have clubbed both these exams and they have now included its syllabus in just one exam. They're asking questions from it, right? So earlier what you have to do is you have to pay for 2 exams, then prepare for 2 exams and give them, and then only you could get the certification. But now just by passing one exam, you can clear out the data engineer certification, right? Now as part of the new exams, now the skill sets have been updated as you can see on the screen. So basically these are the distribution of topics and they'll be covered in this exam. Now first of all, you will be asked most of the questions on design and implement data storage. Now this is going to have 40 to 45% of weightage, okay? Now I'm going to tell you what are the topics that comes under the design and implement data storage. So make sure you write it down, okay guys? So the first is design a data storage structure. Then the second is design a partitioning strategy. Then the next question is design the serving layer. Then you have the implement physical data storage structures. Then implement logical data structure. And lastly, implement the serving layer. Now after this, you will have design and develop data processing. Now this is of 25 to 30% weightage. Now there are 4 points coming under this design and develop data processing. Now the first is you need to learn about the ingest and transform data. Second is design and develop a batch processing solution. The third is design and develop a stream processing solution. And lastly, we have the manage batches and pipelines. All right. So coming to the third is design and implement data security, which is of 10 to 15%. So there are two main topics here, that is design security for data policies and standards, and the second is implement data security. Now talking about the last is you have the monitor and optimize data storage and data processing, which is again of 10 to 15%. Now even here also we have two main topics that you need to be covered, that is the monitor data storage and data processing, and the second is optimize and troubleshoot data storage and data processing. Now if you are with me till at this point, you shall have understood what are all the things that you have to learn in order to clear the exams and become an Azure data engineer, right? Since we have already discussed what are the path and what are the skills to learn to prepare ourselves, so like I said earlier, you now just have to give this DP203 exam to get the Microsoft Certification Associate Data Engineering certification. Okay, so just one exam and now you will get the certification for it. Right, so now let's move on guys, and now let's talk about how you guys can get started in clearing this exam and developing those skills and go ahead and apply for the job and become a successful Azure data engineer. So we have mentioned a lot of things that you have to learn, but how exactly you should go forward and start learning these things? Let's go ahead and clear that out. So first of all guys, what we can do for you is you can basically refer to a lot of blogs that we have written on, or we frequently update the videos on YouTube as well, such as this video which has info about the engineering certification or how to become an Azure data engineer. Now we frequently put more videos for such topics. Now you can go through them and basically get a jump start into how you can prepare. Now my recommendation to you will be to plan out your working plan hours after or before working shift of yours. Now you should at least spend 3 to 4 hours every day for the next 2 or 3 months in order to clear this certification exam. Otherwise, if you don't invest this much amount of time guys, it is going to be very difficult to crack the exam because there are a lot of things to learn, especially if you're not from a data engineering domain. Now it is going to be a little difficult because you will have to read documentation, you will have to do hands-on, right? Now at some point you will get stuck and you'll have some issues. You have to figure out what went wrong or what's wrong with the hands-on. I know this because I've also been there guys. But getting stuck is the most beautiful part of learning anything, because that is where you start the actual research and about how things work, right? So spend at least 2 to 3 hours every day, either after your work shift or before your work shift, to basically learn these technologies, right? And now for those people who feel like they do not have the time or they do not want to invest time in researching and they want someone to help them out in getting this exam cleared and become a successful Azure data engineer. So guys, we at Edureka also offer a course of Microsoft Azure certification training of the Azure Data Engineer Associate Certification course. And we also have a master program as well, right? Which will basically help you in clearing the Azure Data Engineer Associate Certification, right? Now, if you need a helping hand and you need someone, or you need to be taught by someone who's already cleared this examination and is already working as a data engineer in the industry, then this is the right course for you guys.
So why Azure Data Factory? Because again, we know that we have been generating data at an exponential rate, especially since last 5 years. And in 2015, we were generating data at the rate of almost 3.4 exabytes per month. And now we are generating at the rate of almost more than 44 exabytes of data per month. But that's almost 15 times increase in the amount of data in just a span of 5 years. And it is going to be increased by almost 30% more because of the current lockdown faced by all the entire globe. And that's why the entire consumption of data is again has been increased tremendously, right? That is it. That exactly is what we have. That's why we need to have the most optimized solution for data-driven solutions out there, especially on the cloud computing platforms, right? And modern data handling requires us to move from on-premise to database to cloud database services, and that too quickly. And then here we have to make sure again, and that's why the data needs processing and goes through a series of steps, making that process tedious. Because again, when we are trying to load the data, if we are trying to migrate other data from our database servers, from our on-premise storage services, then that has to go through a series of steps, and that makes the entire process much more complicated. It makes it much more slower as well, and plus, since it requires a good amount of investment, both in terms of time and money, it becomes we can say not feasible at all. And data factories simply help us in automating this entire process and thus serve the cause. That exactly is why we have data factory. Now, what exactly is data factory? What exactly is data factory here? So data factory is basically a cloud-based integration service through which we can we can design the entire workflow of data in cloud, and making sure that we can use for orchestration and for the automation purposes. So for example, suppose if we want, we can create a complete pipeline. We can define what is the source and how the pipeline should be structured, how the data is coming in, where it should be stored, and that too on a regular manner. So we can define the entire pipeline and we can automate the entire data movement. That means if we make any changes to any particular file or any objects in the on-premise, that will be automatically replicated, or we can say moved into the cloud services as well by the help of data factory. Right, and using data factory here, we can create and schedule the entire data-driven workflows called as pipelines that can ingest data from disparate data source. For example, if we have multiple data source defined here, we can simply ingest data from multiple sources, and then we can process it by a single pipeline. It is basically used for processing large volume of data, and these are done by integrating it with services like we have Azure SG Insight, Hadoop, Spark, Azure Data Lake Analytics, and Azure Machine Learning. So basically, if we are looking to make sure that we have the optimized data available and optimized stream of data available for analytics and for machine learning, then we have to do that by using data factory to maintain that consistency. And if we talk about the entire workflow here, first of all, the pipelines are all data-driven workflows. In Azure Data Factory typically performs the following 4 steps. It simply helps us in connecting and collecting the entire data set. So first of all, if we have multiple sources, if we have wide variety of data sources here, we have to make sure we are able to set the source for each and every connector. We have to make sure that we are able to connect to multiple services, and then we can through multiple APIs, or if we have multiple sources of data sets. For example, if we have data from our own CRM coming in, if we have data from our own ERP tool, from multiple social media analytics dashboard here, we have to connect and collect all the different data sets. Then we have to transform and enrich, because raw data always consists of multiple anomalies, right? There may be multiple missing values, there will be some incorrect data formats available, the data may be incomplete, or it may be or maybe multiple mistakes in that data, correct? So you have to make sure that we take care of the entire data transformation. That means if you want to convert the data format from one to the other, like we have the ETL, so again, we can take care of the transformation and the enrichment of data. That means data pre-processing and making sure it is much clear and again, it is usable by the analytical platforms for which we want to use it. Then we have to publish it to make it usable, and then we have to continuously monitor it, so that the entire process can be monitored in case there have been some breakdowns in any of the clusters from which we are collecting data. Then that can be monitored, and if something can be done, it can be processed as well. We can do that. Now let's understand each and every concept for data factory here. So if we talk about the entire concepts, first of all, we do have pipeline. We do have something as pipeline. So pipeline is a logical grouping of activities. For example, suppose there are 10 different sequences. Like we had discussed, first of all, we have to connect, then we can transform, then we have to process it, then we have to make it available for the analytical platforms. So if there are multiple sequences that needs to be followed, again, that is something that we define as a part of pipeline altogether. And then we have data sets. So obviously, without data sets, the entire data pipeline is of no use. So data sets simply represent the data structure within the available data store. So there are multiple data stores available. What exactly those are, we are going to discuss step by step. And then we have activities. So activities simply represents a processing step in a pipeline. For example, there are 10 different steps here. For example, we have to first of all connect to the source, Then we have to work on transforming data itself. Then we have to work on pre-processing. Then we have to work on setting up the connection. So this entire process itself is called as pipeline, where it consists of multiple sequence steps, and each and every individual step here, these are termed as activities. So a pipeline is what? We can say a pipeline is simply a collection of different activities. So that activity is focused on completing one different task, and pipeline simply defines the structure, or we can say sequence of those tasks, and it simply makes sure that that sequence is followed whenever the entire pipeline is being implemented. So let's erase this up. And next we have linked services. So it's simply the information needed to connect to the external sources. Like for example, we have APIs if we have third-party vendors, and we have third-party sources, then we do need an active APIs for that. And that's why these are all termed as linked sources from which we can source the entire data sets here. These are all additional links available. And as we know, data factory is basically used for on-premise itself. If we are looking to connect this, to multiple on-premise data sets here, then that exactly is what we use it for. Let's understand what exactly is data lake service. So data lake, as we know, data lake is simply an enterprise-wide hyperscale repository. So here again, it is simply an enterprise-wide hyperscale repository for big data analytics workload. And now it simply holds, it has a capability of petabyte. So it can hold data for any size. It will allow us to do, again, using that, we can do multiple operational and exploratory analytics as well. For example, if we have multiple sources of data. So for example, if we have data sources like from on-premise, we have sensors data. Like for example, when we're talking about aviation industry, then we have tons of data sets coming in from different sensors, especially and same way for any manufacturing sectors as well. Same way if we have any data collected for any websites. For example, we are talking about any stream of data coming in for analytics for any special websites. For example, let's suppose we have any big e-commerce solution for Amazon, Flipkart, Airbnb. So they have tons of data available on the platforms. If we have data coming in from different devices, it can also be a part of the complete IoT networks. There can be data in the format of videos, multiple social media streams coming in. For example, we have streams of Facebook, on Twitter, Reddit, on multiple platforms. So if you have multiple social media streams coming in the formats of posts, or let's say if you want to understand the real time, or you can say if your use case is to work on studying the user sentiments, right? Then in that case, we have to make sure we are pitching in the multiple social media streams coming in. If we have data in the format of images on application, then these all sources needs to be connected as a part of data factory, right? And that's why here we get in now. Once we have these data sources available, then we can connect it to AD analytics. We can connect this to SG Insight, to R, Spark, and machine learning purposes. Now, if we have been aware of the factors such as, now we can say data warehousing. We can say data lake works like a data warehouse. For example, if we are working on the real-time analytics, right? And if we have data sources from multiple platforms, so instead of connecting each and every source manually, or we can say one by one to Spark, we can store the entire data in a centralized location, and then we only need to connect a central location with a single connection to Spark. That's it. So it simply improvises the entire performance as well. Just like we have Redshift available in AWS Azure, same way here we have data lake. Now let's also understand multiple data lake concepts. Here. So data lake, as we know, again has multiple components inside it. Like we have analytics. Now in data lake components, we have components for analytics such as SG Insight. We have Azure data lake available. We can use data store for the complete storage purposes, or for analytics we can indicate this with SG Insight, and then we have Hadoop Insight, and then we have Azure data lake available. And then when we are trying, again, in terms of analytics, we have to make sure we do remember these three main key points. Analytics we can do on data of any size. There is no limitation. All users are productive on day one, and then we have to make sure that it is all scaled up exactly as per our enterprise requirement. We have to make sure of that part. In terms of type of data stored here, it supports all data types. We have structured, semi-structured, and unstructured data types supported. We have CSV files, we have XML files, right? We have the emails, we have JSON files, right? So again, these all are a part of semi-structured data when we don't have a direct format available on which we can start and perform the entire sorting. And that is example for semi-structured data set. And then we have unstructured data set, like we have images, videos, audio clips. These all are part of semi-structured data sets. And then if we compare data lake to data warehouse, if we compare data lake to data warehouse here, again, data lake, as you know, is simply complementary to the data warehouse, whereas if you talk about the data warehouse and service, it may be sourced to data lake. Data lake is basically used for detailed data, whereas as we can see, data warehouse is basically used for filter, summarize, and for refinement of data altogether. Data lake offers schema on read, whereas data warehouse offers schema on write. And data lake has one language to process data of any format, whereas in data warehouse we can process it using the SQL compliant data altogether. Now let's move into the hands-on here and see how exactly it is implemented on top of Azure Data Factory portal here. Data warehouse and data lake. Let's understand this by simple use case here. And for doing that, let's open up our notepad here. For example, let's say we have multiple data sources. For example, we have data sources available from our CRM, correct? For example, our main use case is we want to perform the analysis for sales report, for sales, for any company, correct? We are here to perform analysis of multiple sales data here, right? Or suppose if we have data coming from, say, from CRM, we have data from ERP tools as well, right? And then we have data from the old data set available. For example, we have their own CC file also stored here. So if we have multiple sources of data coming in, then if we want to club it, if we want to use this on top of any analytical platform, so there are two ways of doing that. Either we have to connect each and every source with the analytical platform, and then only we can start working on it, correct? Using the concept of data warehouse, what we can do, we can connect each and every source. We can store the data from each and every source to a centralized location, as in called as a data warehouse, right? And once the entire data is available in data warehouse, then we can connect that data warehouse directly to us through a single connection to our analytical platform, so that whatever analytics we are trying to perform, the entire process can be streamlined as a part of data warehousing service. Let's erase this up. For getting started on data factory here, we can come back to a portal. So here we can come back to a portal. In case you have not signed up on Azure, we can open this entire portal here, where we can start working on top of data factory one by one. Now for getting started here, what we can do is we can simply come back. And first of all, for having the entire database that we can install and we can interpret locally, we can use this. We can use an entire platform called as SSMS. In case you don't have the entire setup done at your end, then we can simply go ahead and download the SQL Server Management Studio in case you don't have the setup done. Now, once we have configured these, now what we can do, we can come back to our Azure portal. Now, in this Azure portal, what we can do, we can simply, first of all, once we are into dashboard here, we have to work around with, first of all, setting up the entire data warehousing service. So what we can do is here, we can set up the entire data warehousing service, and for setting it up, we can come back to our entire dashboard. Now, for creating a new resource, we have to click on this option which says create a resource, and then we can choose resource type here. So from databases here, we can choose. Now, here these are the most commonly used resources here. For example, if you want to go for web application, for functional applications, for SQL databases, we can choose accordingly. And if you want to start with SQL database, we can open up SQL database, and then we can set up the entire database platform. But again, in here, our main goal is not to create a SQL database, but to set up the entire data warehousing first, and then we can establish entire data lake services, and then get started on top of it, right? So here, what we can do here, either we can go ahead and search for the services using these categories, or we can use it directly. We can use the service bar to search for the services directly. For example, here we can use data lake. As you can see, currently we are planning to use the data lake. So here we can choose data lake here. Now, if you want to create it, now here we can simply click on create. Here we can define the name of the current data lake storage service that we are going to create. We can define the entire name. For example, let's say we call it as Edureka app itself. Here we can choose subscription. So currently here either we can go for two types of subscription. Here we can choose pay as you go, or here we can choose the free file. If in case we have free file available, then we can choose that. Then here we can choose resource group. In case we don't have the resource group created, we can choose a new resource group here. Let's enable the entire services there so that we can enable the entire subscription model here. So let's enable the entire subscription model. Here we can verify the code. In case we haven't set it up, we can simply set it up by simply specifying our entire details. Set it up so that we can use it for creation of our entire data lake and data warehousing platform. Now, even though if we are setting this up for the first time here, once we sign it up, we will be charged a nominal fee for making sure the entire account is well authenticated that we can use as a part of signing up for Azure platforms. And once it is done, this will take us back to the entire dashboard. Now, once we have entered the account here, we can simply click on create resource, and here we can choose data now. For example, let's say we are planning to start with by setting up entire data warehouse first, right? So earlier it was called as data warehouse, which was now changed to data lake itself. So now we can open up the data lake account altogether. So here we can go for data lake generation. Here we can click on create. Here we can define the entire resource name. Let's say we name it as Edureka. Here we can choose a subscription model that we are planning to go for. Here we can choose resource group. Resource group are simply like when we are planning for creation of, now when we are creating 10 different resources in Azure, and at the end we want to simply segregate them based on a certain project. For example, we want to know which all services have been deployed for which particular project. And if we want to see a consolidated billing for that particular project, then we can go for resource group. For example, let's say here we are going to create a resource group for app 1. We can choose any available resource group name that you want to go ahead with. All right, and here we can go for pay as you go model. We can choose the encryption. If you want to enable encryption, we can choose the keys, or we can simply choose the default keys from AWS. Let's say we choose a key from the key generation itself. We can configure this up. It may take a couple of seconds for this entire data lake to be created. And as you can see, it says the deployment in progress. So it may take a couple of minutes for this entire data lake to be processed here step by step. And once it is processed, we would be able to see this entire in live action. And in the meantime, in case you want to go ahead and set up the entire SMS that we have discussed, we have to have the SMS so that we can connect our local SQL databases, and then we can import it entirely into the Azure portal. And then we also have to set up an entire data factory. For setting up the entire data factory here, we can open up the data factory service available in Azure platform. Here we can click on add, and here we have to define the data factory name. For example, let's say we want to call this as Edureka DF as in data factory. Here we can choose a current version. So basically earlier we have been using V1, so now since last year we have been using V2. So here we can choose the subscription model that we have subscribed for ourselves for. We can choose resource group that we have already created by the name of Edureka app. So that if we have 10 different services, if we have 40 different resources being deployed, then we can, and again, all of those resources are mapped for a single application, then we can map it to a single application altogether. We can see that. And once it is done, we can simply choose a location in which we are trying to launch this particular data factory. For example, again, we have to choose a region which is obviously closer to our end users, because at the end, if we are not using a location which is not closer to our end users, then that will create a huge amount of latency. So for example, if our users are based in Singapore, so here we can choose region for Singapore altogether. If we know that our users are based not from Singapore, suppose from Central India, Australia East, Africa North, from Europe, from USA, so here we can choose our regions accordingly. For example, suppose here we want to start with North Europe. So here we can choose North Europe, And then if we want to specify a get URL, that will be used as a main data source here for this data factory. For example, let's say we use our own GitHub URL for this one. Let's log into our GitHub. And for example, suppose here we may have any particular repository here. We have any repository that we want to connect here, we can simply connect that. Let's say we can enter our GitHub URL. Here, if we have multiple repositories here, for example, here we have repository as Edureka 1. We can choose the entire Edureka 1 here. If we have branch as we want to go for let's suppose for the development branch. So here we have a branch for development. We can choose a branch name. So here we have the entire get URL here. We had to define the repository name, and then we had to define the branch name. And then we can choose a root folder for which we are trying to connect to here. So for example, if we have a root folder by the name of index, we can define index, and now we can click on create. So currently this is getting initialized. As you can see, our deployment is done for data lake, and currently the deployment is being in progress for data factory that we have currently deployed so far. Now currently this has been deployed here. Now if we want to download the entire deployment details, it's a good practice to download the entire deployment details, which will contain the entire list of all the pieces of information. And then for getting the entire operations detail here, we can simply choose the operations detail, where we can define the entire operations name, duration. And now if we want to configure this, we can open up the resource. Where now, and this resource here, first of all, here if you want to quick start, if you want to see the entire activity, that means what exactly it has been, and again, what exactly has been the RUPS, the storage usages, and the processor usage, and we can go ahead and see the entire monitoring part. And if we are planning to connect to this particular instance here, we have to make sure we are defining the current IAM user roles and their policies, because again, if we are using this through some particular account here, then we can enter this, we define the roles for them. They will not be able to make any changes to this particular server out there. That is something that we have to take care of. And along with that, let's go ahead and create one storage account as well. So again, for doing that, we can use a service bar available on top. So here we have to open up our storage account. Let's open this up. Now currently, as you can see, currently by default, once we start up, there won't be any storage account created and deployed. So here we have to go ahead and create one. Click on create storage account. Here we can choose a subscription model here. We can choose a resource group for the same application resource group that we have currently created. Here we have to define the entire storage account name. Let's say we name it as Edureka itself. And then we can choose location. Now remember this, okay, we already have configured that. So here, okay, 1, 2. So here we have to choose the same location in which we had deployed the other data lake and our data warehouse, our data factory itself. So we had deployed this for Northern Europe. So here we can choose North Europe, and based on where our locations are, where users are basically located, then we can choose a performance to be standard and premium. So again, in terms of account kind here, we can choose storage, or we can choose, if you're going for general purpose version 1 or version 2. So general purpose 1, again, depending upon a requirement, we can choose accordingly. If you want a higher performance, that means if we are looking to have a higher workload, then we can use Gen 2 that was released earlier last year. And then if you want to replicate the entire data, we want to go for zone redundant, we want to go for locally redundant, as in we want to maintain a local copy, or we want to maintain a read access redundant storage. That means again, based on multiple regions, it will be copied, but again, the copy will have only the read-only access. That means this will be used as a primary account for storing data, for writing data, and the replications will be used for just for the read purposes, so that the entire situation of bottleneck is also not created. And then we can choose assets here to be hot or to be cool, depending upon the requirement. We can choose it to be hot or cool here. Just like in case we have been available, if we have been familiar with the concept of multiple storage classes in AWS, same way we have standard and then we have infrequent access. So here we can choose cool if you want to move to something like infrequent access, which is not used frequently, or we can keep it to hot for those standard, we can say most frequently used files here. So currently we can keep it to host. Then we have to define the networking point. If we are trying to deploy this in our own isolated network, then we can choose public. Then we can choose private or public endpoint depending upon the requirement here. So if we have a virtual network created, then we can go ahead and use selected networks. If we want to deploy this on public endpoints, we can go for public endpoints. Or if again, in case you want to deploy this on our private, then first of all we have to configure our private endpoint, and then only we can get started. Then we can define the protection type here, whether we want to go for stop or like stop delete, or if stop delete as in if you want to retrieve it, we can simply do that. And then we have the Gen 2 hierarchical should be disabled, as you don't need it as a part of our handle currently. So we can keep it to disable. Then we can define the tags here. Tags are simply used for sorting and filtration purposes. If we want to sort this out later on, if there are multiple services that we deployed, and now we want an easier way to host it easily, then we can easily do that. And in here we can define tags. If you don't want to use it, we can review it. We have to wait for this one to be reviewed here. Once we are done, we can click on create. Let's wait for this one to be created. If you are looking to move files here from one part to the other, again we can easily do that. Is it access to free to create database? For creating databases here we can choose the engine. For database, for creation of multiple databases, here we have different services for doing that. For example, suppose for creation of databases here, we can click on create resource. We can choose resource type as databases, and here we can choose which particular database engine we are going to deploy here. Just like we have RDS available in AWS, same way here we can change it up. And if we're looking to create a complete data pipeline, then that's why we use Data Factory. So for example, if we are trying to transfer one data from the other account here, we can simply share that across multiple accounts. If we are trying to transfer data from on-premise to Azure or from Azure to on-premise, again, if we are looking to transfer from Azure to on-premise, then we can, or from Azure to on-premise, at least locally, then we can use another service called as Storage Explorer as a part of Azure platform. We can use that. If we are looking to transfer from Azure platform to on-premise, we can do that. We can take the help of Storage Explorer as a service. And then we can easily use the Azure import export to simply transfer the service from our Azure platform to on-premise. Just like we have a physical device offered as a part of Snowball in AWS. In case we have been working with AWS, and we have a service called as Snowball, where it is a simple physical device for if we are looking to get connected, we can take the help of storage gateways in that. So just like storage gateways, here we can take the help of Storage Explorer back into Azure for transferring data from in and out of Azure platforms.
Now let's have an introduction of a database. First, let's understand why do we need a database. So the various reasons a database is important are, first of all, it manages large amounts of data. A database stores and manages a large amount of data on a daily basis. This would not only be possible using any other tool such as a spreadsheet, as they would simply not work. Second is its accuracy. So a database is pretty accurate as it has all sorts of built-in constraints, checks, etc. This means that the information available in database is guaranteed to be correct in most cases. It's easy to update data in a database. So in a database, it is easy to update data using various data manipulation languages available. One of these languages is SQL. For the security of data, so databases have various methods to ensure security of data. There are user logins required before accessing a database and various access specifiers. These allow only authorized users to access the database. So fifth is data integrity. This is ensured in databases by using various constraints for data. Data integrity in databases makes sure that the data is accurate and consistent in a database. The last is easy to research data. It is very easy to access and research data in a database. This is done using data query language, which allow searching of any data in the database and performing computations on it. Now that you have understood the need of a database, let's briefly understand what actually it is. So a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system. Together, the data in the database management system, along with the applications that are associated with them, are referred to as a database system, often shortened to just a database. So data within the most common types of database in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. The data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases are a structured query language for writing and querying data. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. Databases are used to hold administrative information and more specialized data such as engineering data or economic models. Example includes computerized library system, flight reservation system, computerized past inventory system, and many content management systems that store websites as collection of web pages in a database. Now that you have an understanding of Microsoft Azure as well as of a database, let's now take a look at different types of databases in Azure. First is relational database. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on the relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish the relationships among data points. In a relational database, all data is stored and accessed via relations. So relations that store data are called base relations, and in implementations are called tables. Other relations do not store data but are computed by applying relational operations to those relations. These relations are sometimes called derived relations. In implementations, these are called views or queries. Derived relations are convenient in that they act as a single relation, even though they may grab information from several relations. Each relation or table has a primary key. This being a consequence of a relation being a set, a primary key uniquely specifies a tuple within a table, while natural attributes are sometimes good primaries. So this is all about relational database. Then second we have is non-relational database, also known as NoSQL databases. So NoSQL database or non-relational database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in relational databases. So non-relational databases are increasingly used in big data and real-time web applications. And non-relational databases are also like sometimes called not only SQL to emphasize that they may support SQL-like query languages or sit alongside SQL databases. So the prominent non-relational databases provided by Azure is Cosmos database that I will explain you further in this video. And third is in-memory database. So an in-memory database, also like in the short form we say it as IMDb, also like a main memory database system, or MMDB, or memory resident database. These are all the names of it. So an in-memory database is a database management system that primarily relies on main memory for computer data storage. It is contrasted with database management systems that employ a disk storage mechanism. In-memory databases are like faster than disk optimized databases because disk access is slower than memory access. The internal optimization algorithms are simpler and execute fewer CPU instructions. Accessing data in memory eliminates seek time when querying the data, which provides faster and more predictable performance than disk. A potential technical hurdle with in-memory data storage is the volatility of RAM, specifically in the event of a power loss, intentional or otherwise. Data stored in volatile RAM is lost. With the introduction of non-volatile random access memory technology, in-memory databases will be able to run at full speed and maintain data in the event of power failure. Let's now understand the architecture of database services provided by Azure. So you can see it looks like a complex architecture, but I will explain you quite easily. So the basic fundamental building block that is available in Azure is the SQL database. So Microsoft offers this SQL server and SQL database on Azure in many ways. We can deploy a single database, or we can deploy multiple databases as part of a shared elastic pool. You can see the elastic pools and single database. Okay. Microsoft introduced a managed instance that is targeted towards on-premises customers. So if we have some SQL databases within our on-premises data center and we want to migrate the database into Azure without any complex configuration or ambiguity, then we can use a managed instance. Because this is mainly targeted towards on-premises customers who want to lift and share their on-premises database into Azure with the least effort and optimized cost. We can also take advantage of licensing we have within our on-premises data center. Microsoft will be responsible for maintenance, patching, and related services. But in case if we want to go for the infrastructure as a service for the SQL Server, then we can deploy SQL Server on the Azure virtual machine. If the data has a dependency on the underlying platform and we want to log into the SQL Server, in that case, we can use the SQL Server on a virtual machine. We can deploy a SQL data warehouse on the cloud. Azure offers many other database services for different types of databases such as MySQL, MariaDB, and also PostgreSQL. Once we deploy a database into Azure, we need to migrate the data into it or replicate the data into it. Okay. Then we have is Azure Database Services for data migration. So services that are available in Azure, which we can use to migrate the data from our on-premises SQL Server into Azure. So in that, the first one is Azure Data Migration Service. So it is used to migrate the data from our existing SQL Server and database within the on-premises data center into the Azure. Then we have is Azure SQL data synchronization. If we want to replicate the data from our on-premises database into Azure, then we can use Azure SQL data sync. Then we have a SQL stretch database. So it is used to migrate cold data into Azure. SQL stretch database is a bit different from other database offerings. It works as a hybrid database because it divides the data into different types like hot and cold. So hot data will be kept in the on-premises data center and cold data in the Azure. Then we have is Data Factory. So Azure Data Factory is used for ETL, means transformation, extraction, and loading. So using the Data Factory, we can even extract the data from our on-premises data center. We can do some conversion and load into the Azure SQL database. Data Factory is an ETL tool that is offered on the cloud, which we can use to connect to different databases and like extract the data or transform it and load into a destination. Then there's Azure Security Center. So all the databases that exist in Azure need to be secured, and also we need to accept connections from known origins. For this purpose, all these database services comes with firewall rules where we can configure from which particular IP address we want to allow connection. We can define those firewall rules to limit the number of connections and also reduce the service attack area. So now let's talk about the Cosmos DB. So Cosmos DB is nothing but a SQL data store that is available in Azure, and it is designed to be globally scalable and also very highly available with extremely low latency. Microsoft guarantees latency in terms of reading and writes with Cosmos DB. For example, if we have any application such as IoT or gaming, where we get a lot of data from different users spread across globally, then we will go for Cosmos DB because Cosmos DB is designed to be globally scalable and highly available, due to which users will like experience low latency. Finally, there are two things, and one is we need to secure all the services. For that purpose, we can integrate all these services with Azure Active Directory and manage the users from Azure Active Directory also. To monitor all these services, we can use the Security Center. So there is an individual monitoring tool too, but Azure Security Center will keep on monitoring all these services and provide recommendations if something is wrong. I hope the architecture of Azure Database Services is now clear to you. Now let's move forward to briefly understand the database services provided by Azure. So the first is the Azure SQL Database. So SQL Database is the flagship product for Microsoft in the database area. It is a general purpose relational database that supports structures like relation data, JSON, spatial, and XML. The Azure platform fully manages every Azure SQL database and guarantees no data loss and a high percentage of data availability. Azure automatically handles patching, backups, replication, failure detection, underlying potential hardware, software, or network failure, deploying bug fixes, failovers, and like database upgrades and other maintenance tasks. So there are three ways we can implement our SQL database. So first is managed instance. This is primarily targeted towards on-premises customers. In case if we really have a SQL Server instance in our on-premises data center and you want to migrate that into Azure with minimum changes to our application and the maximum compatibility, then we will go for managed instance. Second is single database. So we can deploy a single database on Azure, its own set of resources managed via a logical server. Okay. Then we have is elastic pool. We can deploy a pool of databases with a shared set of resources managed via a logical server. We can like deploy the SQL database as an infrastructure as a service. That means we want to use the SQL server on Azure virtual machine. But in the case we are responsible for managing the SQL server on that, But in that case, we are responsible for managing the SQL server on that particular Azure virtual machine. So then we have the purchasing model. So there are two ways we can purchase the SQL server on Azure. So first is vCore purchasing model, also known as virtual core purchasing model. So the vCore purchasing model enables us to independently scale compute and storage resources, match on-premises performance, and optimize price. It also allows us to choose a generation hardware. It also allows us to use Azure hybrid benefit for SQL server to gain cost savings. Best for the customers who value flexibility, control, and transparency. So second is the DDU model. It is based on a bundled measure or compute storage and input-output resources. So sizes of the compute are expressed in terms of database transaction units, means DTUs, for single databases, and elastic database transaction units for elastic pools. This model is best for customers who want simple pre-configured resource options. And the second database service is Azure Cosmos Database. So Azure Cosmos Database is a NoSQL data store. It is different from the traditional relational database where we have a table and the table will have a fixed number of columns and each row in the table should adhere to the scheme of the table. In the NoSQL database, you don't define any schema at all for the table. And each item or row within the table can have different values or different schema itself. So now let's understand the Cosmos database structure. First one in the structure is a database. So we can create one or more Azure Cosmos database under our account. A database is analogous to a namespace and it is the unit of management for a set of Azure Cosmos containers. So the second is Cosmos account. So the Azure Cosmos account is the basic unit of global distribution and high availability. For globally distributing our data and throughput across multiple Azure regions, we can add or remove Azure regions from our Azure Cosmos at any time. I mean Azure Cosmos account at any time. So the third is a container. So an Azure Cosmos container is the unit of scalability for both provision, throughput, and storage of items. A container is horizontally partitioned and then replicated across multiple regions. Then let's understand the types of consistency under Cosmos DB. So Azure Cosmos Database approaches the data consistency as a spectrum of choices instead of two extremes. So strong compatibility and eventual consistency are at the ends, but these are many consistency choices along the spectrum. So the consistency levels are region agnostic. The consistency level of our Azure Cosmos account is guaranteed for all read operations regardless of the region from which the reads and writes are served. The number of areas associated with the Azure Cosmos account or whether our account is configured with a single or multiple write regions. Then there's request units. So we pay for the throughput we provision and the storage we consume on an hourly basis with Azure Cosmos DB. Remember this DB means database. So then there are request units in Cosmos DB means Cosmos database. So we pay for the throughput we provision and the storage we consume on an hourly basis with Azure Cosmos DB. The cost of all the database operations is normalized by Azure Cosmos DB and is expressed in terms of request units. The price to read a 1 KB item is one request unit. All other database operations are similarly assigned with a cost in terms of research units. The number of research units consumed will depend on the type of operations, item size, data consistency, query patterns, etc. For the management and planning of capacity, Azure Cosmos Database ensures that the number of research units for a given database operations over a given dataset is deterministic. And the third database service is Azure Data Factory. So Azure Data Factory is a data integration service based on the cloud that allows us to create data-driven workflows in the cloud for orchestrating and automating data movement and data transformation. Data Factory is a perfect ETL tool on cloud. Data Factory is designed to deliver extraction, transformation, and loading process within the cloud. The ETL process generally involves 4 steps. So the first one is collect and collect. We can use the copy activity in a data pipeline to move data from both on-premises and cloud secure data stores. So the second is transform. So once the data is present in a centralized data store in the cloud, process or transform the collected data by using compute services such as HD inside Hadoop, Spark, data lake analytics, and machine learning. Third is publish. So after the raw data is refined into a business ready consumable form, it loads the data into an Azure data warehouse, Azure SQL database, and Azure Cosmos database, etc. So fourth is monitor. So Azure Data Factory has built-in support for pipeline monitoring via Azure Monitor, API, PowerShell, log analytics, and health panels on the Azure portal. So then there are components of Data Factory. So Data Factory is composed of 6 key elements. All these components work together to provide a data form on which you can form a data-driven workflow with the structure to move and transform the data. So first one is pipeline. A data factory can have one or more pipelines. It is a logical grouping of activities that perform a unit of work. The activities in a pipeline perform the task altogether. For example, a pipeline can contain a group of activities that ingest data from an Azure blob and then runs a Hive query and an ℎ𝐷Insight cluster to partition the data. So second is activity. It represents a processing step in a pipeline. For example, we might use a copy activity to copy data from one data store to another data store. Then we have is data sets. So it represents data structure within the data stores, which point to or reference the data or we want to use in our activities as input or output. Then there are link services. So it is like connection strings, which define the connection information needed for data factory to connect to external resources. A linked service can be a data store and compute resources. Linked service can be a link to a data store or a compute resource also. Then we have as triggers. So it represents the unit of processing that determines when a pipeline execution needs to be disabled. We can also schedule these activities to be performed at some point in time, and we can use the trigger to disable an activity. Then the last one is control flow. So it is an orchestration of pipeline activities that include chaining activities in a sequence, branching, defining parameters for the pipeline level, and passing arguments while invoking the pipeline on demand or from a trigger. We can use a control flow to sequence certain activities and also define what parameters need to be passed for each of these activities. I hope you have now understood the major services of Azure databases. So now let's have a look at some of the use cases for Azure database services. First, let's see the use cases for SQL database. So the first one is developer or test environment. An important use case for replicating or migrating data to SQL hosted on Azure is for developer or test environments. Before deploying to the production environment, it is pertinent that the data is tested against developer and test environments. So Azure SQL database can act as a target for such environments. The live production environment can be replicated to the developer or test environment using a database copy. So the second is business continuity. One of the most important use cases for SQL on Azure is using it as a DR target to maintain business continuity. Azure SQL databases can provide an SLA of up to 99.99% by maintaining several copies of the data. This provides business continuity as it allows you to restore geo-redundant copies of the data or use active geo-redundant copies as failover points in use of outages at data centers or in regions. Besides SQL databases, you can also use availability groups to fulfill business continuity demands. Not only can you use availability groups in Azure SQL virtual machines, but also use Azure SQL virtual machine instances as a target for high availability and disaster recovery. And the third one is scaling out read-only workloads. Apart from providing BC or DR capabilities, active geo replication can also be used to offload read-only workloads such as reporting jobs to secondary copies. You can also extend on-premises SQL Server instance using readable always-on replicas. And the fourth one is backup and restore. So Azure SQL database are backed up automatically on a regular basis, and there are no storage costs for up to 200% of the maximum provisioned database storage. You can restore backups to any point in time going back to a pretended period, which is determined by the Azure SQL Service tier in use. On-premises SQL Server databases and transaction logs can also be backed up directly to Azure using the backup to URL feature and stored in Azure storage. So Azure SQL databases can also be stored on local storage by exporting them to backpack files, means backup and restore files. So fifth one is advanced analytics. So another important reason for hosting SQL in Azure is to make use of Azure's advanced analytics platforms such as Azure Storage Blob and Azure Data Lake Store. A common scenario with advanced analytics is when users reference data from various data sources, use Azure Data Lake Store as the staging area, or perform transformation activities using Hive or Spark, and finally load the data into Azure Data Warehouse for BI and reporting. BI means business intelligence. Now let's see the use cases for Cosmos database. First of all, they are used in IoT and telematics. So IoT use cases commonly share some patterns in how they ingest, process, and store data. First, these systems need to ingest bursts of data from device sensors of various locales. Next, these systems process and analyze streaming data to derive real-time insights. The data is then archived to cold storage for batch analytics. Microsoft Azure offers rich services that can be applied for IoT use cases, including Azure Cosmos Database, Azure Event Hubs, Azure Stream Analytics, Azure Notification Hub, Azure Machine Learning, Azure 𝐻𝐷Insight, and Power BI. Bursts of data can be ingested by Azure Event Hubs as it offers high throughput data ingestion with low latency. Data ingested that needs to be processed for real-time insight can be funneled to Azure Stream Analytics for real-time analytics. Data can be loaded into Azure Cosmos database for an ad hoc query. Once the data is loaded into Azure Cosmos database, the data is ready to be queried. In addition, new data and changes to existing data can be read on changed feed. So change feed is a persistent append-only log that stores changes to Cosmos containers in sequential order. Then all data or just changes to data in Azure Cosmos database can be used as reference data as part of a real-time analytics. In addition, data can further be refined and processed by connecting Azure Cosmos database data to HD Insight for 𝐵𝐺 or MapReduce jobs. Refined data is then for a sample of IoT solution using Azure Cosmos database, event hubs, and Storm. See the HD Insight Storm examples repository on GitHub. Okay. Then we have is retail and marketing. So Azure Cosmos database is used extensively in Microsoft's own e-commerce platform that runs the Windows Store and Xbox Live. It is also used in the retail industry for storing catalog data and for event sourcing in order to process pipelines. So catalog data storage scenarios involve storage and querying a set of attributes for entities such as people, places, and products. Some examples of catalog data are user accounts, product catalogs, IoT devices, registries, and bill of material systems. Attributes for this data may vary and can change over time to fit application requirements. Consider an example of a product catalog of an automotive part supplier. Every part may have its own attributes in addition to the common attributes that all parts share. Furthermore, attributes for a specific part can change the following year when a new model is released. Azure Cosmos database supports flexible schemas and hierarchical data, and thus it is well suited for storing product catalog data. Azure Cosmos database is often used for event sourcing to power event-driven architectures using its change feed functionality. The change feed provides downstream microservices the ability to reliability and incrementally read inserts and updates made to an Azure Cosmos database. This functionality can be leveraged to provide persistent event store as a message broker for state-changing events and drive order processing workflow between any microservices. In addition, data stored in Azure Cosmos database can be integrated with HD Insight for big data analytics via Apache Spark jobs. So the third one is gaming. The database tier is a crucial component of gaming applications. Modern gaming apps perform graphical processing on mobile or console clients, but rely on the cloud to deliver customized and personalized content like in-game stats, social media integration, and high-score leaderboards. Games often require single millisecond latencies for reads and writes to provide an engaging in-game experience. A game database needs to be fast and be able to handle massive spikes in request rates during new game launches and feature updates. So Azure Cosmos database is used by games like The Walking Dead, No Man's Land by Next Games, and Halo 5 Guardians. So Azure Cosmos database provides the number of benefits to game developers like Azure Cosmos DB allows performance to be scaled up or down elastically. This allows games to handle updating profiles and stats from dozens or millions of simultaneous gamers by making a single API call. Then Azure Cosmos DB supports millisecond reads and writes to help avoid any lags during the gameplay. Then Azure Cosmos database automatic indexing allows for filtering against multiple different properties in real time. For example, locating players by the internal player IDs or their Game Center, Facebook, Google IDs, or querying based on player membership in a guild. This is possible without building complex indexing or sharding infrastructure. Social features including in-game that messages player guild membership challenges, completed high score leaderboards, and social graphs are easier to implement with a flexible schema. So Azure Cosmos database as a managed platform as a service required minimal setup and management work to allow for rapid iteration and reduce time to market. The last one is web and mobile applications. So Azure Cosmos database is commonly used within mobile and web applications and is well suited for modeling social interactions, iterating with third-party services, and for building rich personalized experiences. The Cosmos database SDKs can be used to build rich iOS and Android applications using the popular Xamarin framework. So under web applications, first we have the social applications and then we have personalization. So in social applications, a common use for Azure Cosmos database is store and query user generated content, means UGC. So for web, mobile, and social media applications, some examples of a user generated content are chat sessions, tweets, blogs, posts, rating, and comments. Often the UGC in social media applications is a blend of free form text, properties, text, and relationships that are not bounded by rigid structure. Content such as chats, comments, and posts can be stored in Cosmos DB without requiring transformations or complex object to relational mapping layers. Data properties can be added or modified easily to match requirements as developers iterate over the application's code, thus promoting rapid development. Applications that integrate with third-party social network must respond to changing schemas from these networks, as data is automatically indexed by default in Cosmos database. Data is ready to be queried at any time. Hence, these applications have the flexibility to retrieve projections as their respective needs. So the second thing in web and mobile applications is personalization. So nowadays, modern applications comes with complex views and experiences. These are typically dynamic, catering to user preferences or moods and branding needs. Hence, applications need to be able to retrieve personalization settings effectively to render UI elements and experiences quickly. JSON, a format supported by the Cosmos DB, is an effective format to represent UI layout data, as it is not only lightweight but also can be easily interpreted by JavaScript. Cosmos DB offers turnable consistency levels that allows fast reads with low latency writes. Hence, storing UI layout data, including personalized settings as JSON documents in Cosmos DB, is an effective means to get this data across the wire. So these were the use cases for Cosmos DB. Now that you have a theoretical understanding of Azure database services, let's now see a simple deployment of a database service on Microsoft Azure. Just simply type Microsoft Azure on Google. What you can do is you can create a free account on Microsoft Azure. You get 12 months of free services and around 40,000 rupees of free credits also for using the services. We can just directly open the console from here. I will just sign in. So for deploying a simple database service, so what we are going to deploy today, we can deploy Cosmos database, like I have explained to you what is Cosmos database or NoSQL database it is. So we can just go to console, to the portal, I mean. You can go to the portal. You can create a resource from here. You can search for Cosmos. It comes like Azure Cosmos, yes. You can see here free credits. I have a free trial account, so it is showing that I have 14,500 free credits. So this is the credit amount you get for in a free trial. Okay, so you can create a Azure Cosmos DB from here. Which one you want to create? You can create core SQL one. So resource group, you can give a new one, or we have an existing. We have a Cosmos one, resource Cosmos. So if you want to choose the existing one, or if you want to choose the new one, okay. So you can choose the existing one from here. Or if you want to create a new one, then create new one. Source one Cosmos. I hope that works out. Yeah. Then give any unique name for this. I will give demo underscore Cosmos 123. Okay, it cannot contain underscore. Remember these things. Okay, it just cannot contain this. So 1, 2, 3, 4. I will. Okay, it's not available. So I will give 5 also. Yeah, it's available now. And choose your location, whichever location you are located in. You can use nearby location. So mine is Asia Pacific Central India. So I've chosen this. So free trial account is already there. I applied for it. Then you can just review and create. Before getting deployed, it will show you the review for it. So remember that on the basis of the location we have selected, the creation time will differ. Okay, so you can review it, all the information what you have inserted. So now you can create. So deployment is in progress. It will take a few minutes. You can see how the resource has been created. Deployment is in progress. Will soon be created. You can check details for it from here. Let's go to portal again. It is already pinned here, or you can search from here. Okay, for Azure Data Cosmos DB. So you can just click here. So it is showing that it is getting created. This is the one I have created before only. This one is creating. It is still in progress. Let's refresh one again. You can see the processing going on here. Yeah. So your deployment is complete. It's showing. You can go to resource from here also. You can just refresh it from here. So yeah, this is how it's been created. You can open the resource from here, and you can go to activity log or data explorer. You can create a database, anything, or you can see the consistency of it, default consistency and everything. So that's how Cosmos database is being deployed. So I hope you have understood this deployment. Let's look into the family of Azure SQL. So first one in the family is SQL Server on virtual machines. So With this, you can lift and shift your SQL Server workloads to the cloud to get the combined performance, security, and analytics of SQL Server with flexibility and hybrid connectivity of Azure with 100% code compatibility. Access the latest SQL Server updates and releases including SQL Server 2019. Register your virtual machines with SQL Infrastructure as a Service agent extension for automated virtual machine management at no additional cost. SQL Server on Azure Virtual Machines is part of the Azure SQL family, which allows you to migrate existing apps or build new apps on the best cloud destination for your mission-critical SQL Server workloads. So its features are, first of all, best TCO, that is total cost of ownership with Azure hybrid benefit. With Azure SQL Server, you can save up to 84% compared to Amazon Web Services migrating SQL Server databases with Azure Hybrid benefit and get free extended support for SQL Server 2008 R2 images in Azure Infrastructure as a Service. Activate Azure Hybrid benefit when you provision SQL Server on Azure Virtual Machines images from the Azure Marketplace. Second feature is high performance virtual machines for SQL Server on Linux and Windows. So you can take advantage of SQL Server virtual machines with industry leading performance. Choose from images with Windows Server, Red Hat Enterprise Linux, SUSE Enterprise Linux Server, or Ubuntu Linux. Gain co-located integrated support for your SQL workloads with Red Hat and SUSE. The third feature is built-in security and manageability. So you can ease maintenance with automatic security updates and restore your database to a specific point in time with Azure Backup. Help protect your data at rest and in motion with the database rated as least vulnerable over the last 9 years in the cloud with the most global, national, and industry certifications. The second member in the family is Azure SQL Managed Instance. So part of the Azure SQL Service portfolio, Azure SQL Managed Instance is the intelligent, scalable cloud database service that combines the broadest SQL Server engine compatibility with all the benefits of a fully managed and evergreen platform as a service. With SQL Managed Instance, confidently modernize your existing apps at scale by combining your experience with familiar tools, skills, and resources and do more with what you already have. Azure Arc enabled SQL Managed Instance is now in preview. You can run this service on-premise on any infrastructure of your choice with Azure Cloud benefits like elastic scale, unified management, and a cloud billing module while staying always current. Some of its features are always operate on the latest version of SQL. So SQL Managed Instance is built on the SQL Server engine. It's evergreen, meaning it's always up to date with the latest SQL features and functionality. Never worry about updates, upgrades, or end of support again. Second is fully managed and optimized for DBA productivity. So boost productivity and operate more efficiently by letting the service perform time-consuming and complex tasks on your behalf. Features like built-in high availability, disaster recovery, and automated backups ensure your data is available when you need it, while AI-powered automatic tuning optimizes performance for you. SQL Managed Instance combines all the best of SQL Server with the financial and operational benefits of the platform as a service. And the third feature is maintain SQL Server application compatibility. So accelerate application modernization with the latest SQL Server capabilities in the cloud. SQL Managed Instance provides an entire SQL Server instance within a managed service, so you can continue to use familiar tools and SQL Server features like cross-database queries and link servers. SQL Managed Instance maintains the highest compatibility labels, so you can move your on-premises workloads without worrying about application compatibility or performance changes. And the third member in the family is Azure SQL Edge. So Azure SQL Edge is an optimized relational database engine geared for IoT and IoT Edge deployments. It provides capabilities to create a high-performance data storage and processing layer for IoT applications and solutions. Azure SQL Edge provides capabilities to stream, process, and analyze relational and non-relational data such as JSON, graph, and time series data, which makes it the right choice for a variety of modern IoT applications. Azure SQL Edge is built on the latest version of the SQL Server database engine, which provides industry-leading performance, security, and querying processing capabilities. Since Azure SQL Edge is built on the same engine as SQL Server and Azure SQL, it provides the same Transact SQL programming surface area that makes development of applications or solutions easier and faster and makes application probability between IoT edge devices, data centers, and cloud straightforward. So there are two different deployment models in Azure SQL Edge. So the first one is connected deployment through Azure IoT Edge. Azure SQL Edge is available on the Azure Marketplace and can be deployed as a module for Azure IoT Edge. Second is disconnected deployment. So Azure SQL Edge container images can be pulled from Docker Hub and deployed either as a standalone Docker container or a Kubernetes cluster. So some of the features of Azure SQL Edge are built-in data streaming and time series within database machine learning and graph features for low latency analytics. Then data processing at the edge for online, offline, and hybrid environments to overcome latency and bandwidth constraints. Next is deploy and update from the Azure portal or your enterprise portal for consistent security and trunk key management. Last one is simplified pricing with no upfront cost and subscription offers as low as $60 per year per device. So the fourth and the major family member of Azure SQL family is Azure SQL Database, which we're going to briefly understand further. First, let's understand why one need an Azure SQL database extensively. I will tell you the top 5 benefits that companies are realizing with SQL database. So the first one is scalability and beyond. Flexible service plans for SQL database meet the need for both big and small business users. SQL is no longer way out of reach for smaller operations because the pricing structure allows users to pay as little as $4.99 per database per month with a maximum storage set at 150 GB per database. That's a lot of space for very small cost. Second is high speed and minimal downtime. So high availability architecture mean high speed connectivity and data retrieval as well as low downtime at your organization. There's nothing worse than stopping business because your technology can't keep up, and that is no longer a problem with SQL database. Secondly, companies can add application instances as needed through sharding. For example, sharding is a type of database partitioning that separates very large databases into smaller, faster, more easily managed parts called data shards. Not only can you spin nodes up and down on demand, you can leverage a federation infrastructure to scale more easily without affecting other areas of the server. SQL Azure Federation Data Migration Wizard can further automate this process, which impacts your organization and the employees much less. Lastly, there are multiple levels of implementation that you can benefit from. If you just need a website and a database, you can hitch a SQL Azure instance to an Azure website and you are done. If you need a full-blown virtual machine now or even down the road, you can get that as well. You can even use a locally deployed instance of SQL Server in the virtual machine instead of SQL Azure. These implementation options help make your company more adaptable to the inevitable changes it undergoes on a regular basis. With SQL Azure, you are not stuck. You are a foundation that encourages growth while working with it. Third is improved usability. So SQL developers are familiar with all things SQL, and SQL database can be updated with SQL CMD or the SQL Server Management Studio. Better yet, there is no coding required. Using a standard SQL, it's much easier to manage database systems without having to write or update a huge amount of code. Fourth, time is on your side. With no administrative duties on your physical location, employees can take time for strategic work to advance, grow all around business success. When your database is hosted in the cloud, you don't have to deal with setting up SQL Server, appropriating databases, and dealing with physical machine maintenance and upkeep. All of this results in better alignment of your organization and ultimately more time on your side. Fifth and the last one is easy to use migration tools. Ramp up time with SQL database is now easier than ever and free. SQL data synchronization allows you to either synchronize your SQL Server stored data or migrate that data without having to worry about the cost to migrate by syncing gigabyte size tables. Now that you know why we need Azure SQL database, let's briefly understand what actually it is. The basic fundamental building block that is available in Azure is the SQL database. Azure SQL Database is fully managed platform as a service database engine that handles most of the database management functions such as upgrading, patching, backups, and monitoring without user involvement. Azure SQL Database is always running on the latest stable version of the SQL Server Database Engine and patched OS with 99.99% availability. Platform as a service capabilities that are built into Azure SQL Database enable you to focus on the domain-specific database administration and optimization activities that are critical for your business. With Azure SQL Database, you can create a highly available and high-performance data storage layer for the applications and solutions in Azure. SQL Database can be the right choice for a variety of modern cloud applications because it enables you to process both relational data and non-relational structures such as graphs, JSON spatial, and XML. Azure SQL Database is based on the latest stable version of the Microsoft SQL Server database engine. You can use advanced query processing features such as high-performance in-memory technologies and intelligent query processing. In fact, the newest capabilities of SQL Server are released first to SQL Database and then to SQL Server itself. You get the newest SQL Server capabilities with no overhead for patching or upgrading, tested across millions of databases. SQL Database enables you to easily define and scale performance within two different purchasing models, and that we will discuss further. So Microsoft handles all patching and updating of the SQL and operating system code. You don't have to manage the underlying infrastructure. So now let's understand the deployment models. Azure SQL Database provides the following deployment options for a database. So the first one is managed instance. This is primarily targeted towards on-premises customers. In case if we already have a SQL Server instance to our on-premises data center and you want to migrate that into Azure with minimum changes to our application and the maximum compatibility, then new will go to the managed instance. Second is single database. So single database represents a fully managed, isolated database. You might use this option if you have modern cloud applications and microservices that need single reliable data source. A single database is similar to a contained database in the SQL Server database engine. Last one is Elastic Pool. So Elastic Pool is a collection of single databases with a shared set of resources such as CPU or memory. Single databases can be moved into and out of an Elastic Pool. Now let's understand the purchasing models. So SQL Database offers the following purchasing models you can see here. So the first one is vCore based purchasing model, which is new and it offers a totally different approach to sizing your database. It is easier to translate local workloads to a vCore based model because the components are what we are used to. The vCore based model lets you choose the number of vCores, the amount of memory, and the amount and speed of storage. The vCore based purchasing model also allows you to use Azure Hybrid benefit for SQL Server to gain cost savings. Then the next one is DTU based purchasing model. So the DTU based purchasing model offers a blend of compute, memory, and input output resources in three service tiers to support light to heavy database workloads. Compute sizes within each tier provide a different mix of these resources to which you can add additional storage resources. As you can see from the following diagram, the DTU model offers a pre-configured and predefined amount of compute resources. vCore is all about independent scalability where you can look into a specific area such as the CPU, core count, and memory resources, something that you cannot control at the same granular level when using the DTU based model. So the third one is the serverless model, which automatically scales compute based on workload demand and bills for the amount of compute used per second. The serverless compute tier also automatically pauses databases during inactive periods when only storage is built and automatically resumes databases when activity returns. Now let's see the service tiers for Azure SQL Database. So the first one is general purpose or standard model. It is based on a separation of computing and storage service. This architecture model depends on the high availability and reliability of Azure Premium Storage that transparently copies database files and guarantees for zero data loss if underlying infrastructure failure happens. Second is business critical or premium service tier model. It is based on a cluster of database engine processes. Both the SQL database engine process and underlying MDF or LDF files are placed on the same node with locally attached SSD storage providing low latency to a workload. High availability is implemented using technology similar to SQL Server always on availability groups. So the third one is hyperscale service tier model. It is the newest service tier in the vCore based purchasing model. This tier is a highly scalable storage and compute performance tier that leverages the Azure architecture to scale out the storage and compute resources for an Azure SQL database beyond the limits available for the general purpose and business critical service tiers. Now let's understand the self-contained services in Azure SQL Database. So Azure SQL Database is a database as a platform service designed for applications that will use database as self-contained service. Databases can be grouped together to simplify management options or share the resources. There are different options that can be used to bound databases in the group. So the first one is databases in logical server. So logical server is a default container for Azure SQL database. Logical server enables you to perform administrative tasks across multiple databases, including specifying regions, login information, firewall rules, auditing, threat detection, and failover groups. All databases within the server are self-contained with independent service tiers that can be specified per each database. Each database can be independently scaled up or down by changing performance tiers on the database, which will not affect other databases. Databases cannot share resources, and each database has guaranteed and predictable performance defined by its own service type. Some server level specific features such as cross database querying, linked servers, SQL agent, service broker, or CLR are not supported in Azure SQL database placed in logical servers. Second one is databases in elastic pool. So databases need to share resources can be stored in elastic pools instead of the logical server. All databases within the elastic pool share the same resources associated with the elastic pool label. Currently, there are three service tiers in the elastic pools: basic, standard, and premium. Databases within the elastic pools cannot have different service tiers because they share resources that are assigned to the entire pool. Resources usage in one database might affect others. However, you can specify reserve performance for the database in the pool that will guarantee a minimal amount of resources that the database can have. This model is a good choice for databases that have performance peaks or heavy usage in different time periods because the amount of resources associated with the pool can be assigned to the databases that need them while the others are inactive. Elastic Pool model is designed for resource sharing, and it still does not support server level features such as SQL agents, service broker, etc. These are other mechanisms that can be used as a replacement of these features, such as elastic jobs and elastic queries instead of some server level features. So now let's look at some of the key features of Azure SQL database. The first one is extensive monitoring and alerting capabilities. So Azure SQL database provides advanced monitoring and troubleshooting features that help you get deeper insights into workload characteristics. These features and tools include the built-in monitoring capabilities provided by the latest version of the SQL Server database engine. They enable you to find real-time performance insights. Also, platform as a service monitoring capabilities provided by Azure that enable you to monitor and troubleshoot a large number of database instances. Query Store, a built-in SQL Server monitoring feature, records the performance of your queries in real time and enables you to identify the potential performance issues in the top resource consumers. Automatic tuning and recommendation provides advice regarding the queries with the regressed performance and missing or duplicated indexes. Automatic tuning in SQL database enables you to either manually apply the script that can fix the issues or let SQL database apply the fix. SQL database can also test and verify if the fix provides some benefit and retain or revert the change depending on the outcome. In addition to query store and automatic tuning capabilities, you can use standard DMVs and XC event to monitor the workload performance. Azure provides built-in performance monitoring and alerting tools combined with performance ratings that enable you to monitor the status of thousands of databases. Using these tools, you can quickly assess the impact of scaling up or down based on your current or projected performance needs. Additionally, SQL database can emit metrics and resource logs for easier monitoring. You can configure SQL database to store resource usage, workers, and sessions and connectivity into one of these Azure resources. So these resources are, first one is Azure Storage. So for achieving vast amounts of telemetry for a small price. So the second one is Azure Event Hubs for integrating SQL database telemetry with your custom monitoring solution or hot pipelines. And the third one is Azure Monitor Logs for a built-in monitoring solution with reporting, alerting, and mitigating capabilities. So the second feature is availability capabilities. So Azure SQL database enables your business to continue operating during disruptions. In a traditional SQL Server environment, you generally have at least two machines locally set up. These machines have synchronously maintained copies of the data to protect against a failure of a single machine or component. This environment provides high availability, but it doesn't protect against a natural disaster destroying your data center. Disaster recovery assumes that a catastrophic event is geographically localized enough to have another machine or set of machines with a copy of your data far away. In SQL Server, you can use always-on availability groups running in asynchronous mode to get this capability. People often don't want to wait for replication to happen that far away from committing a transaction, so there's potential for data loss when you do unplanned failovers. So databases in the premium and business critical service tiers already do something similar to the synchronization of an availability group. Databases in lower service tiers provide redundancy through storage by using a different but equivalent mechanism. Like built-in logic helps protect against a single machine failure. The active geo replication feature gives you the ability to protect against disaster where a whole region is destroyed. Azure Availability Zones tries to protect against the outage of a single data center building within a single region. It helps you protect against the loss of power or network to a building. In SQL database, you place the different replicas in different availability zones. In fact, the service level management of Azure, powered by a global network of Microsoft managed data centers, helps keep your app running 24/7. The Azure platform fully manages every database and it guarantees no data loss and a high percentage of data availability. Azure automatically handles patching, backups, replication, failure detection, underlying potential hardware, software, or network failures, deploying bug fixes, failovers, database upgrades, and other maintenance tasks. Standard availability is achieved by a separation of compute and storage layers. Premium availability is achieved by integrating compute and storage on a single node for performance and then implementing technology similar to always-on availability groups. In addition, SQL database provides built-in business continuity and global scalability features. These include automatic backups. So SQL database automatically performs full differential and transaction log backups of database to enable you to restore to any point in time. For single databases and pooled databases, you can configure SQL database to store full database backups to Azure storage for long-term backup retention. For managed instances, you can also perform copy-only backups for long-term backup retention. Second is point-in-time restore. So all SQL database deployment options support recovery to any point in time within the automatic backup retention period for any database. Third one is active geo replication. The single database and pool databases option allow you to configure up to 4 readable secondary databases in either the same or globally distributed Azure data centers. For example, if you have a service as a platform application with a catalog database that has a high volume of concurrent read-only transactions, use active geo-replication to enable global read scale. This removes bottlenecks on the primary data due to read workloads. For managed instances, use auto failover groups. Fourth is auto failover groups. All SQL database deployment options allow you to use failover groups to enable high availability and load balancing at global scale. This includes transparent geo-replication and failover of large sets of databases, elastic pools, and managed instances. Failover groups enable the creation of globally distributed service as a platform applications with minimal administration overhead. This leaves all the complex monitoring, routing, and failover orchestrations to SQL database. Fifth and the last one is zone redundant databases. SQL database allows you to provision premium or business critical databases or elastic pools across multiple availability zones. Because these databases and elastic pools have multiple redundant replicas for high availability, placing these replicas into multiple availability zones provides higher resilience. This includes the ability to recover automatically from the data center scale features without data loss. So the next feature is built-in intelligence. With SQL database, you get built-in intelligence that helps you dramatically reduce the costs of running and managing databases, and that maximizes both performance and security of your application. Running millions of customers' workloads around the clock, SQL database collects and processes a massive amount of telemetry data while also fully respecting customer privacy. Various algorithms continuously evaluate the telemetry data so that service can learn and adapt with your application. So in its process of work, first step is automatic performance monitoring and tuning. So SQL database provides detailed insight into the queries that you need to monitor. SQL database learns about your database patterns and enables you to adapt your database schema to your workload. SQL database provides performance tuning recommendations where you can review tuning actions and apply them. However, constantly monitoring a database is hard and tedious task, especially when you are dealing with many databases. Intelligent Insights does this job for you by automatically monitoring SQL database performance at scale. It informs you of performance degradation issues, it identifies the root cause of each issue, and it provides performance improvement recommendations when possible. Managing huge number of databases might be impossible to do efficiently even with all available tools and reports that SQL database and Azure provide. Instead of monitoring and tuning your database manually, you might consider delegating some of the monitoring and tuning actions to SQL database by using automatic tuning. SQL database automatically applies recommendation, tests, and verifies each of its tuning actions to ensure the performance keeps improving. This way, SQL database automatically adapts to your workload in a controlled and safe way. Automatic tuning means that the performance of a database is carefully monitored and compared before and after every tuning action. If the performance doesn't improve, the tuning action is reverted. Many of our partners that run service as a platform multi-tenant apps on top of SQL database are relying on automatic performance tuning to make sure their applications always have stable and predictable performance. For them, this feature tremendously reduces the risk of having a performance incident in the middle of the night. In addition, because part of their customer base also uses SQL Server, they are using the same indexing recommendations provided by SQL database to help their SQL Server customers. Two automatic tuning aspects are available in SQL database. So first one is automatic index management, which identifies indexes that should be added in your database and indexes that should be removed. Second one is automatic plan correction, which identifies problematic plans and fixes SQL plan performance problems. So the next step in the process of work is adaptive query processing. You can use adaptive query processing, including interleaved execution for multi-statement table-valued functions, batch mode memory grant feedback, and batch mode adaptive joins. Each of these adaptive query processing features applies similar learn and adapt techniques, helping further address performance issues related to historically untraceable query optimization problems. So the next feature is advanced security and compliance. SQL database provides a range of built-in security and compliance features to help your application meet various security and compliance requirements. Note this that Microsoft has certified Azure SQL database against a number of compliance standards. For more information, see the Microsoft Azure Trust Center, where you can find the most current list of SQL database compliance certifications. So built-in security and compliance features. So there are certain built-in security and compliance features. So the first one is advanced threat protection. Azure Defender for SQL is a unified package for advanced SQL security capabilities. It includes functionality for managing your database vulnerabilities and detecting anomalous activities that might indicate a threat to your database. It provides a single location for enabling and managing these capabilities. So there are two kinds of assessment in advanced threat protection. The first one is vulnerability assessment. This service can discover, track, and help you remediate potential database vulnerabilities. It provides visibility into your security state and includes actionable steps to resolve security issues and enhance your database fortifications. Second is threat protection. So this feature detects anomalous activities that indicate unusual and potentially harmful attempts to access or exploit your database. It continuously monitors your database for suspicious activities and provides immediate security alerts on potential vulnerabilities, SQL injection attacks, and anomalous database access patterns. Threat detection alert provide details of the suspicious activity and recommend action on how to investigate and mitigate the threat. So under this, the second subfeature is auditing for compliance and security. So auditing tracks database events and writes them to an audit log in your Azure storage account. Auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that might indicate business concerns or suspected security violations. So third one is data encryption. SQL database helps secure your data by providing encryption. For data at rest, it uses transparent data encryption. For data in use, it uses always encrypted. Fourth feature is data discovery and classification. Data discovery and classification provides capabilities built into Azure SQL database for discovering, classifying, labeling, and protecting the sensitive data in your databases. It provides visibility into your database classification state and tracks the access to sensitive data within the database and beyond its borders. And the last one is Azure Active Directory integration and multi-factor authentication. So SQL database enables you to centrally manage identities of database user and other Microsoft services with Azure Active Directory integration. This capability simplifies permission management and enhances security. Azure Active Directory supports multi-factor authentication to increase data and application security while supporting a single sign-in process. The last major feature is easy to use tools. SQL database makes building and maintaining applications easier and more productive. SQL database allows you to focus on what you do best, building great applications. So you can manage and develop an SQL database by using tools and skills you already have. So the first tool is the Azure portal, a web-based application for managing all Azure services. Second is Azure Data Studio, a cross-platform database tool that runs on Windows, Mac OS, and Linux. Third is SQL Server Management Studio, a free downloadable client application for managing any SQL infrastructure from SQL Server to SQL database. Fourth is SQL Server Data Tools in Visual Studio, a free downloadable client application for developing SQL Server relational databases in Azure SQL database, integration service, packages, analysis service, data models, and reporting services reports. And the last tool is Visual Studio Code, a free downloadable open source code editor for Windows, Mac OS, and Linux. It supports extensions, including the MS SQL extension for querying Microsoft SQL Server, Azure SQL Database, and Azure Synapse Analytics. Now let's look at some of the use cases for Azure SQL Database. So the first one is developer or test environment. It's an important use case for replicating or migrating data to SQL hosted on Azure is for developer or test environments. Before deploying to the production environment, it is pertinent that the data is tested against developer or test environments. Azure SQL databases can act as a target for just such environments. The live production environment can be replicated to the developer or test environment using a database copy. Second is business continuity. One of the most important use cases for SQL on Azure is using it as a DR target to maintain business continuity. Azure SQL databases can provide an SLA of up to 99.99% by maintaining several copies of the data. This provides business continuity as it allows you to restore geo-redundant copies of the data or use active geo-redundant copies as failover points in case of outages at data centers or in regions. Besides Azure SQL databases, you can also use availability groups to fulfill business continuity demands. Not only can you use availability groups in Azure SQL virtual machines, but also use Azure SQL virtual machine instances as a target for high availability and disaster recovery. Third is scaling out read-only workloads. Apart from providing BC or DR capabilities, active geo replication can also be used to offload read-only workloads such as reporting jobs to secondary copies. You can also extend on-premises SQL Server instances using readable always-on replicas. Fourth is backup and restore. Azure SQL databases are backed up automatically on a regular basis, and there are no storage costs for up to 200% of the maximum provisioned database storage. You can restore backups to any point in time going back to the retention period, which is determined by the Azure SQL Service tier in use. On-premises SQL Server databases and transaction logs can also be backed up directly to Azure using the backup to URL feature and stored in Azure storage. Azure SQL databases can also be stored on local storage by exporting them to backpack files, means BAC PAC files. And the last use case is advanced analytics. Another important reason for hosting SQL in Azure is to make use of Azure's advanced analytics platforms such as Azure Storage Blob and Azure Data Lake Store. Common scenario with advanced analytics is when users reference data from various data sources, use Azure Data Lake Store as the staging area, perform transformation activities using Hive or Spark, and finally load the data into Azure Data Warehouse for business intelligence and reporting. Now that you have a theoretical understanding of Azure SQL database, let's now see a deployment of a SQL database service on Microsoft Azure. We will also connect this database with SQL Management Server as well as with Azure Data Studio. So let's move ahead. You can just simply go to the Azure portal. If you don't have an account on Azure, what you can do is you can create a free account, like can start free here, and you will get a 12 months free services access. As well as if you are from India, the currency will be around like 14,500 INR, means Indian rupees. Free currency we will get for free use. That's the amount you will get. So I already have an account, so I will just log in from here. No, I don't want to. I will just go to Microsoft Azure here. This is the portal. So I don't want to buy. See, these are the credits it is showing. You get 14,500 credits. I have used some of the credits and this much are left. So what you can do is you can go to SQL databases right now because it is, I have a pin here. But what you can do is you can go to SQL databases from here, like here, or you can search it from here, SQL database. Yeah. Now let's create the database from here. So free trial is here. We have chosen this. Then we can choose the resource group. We can create one group. So let's create with a new one. So let's give the name as resource SQL demo. Okay. So a new resource has been created. Then enter database name. You can give some name to like demo SQL. So yeah, that's okay. So give the server name also. So create a new server. The server's name. So let's give it like, remember these names. SQL demo server I have given. So the specified server name is already in use. Okay, we can give like SQL demo server 662. But you have to remember this. Don't forget this. Like login information. Okay. So you can give some server admin login. So Azure admin will be okay, I think. Yeah. Now let's move ahead to give a password. Don't forget these information. We will require these information later on in this process. And choose your region also. So my region is Central India, so it will be Asia Pacific Central India. Just yeah. So okay, the next process is if you want to use SQL Elastic Pool. Right now we don't require, so we will choose no. If you want to, then you can choose yes. Then we can configure the database and storage also. So these are the plans, like I have explained you: basic, standard, premium. The service tiers are there. Similarly, purchasing models are there. Vico purchasing models are there. General purpose, hyperscale, and business critical. These also I have explained you. So like whichever you choose, on the basis of that it shows the price. So right now it's costing 29,059, but we don't require that much big. So you can choose it from here also, like not available because it's the free tier account. That's why we don't have the premium version. So you can use the standard one. So in this standard one, if you decrease the storage, then it will also decrease the price. Not in this manner. Like from, you can go to basic. Here you get 2 GB and the price decreased. You can choose for 1 GB also, but price will remain the same. So you can go to 2 GB. So we will choose the basic one because we don't require that much of configuration. So just apply from it. Just review and create a simple review plan. So yeah, create. So it's getting created from the process. It takes a little time, so that's why it's taking a time. Few minutes it takes. So you can see the deployment is complete. So you can go to resource SQL demo. So we have came to resource. Here you see the server is created, but you have to refresh once again. Just a second. Where is the database? Let's refresh again. I don't know. It's get created usually. Yeah. So you can see. Have to refresh it. So it will takes a little time. So database is also created now. So what we can do from here is, first step is you have to create the firewall. So you can go to database. So you have to set the firewall, set firewall servers. You can go from here, set the firewall. So you have to choose the, like all these client IP it is given from start IP and end IP. So you can just, you have to add the client IP. So it has been added. So you have to give it from 0 to 255. Complete you have to give 255. So save and just go back. Then you can see different cool features are given on the left side of this dashboard. So you can go to the query editor. This is here you can like connect your database to the browser and you can configure. And then there is compute and storage. If you have like, you can, yeah, not a problem. So compute and storage is given. If you want to like change your plan, purchasing model and everything, then you can change it from here again. Like all the things are given here, you can again change it. That's not a problem. Then there are like connection strings. No problem. Then you can go to connection strings where you can connect your and make connection to the strings. Like there's ADO.NET, or if you are working on Java, then JDBC is there, ODBC is there, PHP, Go, everything is there. It's quite cool feature. Then they are synchronous to other database where you can synchronize to other databases also. Then also you can like add Azure search also. Then there are different security features are there, advanced security features are there for data also. Advanced data security features are given here. Now what we can do is, major thing we have to do is we have to connect it to the management SQL server. So if you don't have a management SQL server, you can download it from here. You can just give management SQL server and just go here and download it from here. It's given. You can just click here and it will get downloaded. It will ask for a restart. It will restart the computer and all the settings will be saved in your computer. Then you can start using SQL server. I already have downloaded it. So I already have downloaded it. So we can just go here. I have it pinned here. So Microsoft SQL Server Management. So yeah, you have to give your server name. So let's see the server name first. Here it is. No, from database only. So my server name is given. So you can just copy it from here, paste it here. You can just select the SQL Server authentication here and give your login also. So remember the login. I told you to remember the login password. So mine is Azure admin password. You can just connect it from here. So yeah, we got it here. So we can just choose the databases. You can see the demo SQL. We can find our database here, and the different tables and everything is there. So we can just start the new query from here. We can create the table. So let's create the table. We can create table with the name persons. So yeah, it will be enough. Let's now execute it. So you can see command completed successfully. We can now insert values into it. So like before that, we can view in tables also. The table where we create the name of persons spending. So yeah, you can see persons is created. So let's now insert values. You can give like give my name. So 26 extract from persons. Let's execute now. Oh, sorry, it's a little mistake. Let's execute now. So yeah, you can see we have got the table, contents, everything is there. Now we can also see for Azure Data Studio also. So we will just go to Azure Data Studio. It's like you have a Visual Studio Code also. Similarly, there's Azure Data Studio. You can start the new connection. Then we have to give the server name here, just like we have the server name there. So what was the server name? Let's copy it from here. So yeah, just give here, and then we will choose the SQL login. Use the name Azure admin, the password. Yeah, we can just remember the password, not a problem. Then database we have to select. So what was the name of the database? Demo SQL. That's why it's showing here. Yeah, so we connected from here. Yeah, we are here. Like different features are given, like new query, new notebook, just like you have in Visual Studio Code. In that way, it is given, and all the other, like it has a very good UI also. Here we go to our database. Persons it is showing. Just maximize it. Okay, yeah, so it's open now. Just like you can give it here, also all the details it is showing, like it's been executed and details are shown here. So this is how it looks like. Also, one cool thing about Azure Data Studio is you can go here and you can see like it actually remembers all the databases. Like this one, it remembers. This one I have closed actually. This database I have closed. I have created it some time back, but it still remembers the databases. If you give the Azure like server ID, na, so like it will remember all the databases, like from where initially we have selected, na, from there on. So this is how it looks like. Let's go back to Azure one. We have understood how to do it in Azure Data Studio also, and how to connect it with the management SQL server also. So there are certain other features also you can see here for performance overview, like how it's working and to track the performance and everything. Also the auditing and things are given here. So just like these are the things, but I have mainly told you about the purchasing models and deployment models and how service tiers are there and how we can create a database connected with management SQL server as well as Azure Data Studio. I think it might be a little hectic, but I have explained you in a little simpler manner. So please try it with your hands-on experience. Like take your hands-on experience also by trying it on deploying Azure SQL database on this Azure portal.
Azure Data Lake Storage. So what is Azure Data Lake Storage? Azure Data Lake Storage is a repository that stores large amount of raw data in its natural format until it is needed for analytics application. So why is it named as Data Lake? Well, James Dixon, the Chief Technology Officer of Pentaho, is the person who has generally been credited with the coining of the term data lake. According to him, he described a data mart that is a subset of a data warehouse as akin to a bottle of water which is cleansed, packaged, and structured for easy consumption, while a data lake is more likely a body of water in its natural states. Data flows from the streams, that is the source of the system, to the lake. Users have access to lake to examine, take samples, or dive in. So, a data lake is a centralized repository designed to store, process, and secure large amount of structured, semi-structured, and unstructured data. It can store data in its native format and process any variety of it, ignoring the size limits. Next is how to create a data lake storage. For this, we'll have a practical demo to have a better understanding. So the first step to work on any Azure services is to first sign in. So first we need to sign in. Make sure you do have an Azure account. so that you can have the access to different Azure services. So let's sign in. Stay signed in. So once you sign in, you enter to this dashboard. So you can see here, this is a dashboard of your account, and you can see different kinds of Azure services like storage accounts, monitors, virtual machine, resource group, SQL database, SQL managed instances. And also you can see your subscriptions and different types of resource group you have created and all other stuff. So let's quickly get started. First, we need to go to create a resource. So once you come here, you can see popular Azure services. So like virtual machine, Kubernetes services, Cosmos DB, and rest other. So for us, we need to go to storage account. Once you click here, so you enter to create a storage account. Here, we need to create a resource group. So first of all, what do you mean by resource group? A resource group is a container that holds related resources for an Azure solution. It can include all these resources for the solution or only those resources that you want to manage as a group. So let's create a new resource group. Let's name it as Demo Data Lake 1. Okay. And once you create a resource group, so you come to a storage account main. So a storage account contains all of your Azure storage data objects, including blobs, file shares, queues, tables, and disks. So let's name it as Marshmallow123. So once you have named your storage account, we go to the advanced section. Here we will directly move to Data Lake Storage Generation 2. So what do you mean by Data Lake Storage Generation 2? Data Lake Storage Generation 2 is designed to deal with this variety and volume of data at exabit scale while securely handling hundreds of gigabytes of true output. With this, you can use Data Lake Storage Generation 2 on the basis of both real-time and batch solution. So here we will enable the hierarchical namespace. Once we enable it, we'll click on Review plus Create. So it will take few minutes to validate all your details. Once validation is passed, you just click on Create. So it's now getting ready to deploy. So here you can see your Marshmallow 123 is created and now it is getting ready for deployment. Here you can see deployment is in progress. Once it gets ready, so we will be working on it. Here you can see your deployment is complete. Now what you're gonna do is we'll move on to go to resources. Now here you can see your details, your resource group details, the whole storage account details basically, and even you can see the properties enabled with it. So here we have data lake storage, file service, queue service, table service, networking, security. So after this we'll quickly go to containers and we'll create a new container for our storage account. So let's click on container and we give it a name to it. Make sure you give a name. It should be in lowercase because they don't accept the uppercase. So let's keep it demo and create. So yeah, you can see your container has been created. Let's click on it. So here you can see there are no results as we haven't added any stuff. So let's upload. For this, you can either upload it from Azure portal or else you can also go to Storage Explorer. So let's see how do we do on the Azure portal. So once you come here, you can just click on select a file. Let's take any picture. Let's see, we'll upload a picture. So here you can see aws3.png. Let's upload it. So yeah, you can see AWS PNG has been uploaded in your container. Same as we can do on Storage Explorer too. For that, you need to download a Storage Explorer in my case, I have already downloaded the Storage Explorer. So let's quickly go into it. So here also make sure you are signed in so that you can see all your containers and resource group which you have created. So here you can see my storage account, that is Marshmallow123, which we have created recently. Under this, we'll go and find our container. Yeah, so here we go to blob containers and we can see our demo. So here you can see the image file which we had uploaded through our Azure portal. Now we'll upload a file and a folder both. Let's see. So let's upload a file first. So you click on upload files, and then you select a file. Let's take any file. Let's take a picture again. So AWS 4. Let's take this an image. So now here you can see your image is transferring from your path to our demo. Yeah, so here your image file is uploaded. So as we said, we can upload any kind of data, maybe structured or unstructured. So let's check out by uploading a folder. So here you go with the same process and you select your folder. Let's take any folders. Let's see if we do have any folder. Okay, I'll just take any one of my folders and just click and upload. So your folder is also being uploaded over here. And once your folder is uploaded, now you can see the inside resources into it. So here there were different files, text, image, all of them are there. You can access it from here itself. And you can see other operations as well. If you want to download any of the file or a folder, you can do it. Or if you want to open it, let's open it, any of the files. Let's see if it is getting opened or no. Okay, yes. So yeah, you can see this file has been opened. Now, if you want to download this file, let's download sequence. So we'll download it and just put it in downloads. Let's see if it is downloaded or no. Apply to apply. So yeah, it tells your download is completed. Let's see if you find it or no. We go to our file and downloads, and here, see, now I had downloaded. This is the file which I had downloaded through our Storage Explorer. So this is how you manage your data through Azure Data Lake Storage. So apart from this, you can also give permissions to different users, like whichever file, if you want to give an access to a particular user, then you can also give permission to them that they can either read, write, and access the whole file or a folder. So for that, you just need to click on a file or a folder and right click, and you just see here manage access control lists. So once you come here, so you can see there are different owners, super user, owner, and all. So here I can add an owner, like for this file, who can just get an access to it. So you can find out any name. If you find out any relatable person or a user, then you can give an access to that. Currently, I don't have anyone, so I won't be able to show you that. But yes, this is how you add or give permission to different users. You can also do it with a folder, or else you can also do it with the whole container as well. If you want to share your containers with different people or different users, then you can easily share them. So here also you just go right click and just come to manage access control and just give them the access. Click on add and find out the person whom you want to give the access to, and just after that, once you give them the permission, here you can see if you want to permit them for only read or only write, or if you want to give read and write, or all of the three. So you can just give them the permissions accordingly and click on OK, and then the particular user gets the access to all your files and folders.
So this is how we create and work with Azure Data Lake Storage. Now,
Let us see the comparison between Azure Blob Storage and the Data Lake Storage. So here are some of the comparisons between Azure Data Lake Storage and Azure Blob Storage. Azure Data Lake Storage is a technique of planning and control of the time, whereas Azure Blob Storage is an object store with a flat namespace. Azure Data Lake is an optimized storage for big data analytics workload, whereas Azure Blob Storage is basically a general purpose object store for a wide variety of storage scenarios, which also include big data analytics. In Azure Data Lake Storage, the APIs are over HTTPs only, whereas in Blob Storage, the REST API is over the HTTP as well as the HTTPS. In Azure Data Lake Storage, there is no limits on the account, but in Azure Blob Storage, there are specific limits for container sizes and the files in the blob. So these were the major points which differentiate Azure Blob Storage with Azure Data Lake Storage. At last, we come to the use cases. There are many use cases of Data Lake Storage, out of which we'll discuss about 4. So at first, business intelligence on Data Lake Storage. So Data Lake Storage dramatically improves the speed for ad hoc queries, dashboards, and reports. You can run existing BI tools on lower cost data lakes without compromising performance or data quality. It also avoids costly delays, adding new data sources and the reports. At second, we see cloud data lake migration. Here, we can optionally deploy new applications to the cloud using data lake storage such as S3 or ADLS. You can also migrate from older on-prem data lake environments that are expensive and difficult to maintain while ensuring agility and flexibility. Next, data science on the data lake storage. Here, you can accelerate data science on data lake storage with simplified data exploration and feature engineering. Dramatically, it improves performance, making data scientists and engineers more efficient, resulting in high-quality analytical models. At last, data architecture modernization. So here you can avoid reliance on proprietary data warehouse infrastructure and the need to manage the cubes, abstract, and aggregation tables. You can run operational data warehouse queries on low-cost data lakes, offloading the data warehouse at your own pace.
So Power BI is a BI tools. Okay, the business intelligent tools hosted on the cloud machines, cloud services. It's maintained by Microsoft corporations. It's a Microsoft tools, right? MS tools, Microsoft tools. It's entirely free of cost. We no need to pay any licensing cost or anything for this Power BI. It's a free. It's available under Microsoft stores. So this Power BI is mainly for non-technical people. Suppose if you're a business user, if you have a data analyst, if you have a business analyst, right? So if you want to perform some of the aggregate level data, okay, I want to see the data from summary level, or I want to perform some of the data analysis, or I want to visualize some of the data in the graphical formats, or I want to share the data to the different peoples for different servers, different place, right? So for that, the Power BI is very well suited for non-technical users, business user. Okay, so these are the things we can do it on the Power BI. Okay, next we'll talk about Azure in ML. So how do we use this Azure in machine learning, right? So we have a lot of services are available in Azure, like we can integrate it. So basically, if you want to apply some filter or if you want to apply some selective filter independently, we can do it under Azure platform. Okay, I'll just quickly walk you through the Azure portal. Okay, so this is my cloud platform, like portal, Azure portals, right? So as I told you, we have a different services available. So if you go and check, right? So we have a SQL database, Cosmo DB for NoSQL database, right? And storage account like Azure Active Directory for this security things, right? And then monitor, cost management. So there are different services are available. So basically, before going to create a service, right? So we need to have the free account. So basically, this is a 1 month free account. you can able to create it. So like this, first of all, you have to go have the subscriptions. So the subscription means same as like what kind of subscription currently we're having. And as of now, I don't have any subscriptions. I'm going to create it. Like this is for the 12 months or subscription free. After that, we have to go and purchase it, either pay as you go, let it come. So that's the first one is a free trial. Like after that, we have to go pay as you go, right? As I told you, pay as you go means like depending on whatever we're using, right? We are paying for it. That's it. Okay, we are not once your application once you are done with the work, we can stop the services, right? So it means we're not paying for anything to the. It's not going to consume the cost. Okay, and then for the student also we have the 12 months free thing. We can use it. So first of all, you have to go to get a subscription. So once a subscription is created, we have to go and have the resource group, monitor a lot of things, right? So for different category wise, we talk about, right? We have a storage, we have a networking, we have a, what is called a database, right? So like this, we have machine learning also, we have a summer services. Suppose if you want to have the face API, face detection, computer visions, and then like for cognitive search, right? Like this for analytical, for Azure Databricks. So for that, everything for analytical kind of things, there are a lot of things, right? Power BI integrations. So we talk about Power BI integration, right? So for that, we have a separate analytical service. Okay. So we have a compute service. So compute service we talk about initially, right? So how do you want to execute it? Okay. How do we host we want it? And what is the availability? Which zone you want to store it? What is the disk storage? And virtual machines, virtual storage, like any image app services. So there are compute services, and then we have a container, we have a database level services, we have a DevOps kind of thing services. Everything we are having services on the cloud one.
Before knowing what is Azure Databricks, we must know what Databricks actually is. Well, according to the definition, Databricks is a web-based platform for working with Apache Spark that provides automated cluster management and IPython style notebooks. So basically, Databricks, developed by the creators of Apache Spark, is nothing but a web-based platform which is also one-stop product for all data requirements like storage and analysis. It was originally founded to provide an alternative to the MapReduce system and provide a just-in-time cloud-based platform for big data processing clients. It can derive insights using Spark SQL, provide active connections to visualization tools such as Power BI, ClickView, and Tableau, and also build predictive models using Spark ML. Databricks also can create interactive displays, text, and code tangibly. So, in short, it is an alternative to a MapReduce system. Databricks is now integrated with Microsoft Azure, Google Cloud Platform, and Amazon, making it easy for the business to manage a colossal amount of data and carry out machine learning tasks. As we got to know that Databricks is integrated with all the three cloud-based platforms, today we'll discuss on one of those, that is Azure Databricks. So let us understand what is Azure Databricks. Azure Databricks Lakehouse is a platform that offers a uniform collection of tools for building, deploying, sharing, and supporting enterprise-grade data solutions to a scale. It integrates with cloud storage and security in your cloud account and manages and deploys cloud infrastructure on your behalf. Azure Databricks supports Python, Scala, R, Java, and SQL, as well as data science frameworks and libraries including TensorFlow, PyTorch, and scikit-learn. Now that we have come to know what is Azure Databricks, let us understand why should we use Azure Databricks. Well, our customers use Azure Databricks to process, store, clean, share, analyze, model, and monetize their data sets with solutions from Power BI to machine learning. You can use Azure Databricks platform to build many different applications spanning data personas. Customers who fully embrace the Lakehouse take full advantage of the unified platform to build and deploy the data engineering workflows, machine learning models, and analytics dashboard that power innovations and insights across an organization. The Azure Databricks workspace provides user interfaces for many core data tasks, including tools, which we'll be discussing one by one. So, first is Optimize Spark Engine. It is a simple data processing on auto scaling infrastructure powered by highly optimized Apache Spark for up to 50x performance gains. Next is Machine Learning Runtime. It is a one click access to pre configured machine learning environments for augmented machine learning with state of the art and popular frameworks such as PyTorch, TensorFlow, and scikit-learn. We also have MLflow that is used to track and share experiments, reproduce runs, and manage model collaboratively from a central repository. Well, here you can use your preferred language including Python, Scala, R, Spark SQL, and .NET, whether you use serverless or provisioned compute resources, so that you can quickly access and explore data, find and share new insights, and build models collaboratively with the language and tools of your choice. In Azure Databricks, you have enterprise grade security, which is an effortless native security that protects your data where it lives and creates complaint, private, and isolated analytics workspace across thousands of users and database. Apart from that, it is also production ready. That means you can run and scale your most mission critical data workloads with confidence on a trusted data platform with ecosystem integration for CI/CD and monitoring. You also have collaborative notebooks through which you can quickly access and explore data, find and share new insights, and build models collaboratively with the languages and tools of your choice. And the most important thing, it has Delta Lake that brings data reliability and scalability to your existing data lake with an open source transactional storage layer designed for full data lifecycle. It has a native integration with Azure services. That means you can complete your end to end analytics and machine learning solution with deep integration with Azure services such as Azure Data Factory, Azure Data Lake Storage, Azure Machine Learning, and Power BI. Last but not the least, it has an interactive workspace. That means you can enable seamless collaborations between data scientists, data engineers, and business analysts. So these were the key features that makes Azure Databricks unique. Till now, we have got an idea about the Databricks and Azure Databricks and why are we using Azure Databricks. Now let us deep dive in by understanding how does Azure Databricks actually work. As I said, Azure Databricks is structured to enable secure cross-functional team collaboration while keeping a significant amount of backend services managed by Azure Databricks so you can stay focused on your data science and data analytics and data engineering tasks. It operates out of a control plane and a data plane. Although architectures can vary depending on the custom configuration, such as when you have deployed a Azure Databricks workspace to your own virtual network, which is also known as VNet injection. Now, let us consider this architecture. It is a common structure and a data flow of an Azure Databricks. Here, it consists of control plane and data plane. So, let us understand what is control plane. The control plane includes the backend services that Azure Databricks manage in its own Azure account. Notebook commands and many other workspace configurations are stored in the control plane and encrypted at the rest. If we talk about data plane, it is managed by your Azure account and it is where your data resides. This is also where data is processed. You can use Azure Databricks connectors so that your clusters can connect to external data sources outside your Azure account to ingest data or for storage. You can also ingest data for external streaming data sources such as event data, streaming data, IoT data, or many more. Well, your data is stored at rest in your Azure account in the data plane and in your own data sources. not the control plane. So you maintain control and ownership of your data. If we talk about the job results, then it resides in storage in your account itself. Interactive notebook results are stored in the combination of control plane, that is partial result for presentation in the UI, and your Azure storage. If you want interactive notebook results stored in only your cloud account storage, then you can ask Databricks representative to enable interactive notebook result in the customer account for your workspace. Note that some metadata about results, such as chart columns, names, continues to be stored in control plane itself. So this is the basic architecture of Azure Databricks. To know it more in simplified manner, let us have a quick hands-on on Azure Databricks. So here we'll be integrating Azure Databricks with the Azure Blob Storage, that is a service provided by Microsoft Azure. So as you can see, this is a small workflow of how we'll be working on the demo. So as we know, Azure Blob Storage and Azure Databricks are both services provided by Microsoft Azure. Now, these are two separate services, but as long as you are using them in same resource group, you can integrate these two services. Well, now you must be wondering, why do we need to combine these? So let's say that Microsoft Azure provides a multitude of services. It is often beneficial to combine multiple services together to approach your use case. So if we combine multiple services, then we don't need to engage your local hardware in anything like, well, for example, currently I'm using a laptop. Maybe my laptop can be a lower configuration, or it might not have enough space to process a huge amount of data. In that case, I would want the cloud service to handle all my use cases and my big data storage that I have. So in this workflow, as we said, that we will integrate Azure Databricks and Azure Blob Storage. That means we're going to combine them. So here what you do basically is you interact with the coding notebook, which is nothing but the IPython or Jupyter notebook that your Azure Databricks will create. Then what you do is then you type some coding commands in your coding notebook, and then these commands are sent to the Databricks service. And then what happens is the Databricks service receives the commands from the coding notebook and it sends those commands to your Azure cluster. So whatever cluster you have created after creating your Databricks, so whatever commands that we are writing in the coding notebook is sent through Databricks to your clusters that you have created. Now, depending on the authentication provided to the cluster with regards to your blob storage account, the authentication commands are then sent to the blob storage account, saying that the data is fetched from the desired directory. Then it is brought back inside the cluster, and that data that has received by the cluster then is processed, and whatever output you get out of after the process is you can see it on your coding notebook. Now whatever output you receive from the coding notebook, you can also store that particular output that you have got from the coding notebook back to your blob storage account or space. So all of this is integrated easily and it is handled in a very simpler manner. Well, now that we have understood the architecture, let us now know how to implement it with a hands-on. For this, we need to quickly sign in to our Azure portal. So once we sign in, we land in our dashboard of the Microsoft Azure. As you can see here, all the Azure services are mentioned here. And once you create your resource group, so it gets highlighted also. Now let us quickly open our Azure Databricks and let us create our Azure Databricks. So for this, once we come here, we need to just simply create. And here they ask for basic details like your resource group, then workspace name, region. So let us fill up one by one. So here, as we don't have any resource group, so we'll be creating a new resource group. As we are working on a demo, so let's name it as Azure Databricks demo, and let's create it. Now that we have created the resource group, now they ask for the workspace name. So we'll give it a unique name. You can keep it any. So let's name it as Azure Databricks hands-on. And then you can choose your region. So here you find different types of region where you can like work or create your Azure Databricks. So it is up to you whatever region you choose. For me, I'll be keeping West US as it is. After that, we come to the pricing tier. So here there are three types: standard, premium, and trial. So as we are working on the, like we are just having a practical knowledge, we will be using the trial version and we'll just review and create. Now here you can just check on to your whatever details you had filled previously, whether it is correct or no. So once it is validated, we can just create this Databricks. Now, as you can see, they are initializing the deployment. So it may take a while to create a Databricks. All right, so here you see the deployment is in progress. So once your deployment is complete, you can go to your resource, and here you land up to your Databricks page. Now here what we need to do is launch our workspace. So it will move us to our main Azure portal. So it will sign us in the Azure Databricks. So this is the dashboard of the Databricks. Now here you have different options like notebook and data import, partner connect, transform data, and many other things. Here you can set up your workspace like create a cluster, import data, build a data pipeline as well. Now one thing I should tell you that Databricks works on DBFS. Now what do you mean by DBFS is, well, DBFS is nothing but Databricks file system, which is a distributed file system mounted on Azure Databricks workspace and are available on the Azure Databricks cluster. So it allows you to interact with the object storage using directory and file semantics instead of cloud specific API commands. And it helps you out to mount cloud object storage location so that you can map your storage credentials to the path in the Azure Databricks workspace. It also simplifies the process of persisting files to object storage, allowing the virtual machines and attacked volume storage to be safely deleted on the cluster termination. Well, these are the things which you can like implement it while you're working with the Azure Databricks. Now let's get back to our Databricks. Now that we have come to this page, so the first thing to be done over here is to create a cluster. Now we go to create a cluster. Now here we go to create compute. Now here, as you can see, we have the cluster name. So here we can edit the cluster name based on your requirement. So let us keep it as a Databricks cluster. And after this, we have the policy. So here policy is nothing but a cluster policy defines the limit on the attributes available during the cluster creation. So here we have different types of policies, that is unrestricted personal compute, power user compute, shared compute. So we will keep it unrestricted for time being. Now there are two types of cluster mode. One is multi-node and single node. So in multi-node, we can specify the minimum number of workers and the maximum number of workers. So here minimum numbers can be 2, or you can specify it upon, this is basically a standard limit for minimum and maximum, whereas you can change it accordingly based on your requirement. So now, as of now, as we are only practicing, so we will just disable this auto scaling and we can specify our number of workers over here. So we can keep only one worker as it is only for practicing. Whereas we can also like change the timings for termination if the particular cluster is inactive. So you can specify that much of time to it. Apart from that, we have our access mode. That is nothing but there are three types of access mode, that is single user, shared user, and no isolation shared. So here we will keep it as it is, and here single user access is nothing but a subscription. After that we come to our performance. So here we need to specify our runtime version. So here in our case it is runtime 11.3 LTS Scala 2.12, and our work type can be standard, whereas There are other versions as well, but as of now, we don't require much of it, so we'll be going with the standard version itself. And whereas we have already specified our workers and termination time is also being mentioned. Now here towards your right, you can see the whole summary of your cluster. What have you been creating? So once you review it, you can just create this particular cluster. Now, as you can see, it is loading. It takes a while to create a cluster. Here in this section, you see the status of your cluster. So currently it is in a pending mode, like it has been creating. So we'll wait for a while. So now as you can see, our cluster has been created and it is in the running mode. Now, after this, what we need to do is go back to our main dashboard and we need to create a new notebook. So we'll create a new notebook over here, and here we have already specified the cluster. So we had created now, so it has automatically taken. And here we need to specify our default language. So you can choose any of them. So here there are 4 types of languages which you can choose. Here I would be taking Scala for now, and we can give a simple name to this notebook. That is, it can be anything of your choice. So let us name it as Databricks notebook and let's create. So this will start very quickly. It doesn't take that much of time. Now here it is like you need to run your command over here. So you just need to type down your command and just hit enter and it starts running. So now in this, we will know how to upload a file through the Azure storage service, that is our Azure Blob storage. So it's basically we need to first integrate the Azure Blob storage. So let us know how. So before this, we need to go back to our Azure portal, and here we need to first create our storage account. So here, as you can see, we have our storage accounts, and here we'll create our blob storage. So let's create. So now here for creating storage account, you need to give your details over here. So as here we had already created the resource group previously while creating a Databricks, so we will be selecting the same. And after that, we will give a storage account name. So let us name it as Databricks storage account. And in region, we need to provide the specific region, whichever you like to choose. So as previous, I had chosen West US, so I'll be choosing that as well. And here, now when we come to the performance, so here we can choose any of those, any of the 2 options given below. So here we have standard and premium. So currently we'll be going with the standard version. And when we talk about redundancy, so here we have 2 types of redundancy. As you can see, locally redundant storage. Here it means the low cost option with the basic protection against server rack and drive failures, recommended for non-critical scenarios. Whereas geo-redundant storage is for intermediate option with failover capabilities in secondary region, recommended for backup scenarios. So locally means it happens within the region, not across the whole world. So here we will be choosing the locally redundant storage. Now we have specified everything. So now let us review. So here before creating, you need to check all your details. Once you review it, just create, and your storage account is in initialization stage. So once it gets deployed, we will start working on that. So now our deployment is complete, so we can go to our resource. So here all of the permissions are automatically managed within the same resource group. So we don't have to worry about any permissions requirement. So now that we have created our storage account, now here we need to create our container. So we'll go to our containers and so here we can give it a name to our container. It can be anything. Name it as storage account 1 and let's just create. So as you can see, our container has been created. Now we will quickly go on to this container, and here we don't have anything in this container. So the container is empty. Now we need to upload some files in this particular container. So we'll just quickly go to upload, and here we will go to select file. So here what does it do? It will get connected to my Windows file. You can take any files over here. So as of now, I will just take a normal Excel, a CSV file, and we'll just simply upload it. Well, you can upload more than one files if you want to upload it in the containers. You can also have a larger files, but it may cost according to the given size. Now we have a file in place, and we also have created our notebooks. So now we have to integrate the blob storage with the Databricks. So for that, we need to run a code. Now here the code looks a bit complex. So here first we need to create a token so that we can get access to the files. So we'll just copy this whole code so that there's nothing to memorize. This can be provided to you while you are practicing. So now we'll just copy paste the whole command. So here, now as you can see, the container name. So here we need to specify the container name and the storage account that we have created. So we'll quickly go back to our Azure portal, and we will fill up the details. So as they asked for the container name, so here we need to specify our container name and the storage account which we have created. So let's quickly go back to our Azure portal, and here as you can see, your container name is given. So we'll just quickly copy that. Okay, where did it go? Let's go back, and we'll just copy this name, and we'll paste it here. Now same thing to be done with our storage account. So we'll go back to our storage account, and here we'll see this is our storage account name. So we'll just copy, and we'll just paste it over here. Now for the SOS token, we need to go back to our containers, and here we will go to the shared access signature. So here we will be getting our SAS tokens. So SAS token can be generated for a limited amount, for a given period of time. So you need to specify, when you create your SAS token, so the time it has been started, it would be valid from the time it has been started till its time of expiry. So we'll just allow the services, containers, and the objects, and let the time be as it is been specified. And now let's generate. So now here, as you can see, you can find your SAS token. Now we need to just simply copy this and go back to our Databricks, and we'll paste it over here. So we have just added our SAS token. Let us just verify whether it has been correctly copied or no. So I feel everything looks perfect. Rest other things remains to be same. So here what happens, you keep on creating new variables. So here we have created a URL. So by appending the container and the storage account. So once we specify our URL and our configuration, then it comes the DB utils. So here we specify our source, mount point, and our maps to that particular token. So this is basically where the Databricks helps you get your sources from your different services. So here the Databricks plays the role where it provides you the data from where you want to extract from, and it shows it over here. And now you just hit shift plus enter. So now it is running the command. So here what does it do is we had discussed in our architecture. So it communicates first with the Databricks, and then it communicates with our cluster, and get all the sources, and then shows its result on the cluster itself. So as you can see, your command has been run. Okay, so it shows some error over here. So let's quickly solve that error. All right. Now let's quickly run it again. So it may take a while. So here, as I said, it will first connect with the Databricks and then communicate with that, and then it will communicate with your cluster and get all the resources from there. So here, as you can see, they have specified your container name, storage name, and your token which has been specified. Now, what we need to do is check whether our file has been extracted from our storage account or no. So here we'll specify, first we'll specify our variable. So let's specify with spark.read. And now we're gonna give the format of the file. So as we had uploaded the CSV file, so we'll just specify it over here. CSV, and then we can give them some of the options that they should show. So let's give it an option, like we can ask them to show the header and their value should be true. Then we can also specify the inverse schema, so we'll just add on that as well. And for the efficient data requirement, we will just provide them with a mode that can be fail fast mode, and then we upload the like mentioned the file name. So here we paste this mount/staging, that is our mount point, and we'll paste it over here, and then we will specify our file name, that is, let's go to our containers, let's check what's the name, python1.csv. Let's copy the name and we'll paste it. So now let's just shift enter. So it shows some error. Let's see what is it. Okay, so here we had specified a wrong command. So let's just resolve it and let's run it again. All right, so let us see how it looks like. So now just do df dot show and let's specify some amount and just shift enter. So as you can see, so they have mentioned here the decimal and description, the percentage, your headers have been provided, and the number of rows that we required, they have specified that. So this is how we integrate the two services and we process data through Databricks. Now let us look on to some of the popular use cases that makes Azure Databricks in a huge demand. Well, Databricks isn't a catch-all solution for every business scenario. So there are the best use cases for Azure Databricks. First is database and mainframe modernization. Data storage, collection, and processing are incredibly important in modern businesses. Well, if you're looking to modernize your data lakes or looking into mainframe modernization applications, then Azure Databricks has all the integrations you need. Next is machine learning production pipeline. Here, using the underlying power of ML flow, Databricks is a good choice if you need to get machine learning applications into production. Getting data science out of the development and into production is a common problem, and Azure Databricks can help you streamline that workflow. If we talk about big data processing, then Azure Databricks is one of the most cost-effective options for big data processing. In terms of performance versus cost, it offers higher efficiency. If your business needs the best performance for one-demand data processing, then Databricks will likely be your best choice. Next is business intelligence integration. Integrating business intelligence tools means you can open your data lake to analysts and engineers more easily. There is no need for creation of new pipelines when analysts need access to new data. The data can be shared through SQL Analytics, Power BI, and Tableau. If this is a bottleneck for your business, then Databricks will help you enable your business intelligence team. Now, these are the four popular use cases by Azure Databricks. If your business fits in one of these use cases, then it might be the solution for you.
Let us start with the U.S. primary election use case first. In this use case, we will be discussing about the 2016 primary elections. In the primary elections, the contenders from each party compete against each other to represent his or her own political party in the final elections. There are two major political parties in the U.S., the Democrats and Republicans. From the Democrats, the contenders were Hillary Clinton and Bernie Sanders, and out of them, Hillary Clinton won the primary elections. And from the Republicans, the contenders were Donald Trump, Ted Cruz, and a few others. As you already know, Donald Trump was the winner from the Republicans. So now, let us assume that you are an analyst already, and you have been hired by Donald Trump, and he tells you that I want to know what were the different reasons because of which Hillary Clinton won. And I want to carry out my upcoming campaigns based on that so I can win the favor of the people that voted for her. So that was the entire agenda. So this is the task that has been given to you as a data analyst. So what is the first thing that you will need to do? The first thing you'll do is that you'll ask for data, and you have got two data sets with you. So let us take a look at what this data set contains. So this is our first data set, which is the U.S. primary election data set. So these are the different fields present in our data set. So the first field is state. So we've got the list of the state of Alabama. The state abbreviation for Alabama is AL. We've got the different counties in Alabama like Artuga, Baldwin, Barber, Bibb, Blount, Bullock, Butler, etc. And then we've got FIPS. Now, FIPS are Federal Information Processing Standards Code. So this basically means zip code. Then we've got the party, so which we will be analyzing the Democrats only because we want to know what was the reason for Hillary Clinton's win. So we will be analyzing the Democrats only. And then we've got the candidate, and since I told you there were two candidates, Bernie Sanders and Hillary Clinton, so we've got the name of the candidate here and the number of the votes each candidate got. So Bernie Sanders got 544 in Artuga County, and Hillary Clinton got 2387. And this field over here represents the fraction of the votes, so if you add these two together, you will get a 1. So this basically represents the percentage of vote each of the candidates got. So let's take a look at our second data set now. So this data set is the U.S. County Demographic Features data set. So the first we will have, again, FIPS in the area name, Artuga County, Baldwin, and different other counties in Alabama and other states also. The state abbreviation, so here it is only showing Alabama, and the fields that you see here are actually the different features. You won't know what this exactly contains because it is written in a coded form, but let me give you an example what this data set contains. Let me tell you that I'm just showing you a few rows of the data set. This is not the entire data set. So this contains different fields like population in 2014 and 2010, the sex ratio, how many females, males, and then based on some ethnicity, how many Asians, how many Hispanic, how many Black American people, how many Black African people, and then there's also based on the age groups, how many infants, how many senior citizens, how many adults. So there are a lot of fields in our data set, and this will help us to analyze and actually find out what led to the winning of Hillary Clinton. So now you have seen our data set. You have to understand your data set. You have to figure out what are the different features or what are the different columns that you are going to use, and you have to think of a strategy or think of how you're going to carry out this analysis. So this is the entire solution strategy. So the first thing you will do is that you need a data set, and you've got two data sets with you. The second thing that you'll need to do is to store that data into HDFS. Now, HDFS is Hadoop Distributed File System, so you need to store the data. The next step is to process that data using Spark components, and we will be using Spark SQL, Spark mlib, etc. So the next task is to transform that data using Spark SQL. Transforming here means filtering out the data and the rows and columns that you might need in order to implement or in order to process this. The next step is clustering this data using Spark mlib, and for clustering our data we will be using k-means, and the final step is to visualize the result using Zeppelin. Now, visualizing this data is also very important because without the visualization, you won't be able to identify what were the major reasons, and you won't be able to gain proper insights from your data. Now, don't be scared if you're not familiar with terms like Spark, SQL, Spark mlib, k-means, clustering. You will be learning all of these in today's session. So this is our entire strategy. This is what we're going to do today. This is how we're going to implement this use case and find out why Hillary Clinton won. So now let me give you a visualization of the results. So I'll just show the analysis that I have performed and I'll show you how it looks. So this is Zeppelin, which is in my master node in my Hadoop cluster, and this is where we're going to visualize our data. So there's a lot of code. Don't be scared. This is just Scala code with Spark SQL, and at the end you will be learning how to write this code. So I'm just jumping onto the visualization part. So this is the first visualization that we have got, and we've analyzed it according to different ethnicities of people. For example, in our x-axis we have foreign-born persons, and in the y-axis we're seeing that among the foreign-born people, what is the popularity of Hillary Clinton among the Asians. And the circles represent the highest values. The bigger circle is the bigger counts. So we have made a few more visualizations. So now we've got a line graph that compares the votes of Hillary Clinton and Bernie Sanders together. Again, we have got an area graph also that compares Bernie Sanders and Hillary Clinton votes, and hence we have a lot more visualization. We have got our bar charts and everything finally. We also have state and county-wise distribution of the votes. So these are the visualizations that will help you derive a conclusion to derive an answer, whatever answer that Donald Trump wants from you. And don't worry, you'll be learning how to do that. I'll explain each and every detail of how I've made these visualizations. So let's get started with Hadoop and Spark. We will start with an introduction to Hadoop and Spark. So now let's take a look at what is Hadoop and what is Spark. So Hadoop is a framework where you can store large clusters of data in a distributed manner and then process them parallelly. Then Hadoop has got two components for storage. It has HDFS, which stands for Hadoop Distributed File System, and it allows to dump any kind of data across the Hadoop cluster, and it'll be stored in a distributed manner in commodity hardware for processing. You've got Yarn, which stands for Yet Another Resource Negotiator, and this is the processing unit of Hadoop, which allows parallel processing of the distributed data across your Hadoop cluster in HDFS. Then we've got Spark. So Apache Spark is one of the most popular projects by Apache, and this is an open source cluster computing framework for real-time processing, where on the other hand, Hadoop is used for batch processing. Spark is used for real-time processing, because with Spark, the processing happens in memory, and it provides you with an interface for programming entire clusters with implicit data parallelism and fault tolerance. So what is data parallelism? Data parallelism is a form of parallelization across multiple processes in parallel computing environments. A lot of parallel words in that sentence. So let me tell you simply that it basically means distributing your data across nodes which operate on the data parallel, and it works on fault-tolerant systems like HDFS and S3, and it is built on top of Yarn, because with Yarn you can combine different tools like Apache Spark for better processing of your data. And if you see the topology of Hadoop and Spark, both of them have the same topology, which is a master-slave topology. So in Hadoop, if you consider in terms of HDFS, the master node is known as the name node, and the working node or the slave nodes are known as data node. And in Spark, the master is known as master and slave are known as workers. So these are basically daemons. So this is a brief introduction to Hadoop and Spark, and now let's take a look at Spark complementing Hadoop. There's always been a debate about what to choose, Hadoop or Spark, but let me tell you that there is a stubborn misconception that Apache Spark is an alternative to Hadoop, and that is likely to bring an end to the era for Hadoop. It is very difficult to say Hadoop versus Spark because the two framers are not mutually exclusive, but they are better when they are paired with each other. So let's see the different challenges that we address when we are using Spark and Hadoop together. You can see the first point that Spark processes data 100 times faster than MapReduce. So it gives us the results faster and it performs faster analytics. The next point is Spark applications can run on Yarn leveraging Hadoop cluster, and you know that Hadoop cluster is usually set up on commodity hardware, so we are getting better processing, but we are using very low cost hardware. And this will help us cut our costs a lot, so hence also the cheap cost optimization. The third point is that Apache Spark can use HDFS as storage, so you don't need a different storage space for Apache Spark. It can operate on HDFS itself, so you don't have to copy the same file again. And if you want to process it with Spark, so hence you can avoid duplication of files. So Hadoop forms a very strong foundation for any of the future big data initiatives, and Spark is one of those big data initiatives. It's got enhanced features like in memory processing, machine learning capabilities, and you can use it with Hadoop. And Hadoop uses commodity hardware, which can give you better processing with minimum cost. These are the benefits that you get when you combine Spark and Hadoop together in order to analyze big data. Let's see some of the big data use cases. So the first big data use case is web e-tailing. The recommendation engines, whenever you go out on Amazon or any other online shopping site in order to buy something, you will see some recommended items popping below your screen or to the side of your screen. And that is all generated using big data analytics and ad targeting. If you go to Facebook, you see a lot of different items asking you to buy them. And then you got search quality, abuse, and click fraud detection. You can use big data analytics and telecommunications also in order to find out the customer churn prevention, the network performance optimization, analyzing network to predict failure, and you can prevent loss before the error or before the fault actually occurs. It's also widely used by governments for fraud detection and cybersecurity in order to introduce different welfare schemes. Justice, it has been widely used by healthcare and life sciences for health information exchange, gene sequencing serialization, healthcare service quality improvements, and drug safety. Now let me tell you that with big data analytics, it has been very easy in order to diagnose a particular disease and find out the cure also. So these are some more big data use cases. It is also used in banks and financial services for modeling true risk, fraud detection, credit card scoring, analysis, and many more. It can be used in retail, transportation services, hotels, and food delivery services. And actually, every field you name, no matter whatever business you have, if you're able to use big data efficiently, your company will grow and you will be gaining different insights by using big data analytics and hence improve your business even more. Nowadays, everyone is using big data, and you've seen different fields, and everything is different from each other, but everyone is using big data analytics, and big data analysis can be done with tools like Hadoop and Spark, etc. So this is why big data analytics is very much in demand today and why it is very important for you to learn how to perform big data analytics with tools like this. So now let's take a look at a big data use solution architecture as a whole. You're dealing with big data now. The first thing that you need to do is you need to dump all that data into HDFS and store it in a distributed way. And the next thing is to process that data so that you can gain insights. And we'll be using Yarn because Yarn can allow us to integrate different tools together, which will help us to process the big data. So these are the tools that you can integrate with Yarn. You can choose either Apache Hive, Apache Spark, MapReduce, Apache Kafka in order to analyze big data. And Apache Spark is one of the most popular and most widely used tools with Yarn in order to process big data. So this is an entire solution as a whole. Now, so let's take a look at Apache Spark. Apache Spark is an open source cluster computing framework for real-time processing, and it has been the thriving open source community and is the most active Apache project at this moment. And Spark components are what make Apache Spark fast and reliable. And a lot of Spark components were built to resolve the issues that cropped up while using Hadoop MapReduce. So Apache Spark has got the following components. It's got the Spark core engine. Now the core engine is for the entire Spark frameworks. Every component is based on and it is placed in the core engine. So at first we've got Spark SQL. So Spark SQL is a Spark module for structured data processing, and you can run a modified Hive queries on existing Hadoop deployments. And then we've got Spark Streaming. Now, Spark Streaming is the component of Spark which is used to process real-time streaming data and is a useful addition to the core Spark API because it enables high throughput and fault tolerance, stream processing of live data streams. And then we've got Spark 𝐸. This is the machine learning library for Spark, and we'll be using Spark 𝐸 to implement machine learning in our use cases too. And then we've got GraphX, which is the graph computation engine, and this is the Spot API for graphs and graph parallel computation. It has got a set of fundamental operators like subgraph, join purchases, etc. Then you've got Spark R, so this is the package for R language to enable our users to leverage Spark power from R shell. So the people who have already been working on R are comfortable with it, and they can use R shell directly at the same time, and they can use Spark using this particular component, which is Spark R. You can write all your code in the R shell, and Spark will process it for you. Now let's take a deeper look at a realistic people and all these important components. So we've got Spark Core, and Spark Core is the basic engine for large-scale parallel and distributed data processing. The core is the distributed execution engine, and Java, Scala, and Python APIs offer a platform for distributed EDL development, and further additional libraries which are built on top of the core allow for diverse streaming, SQL, and machine learning. It's also responsible for scheduling, distributing, and monitoring jobs in a cluster, and also interacting with storage systems. Let's take a look at the Spark architecture. So Apache Spark has a well-defined and layered architecture where all the Spark components and layers are loosely coupled and integrated with various extensions and libraries. First, let's talk about the driver program. This is the Spark driver, which contains the driver program and Spark context. This is the central point and entry point of the Spark shell, and the driver program runs the main function of the application, and this is the place where Spark context is created. Well, what is Spark context? Spark context represents the connection to the entire Spark cluster, and it can be used to create resilient distributed data sets, accumulators, and broadcast variables on that cluster. And you should know that only one Spark context may be active per Java virtual machine, and you must stop any active Spark context before creating a new one. Let's talk about the driver program that runs on the master knob of the Spark cluster. It schedules the job execution and negotiates with the cluster manager. This is the cluster manager over here, and the cluster manager is an external service that is responsible for acquiring resources on that Spark cluster and allocating them to a Spark job. Then in the worker node, we have got the executors. The executor is a distributed agent that is responsible for the execution of tasks, and every Spark application has its own executor process. Executors usually run for their entire lifetime of the Spark application, and this phenomenon is also known as static allocation of executors, but you can also opt for dynamic locations of executors where you can add or remove Spark executors dynamically to match with the overall workflow. Okay? So now let me tell you what actually happens when the Spark job is submitted. When a client submits a Spark user application code, the driver implicitly converts the code containing transformations and actions into a logical directed acyclic graph, or DAG, and at this stage the driver program also performs certain kinds of optimizations like pipelining transformations, and then converts the logical DAG into a physical execution of a plan with a set of stages, and after creating a physical execution plan, it creates more physical execution units that are referred to as tasks under each stage, and these tasks are bundled to be sent to the Spark cluster. So the driver program then talks to the cluster manager and negotiates for resources, and the cluster manager then launches the executors on the worker nodes on behalf of the driver. And at this point, the driver sends tasks to the cluster manager based on the day replacement, and before the executors begin execution, they first register themselves with the driver program so that the driver has got a holistic view of all the executors. Now, the executors will execute the various tasks that are assigned to them by the driver program, and at any point in time when the Spark application is running, the driver program will keep on monitoring the set of executors that are running the Spark application code. And this driver program here also schedules future tasks based on data replacement by tracking the location of the cache data. So I hope you have understood the architecture of Spark. Any doubts? All right, no doubts. Now let's take a look at Spark SQL and its architecture. So Spark SQL is the new module in Spark, and it integrates relational processing with Spark's functional programming API, and it supports querying of data either via SQL or via Hive query language. So for those of you who have been familiar with RDBMS, so Spark SQL will be a very easy transition from your earlier tools because you can extend the boundaries of traditional relational data processing with Spark SQL, and it also provides support for various data sources and makes it possible to read SQL queries with code transformation, and that is why Spark SQL has become a very powerful tool. This is the architecture of Spark SQL. So let's talk about each of these components one by one. First, we have got the data source API. So this is the universal API for loading and storing structured data, and it is built on support for Hive, Avro, JSON, JDBC, CVS, Parquet, etc. So it also supports the third-party integration through Spark packages. Then you've got the data frame API. Data frame API is the distributive collection of data that is organized into named columns and is similar to relational table in SQL that is used for storing data in tables. So it is the domain-specific language applicable to, or DSL applicable on structured and semi-structured data. So it processes data from kilobytes to petabytes on a single node cluster to a multi-node cluster, and it provides different APIs for Python, Java, Scala, and R programming. So I hope you have understood all the architecture of Spark SQL. We will be using Spark SQL in order to solve our use cases. So these are the different commands to start the Spark daemons. These are very similar to Hadoop commands to start the HDFS daemons. So you can see to start all the Spark daemons, so the Spark daemons are master and worker, and you can use this command to check if all the daemons are running on your machine. You can use JPS like Hadoop, and then in order to start the Spark shell, you can use this. And you can go ahead and try this out. So this is very similar to the Hadoop part that I just showed you earlier, so I'm not going to do it again. And then we've seen Apache Spark also. So now let's take a look at K-means and Zeppelin. K-means is the clustering method, and Zeppelin is what we're going to use in order to visualize our data. So let's talk about the K-mean clustering now. K-means is one of the most simplest unsupervised learning algorithms that solves the well-known clustering problem. So the procedure of K-means follows a simple and easy way to classify a data set to a certain number of clusters, which is fixed prior to performing the clustering method. So the main idea is define K-centroids, one for each cluster, and the centroids should be placed in a very cunning way because of different location causes different results. So here, let's take an example. So let's say that we want to cluster a total population of a certain location, and so we want to cluster them into 4 different clusters, namely group 1, 2, and 3, and 4. So the main thing that we should keep in mind is that the objects in group 1 should be as similar as possible, but there should be as much difference between an object in group 1 and group 2. It means that the points that are lying in the same group should have similar characteristics. And it should be different from the points that are lying in a different cluster, and the attributes of the objects are allowed to determine which object should be grouped together. For example, let us take in the same sample that we're using in the U.S. county. So let's consider the second data set we have used. There are a lot of features that I already told you, like there are age groups, and they are categorized by professions, and they also categorized by the ethnicity. And so this is the thing that we are talking about. So these are the attributes that will allow us to cluster our data. So this is K-means clustering. Here is one more example. Let us consider a comparison on income and balance. So in my x-axis, I've got the gross monthly income, and in the y-axis, I have the current balance. I want to cluster my data according to these 2 attributes. Here, if you see, this is my first cluster, and this is my second cluster. So this is the cluster that indicates the people who have high income and low balance in the account, and they spent a lot. And this cluster comprises of the people who have got a low income but a high balance, and they are safe. You can see that all the points that are lying here have got similar characteristics, that they have got low income and high balance. And here are the people who share the same characteristics, where they have got low balance and high income. And there are a few outliers here and there, but they don't form a cluster. So this is an example of k-means clustering, and we'll be using that in order to solve our problems. So does anybody have any questions? So here is one more example and one more problem for you. So you guys will tell me now. So the problem is that I want to set up schools in my city, and these are the points which indicate where each student lives. So my question to you is, where should I be building my school if I have students living around the city in these particular locations? And in order to find that out, we will do k-means clustering, and we'll find out the center point, right? So if you can cluster and make groups of all these locations and set up schools at the center point of each cluster, that would be optimum, isn't it? Because that is how the students have to travel less. It will be close to everyone's house. And there it is. So we have formed 3 clusters. So you can see the brown dots are one cluster, and the blue dots are one cluster, and the red dots are one cluster. And we have set up schools in the center points of each cluster. So here is one, and here is yet another one. So this is where I need to set my schools up so that my students do not have to travel that much. So that was all about k-means, and now let's talk about Apache Zeppelin. This is a web page notebook which brings in data ingestion, data exploration, visualization, sharing, and collaboration features to Hadoop and Spark. So remember, when I showed you my Zeppelin notebook, you can see that we have written the code there. We have even run SQL codes there, and we have more visualizations by executing code there. So this is how interactive Zeppelin is, and it supports many, many interpreters, and it is a very powerful visualization tool that can use, that goes very well with Linux systems, and it supports a lot of language interpreters. It supports R, Python, and a lot of other interpreters. So now let's move on to the solution of the use case. So this is what you've been waiting for. First, we will solve our U.S. county solution. So the first thing we will do is we will store the data into HDFS, and then we will analyze the data by using Scala, Spark SQL, and Spark MLlib. And then finally, we'll find out the results and visualize them using Zeppelin. So this was the entire U.S. election solution strategy that I told you. Now, I don't think I should repeat it again, but if you want me, I can. Should I repeat? All right, so most of the people are saying no, so I will go right through this one again. So let me just go to my VM and execute this for you. So this is my Zeppelin, and I open my notebook here, and let us go to my U.S. election notebook, and this is the code. So first of all, what I'm going to do is that I am importing certain packages because I'll be using certain functions that are in those packages. So I've imported Spark SQL packages, and I have also imported Spark MLlib packages because I'll be using k-means clustering. So vector assembler enables me certain machine learning functions. So over here, I have the vector assembler package that gives me certain machine learning functions that I'm going to use. I've also imported the k-means package because I'll be using k-means clustering. Then the first thing that you need to do is that you need to start the SQL context. So I've started my Spark SQL context here, and the next thing that you need to do is that you need to define a schema, because when you want to dump our data set or we want to dump our data, it should be in a particular format, and we have to tell Spark in which format it should be. So we're defining a schema here. So let me take you through the code. So I'm storing schema in a variable called schema, and we have to define the schema in a proper structure. So we're going to start with struct type, and since you know that our data set has got different fields as columns, we're going to define this as an array of fields. And then this is an array and struct, so we are defining the different fields now. So we'll start with the first field by defining it as struct field inside the braces, which should mention what should be the name of that particular field. So I've named it as state, it should be a string type, and true, that means it is a string type. The next we've got FIPS, which is of string type. Now I know that FIPS is a number, but since we are not going to do any kind of numeric operation on FIPS, we're going to let it stay as a string. Then we've got party as a string type, candidate as a string type, and then votes as integer type, because we're going to count the number of votes and there's going to be certain numeric operations that we are going to perform that will help us to analyze our data. Then we've got a fraction votes, which you know is a decimal type, so we have to keep it as double type. The next thing you need to do is that Spark needs to read the data set from the HDFS. So for that, you have to use the command spark read, option header true. Header true means that you have mentioned and you have told Spark that my data set already contains column headers, because state as ABBR, they are nothing, but they are column headers. So you don't have to explicitly define the column headers for it. Neither will Spark choose any random row as a column header. So it will choose only the column headers your data set has. Then you have to mention the schema that you have defined. So I have defined it in my variable schema. So that's why I have mentioned it in my file. It should be in CSV format. And then I have mentioned the path of the file in my HDFS. This is the path, and I stored this entire data set in my variable df. Now what I am going to do is that I'm going to divide up certain rows from my data set, because you know that my data set contains both the Republican and Democrat data, and I just want the Democrat data, right? Because we're going to analyze the Hillary Clinton and Bernie Sanders part. Okay, so this is how you divide your data set. So the first thing that we have done is that we have created one more variable called DFR, and we have applied a filter where party is equal to Republican. And then we are storing the Democrat Party data into DFD. So we're going to use the DF_D from onwards, and DFR, the Republican data, is going to be your assignment for the next class. Now, I am going to analyze the Democrat data, and then after this class is over, I want you guys to take the Republican data. This data set is already available in your elements, and you've got the VMs, also with everything installed. So please, when you are at home, when you have free time, just analyze the Republican data and tell me what were the reasons that Donald Trump won. I want you to do all that analysis and come up with that in the next class, and we'll discuss about it and whatever results and conclusions that you have made after analyzing the Republican data. And that way you'll also learn even more, and it will also be practice for you after today's class. So alright, so we are going to take df_d now, and the first thing that we will do is that we will create a table view, and I'm going to name the table view as election. And let me just show you what it looks like and what it has. So this is the command that I have run in Zeppelin. So this is SQL code that I have run in Zeppelin. And you can see that I have got states, state_ABBR, and I have only got the Democrat data. All right, now let's go back. All right, so after creating the table view, now all of the Democrat data is in my election table. So now what I'm going to do is that I'm creating a temporary variable, and I'm running Spark SQL code. So what I'm actually doing by writing this code, the motive of writing this SQL code or the SQL query is that I want to refine my data even more. So what I'm trying to analyze here is how a particular candidate actually won. I don't have to do anything with the losing data, because you know that each of FIPS contain one of the losing candidate members and one of the winning candidate members. It contains the data of the winning candidate and the losing candidate also, because my data set contains both of the data of Bernie Sanders and Hillary Clinton. In some parts, Bernie Sanders won, and in some counties, Hillary Clinton won. So I just want to find out that who are the winners in a particular county, okay? So I'm going to refine that data, and for that I'm using this query. So I'm going to select all from election, and then I'm going to perform an inner join with their query. So this is one more query inside this query, and let me tell you what I'm actually doing. So first of all, what we have done is that we have selected FIPS as B. You know that now you have got two entries for each FIPS, so each FIPS actually appears twice in the data set. So I've named it as B, and now we are counting the maximum fraction votes. So you know that in each FIP we have the maximum fraction vote, and then we can find the winner by actually seeing who has got the maximum fraction votes, and then we have named it as A. The maximum fraction votes column is named as A, and we are grouping by FIPS. So now each of my FIPS will be selected which has a maximum fraction vote, and I have two columns for that, FIPS, which is 1001 and 1001. So the only row will be selected which has the maximum fraction votes. Now I'll have the winner data, and I've named this entire table inside this query as group TT, and then I'm validating it as where election.fips, the main table view.fips, should be equal to the B column that we have created in group TT table, and election.fraction votes should be equal to group TT.A. So any doubts on this query and about how I have written this? All right, so now what we're going to do is that whatever data that we've got here, I'm storing that in election 1. Let me just show you what is in election 1 now. So this is my election table only, and you can see that I've got two FIPS, so 1067, 1067. Now let me show you election 1. So there, now I can see that I don't have repetition of FIPS. I have only one entry for FIPS, and that is the row which tells me who won in that county, or in that particular FIP, or in the FIP associated with the particular county. And you can see for Bullock it was Hillary Clinton, for Calhoun it was Hillary Clinton, Cherokee also Hillary Clinton, and then State House District 19 is Bernie Sanders. So Alaska is mainly Bernie Sanders. So this is what we've done now, and then you can see that we have also got additional columns as B and A. So A tells you the maximum fraction votes, and B tells you the FIPS. So the data in FIPS and the data in B are the same, and data in fraction votes and data in A is the same, right? What I'm going to do now is, since my columns are repeating and they have the same value, I don't want A and B now, right? So what I'm going to do is I'm going to filter out the columns I don't need, and in this case I don't want B and A. And what I'm going to do is I'm going to make a temporary variable again, so I'm using the temporary variable to store some data temporarily. So I'm writing to the Spark SQL code to select only the columns that I want. I want the state abbreviation, county, FIPS, party, candidate, votes, fashion votes from election 1. I'm storing everything in dWinner. I've created this new variable, and whatever there was in temp, I'm assigning it to dWinner. And now I've got only the winner data, so I have got all the counties, and I've got who won in that particular county and by how much in the fraction of the votes. What I'm just doing till now is that I'm just refining our data set so that it will be easy for us to make some conclusions or gain some insights from that data, right? And also let me tell you that it's not always necessary that you are filing your data set in the exact way that I'm doing it. If you have something in mind after you've seen your data and understand your data and you found out what actually you need to do, you can carry out different steps to do that also. This is just one way of doing it, and this is my way of doing it. So I'm just telling you, and then we are creating a table for dWinner, and we are going to name it as Democrat. So let me go again and let me show you what the Democrat table view looks like. You can press Shift Enter. So there you we have column A and B that we had in election 1. And so I've just got the winner data. So now let us go back and find out what we're going to find is that I want to find out that which of the candidates won my state, and then whatever date and whatever result I'll get will be stored in the temporary variable when I'm assigning everything. That will be stored in the temporary variable to a new variable called dstate, and then similarly I'm going to create a table view for dstate, which is state. Let me show you what my state table view actually contains. So there it is. So I've got state, Connecticut, Hillary Clinton won 55 counties, Florida, Hillary Clinton won 58 counties. So this is what we've come up to for our first data set. So now let's see what we can do with our second data set that contains all the different demographic features. First thing, again, you have to define a schema, and this time I'm naming that schema schema 1, since you know that we have got almost 54 columns, so I have to define all those 54 columns also. So you remember what each of those columns contains. So this is exactly what I have done, and I don't need to go through every line, but like I already told you how to define a schema, you can have the code in your LMS so you can take a look at it. So the next thing we're doing, again, we have to read our data set, and I'm storing my data set into a new variable called df1, and this is the path in my HDFS where my data set was. And then I have created a table view for my data set, which is called facts. Now, let me show you what facts contain. As you can see, that it contains abbreviation, state abbreviation, population 2014. So instead of using the code now, or the encoded form that was actually there in my data set, I have given a varied meta name that would describe what it contains, right? So instead of PST 214, I've got population 2014. So does that make sense? Right. It contains all the 54 demographic features or different features that was in my data set. White alone, not Hispanic or Latino, living in the same house, 1 year and over, foreign-born persons, language or other than English spoken at home, high school graduate or higher. So it contains basically all the different features or all the different columns that actually was in my data set and that I have defined in my schema. So this is what facts I have. So now what I'm going to do is that I'm not going to analyze my whole data based on all these different features. I'm going to choose some specific features in order to analyze it. I'm going to take just a few, add one. So these are the different features that I'm going to use. I'm going to use FIPS, I'm going to use state, I'm going to use state abbreviation, then area name, candidate and people who are over 65 years, senior citizens, female people, white alone, black African alone. I'm choosing Asian alone, Hispanic or Latino. So basically what I'm trying to do is I'm trying to check what is the popularity of Hillary Clinton among the foreign people or people from different ethnicities. So I'm choosing white people, black people, and Hispanic people. So I'm just trying to analyze it, okay? And you know that I have stored this in a temporary variable again, and then whatever result I'll get by running this Spark SQL code, I'll store it in a different variable called dfx, and then I'll store it, and then I'll make a table view for df facts such as winner facts. So let me show you what winner facts look like. So it's winner facts. You've got FIPS, the state is Alabama, the state abbreviation is AL for Alabama. The area name is Artuga County. The winner was Hillary Clinton, and the people over 65 years in that particular county is 13.8%. Female percentage is 51.4%. White alone, 77.9%. And so these show you the data. So black, white, or African is 18%. And then I've got the different fields that I have selected. Asian alone, Hispanic or Latino, foreign-born. So I have chosen 14 features to analyze it from. All right? So now what I'm doing again is that I'm going to divide the Hillary Clinton data and the Bernie Sanders data so that we can analyze only why Hillary Clinton won or why Bernie Sanders won in some particular counties. So we are planning to filter the same way we divided Democrats and Republican data from our initial primary result data set. So this is what you have done. So you know that is stored in df facts. So we are putting a filter in df facts where candidate is equal to Hillary Clinton. So that will be stored in HC, and the data of Bernie Sanders will be stored in BS. So after that, what we are doing is that we are doing a one-hot encoding. So we'll add two more columns in our data set, a WBS and WHC. In this case, we are going to do one-hot encoding. And what we're going to do is that we are going to include, or we are going to attach two more columns in winner facts as WHC and WBS. So it'll just contain either 1 or 0. And so you can edit it in that way, whichever county. So if you're considering a county, let's say Artuga County, say if Hillary Clinton is the winner, it will have a 1 in WHC, and in WBS, it will have 0. Similarly, in which counties Bernie Sanders won, so Bernie Sanders will have 1, so WBS will have 1, and WHC will have a 0. And then we are creating different views for both of these two together, so this will only tell me wherever WHC is 1. That means this will only show me the counties where Hillary Clinton won. This will only show me the counties where Bernie Sanders won. And we are creating a view for both of these. So for Bernie Sanders, the view is WBS, and for Hillary Clinton, it's WHC. Then finally, we are merging both of them together using union. So select all from WHC, union all select from WBS, and finally you have stored it in result, and we have created a table view known as result. So let me show you what this result contains. So there it is for our Tuga. It was Hillary Clinton. So we've got the Bernie Sanders data over here at the bottom. And I've got all the different fields also from my second data set, the different features that I chose from my second data set to analyze it. So now comes the actual analyzing part. This is where we are going to perform k-means. But first we have to define the feature columns. Actually, you have to define what is the input that you're going to feed so that you get an output. So this is actually the input that you are going to feed to the machine so that the machine learning goes on, and finally it gives you some kind of result, right? So this is where I'm defining. Again, I'm using an array to define all the different fields from my data set. So I'm using person 65 years and older, female person percentage, white alone or black or African, American alone, Asian alone, Hispanic or Latino, foreign-born persons, language other than English, spoken at home, bachelor degree or higher, veterans, home ownership rate, median household income, persons below poverty level, and population per square mile, WHC and WBS. And then I'm going to use the vector assembler. So this is what enables different machine learning algorithms where we are using k-means. So my input column is features calls. So this is going to be the input, and my output column and will be called features. So whatever result that I'm going to get is features, and we have to transform the results. So this is the final table view that we have created, and you know what transforming means, or transforming again means. So in our strategy, we already saw that we have to transform the data first. So my updated data set was results. So I'm going to transform result and put columns as going to be these, which is feature columns. And output table view will be called features. And then we're going to perform the k-means clustering, and we're going to store it in a variable called k-means. So we're using different functions from Spark ML library, and we have chosen Spark with clustering k-means. And you know that in k-means we already defined that how many clusters do we need, and we need 4. So we have selected 4 clusters, and then we're going to set feature columns as features. And then set prediction column as predictions. So after that we're going to make a model, and we have defined our input and output columns in rows. So we're going to use 𝐾𝐻.fit row, and whatever predictions we will get, we're going to store it in a model, and then we are going to do this, and that we are going to print the cluster centers for each cluster. So let me show you what my cluster centers are. So after we run this code, you can see that these are the different cluster centers. So just what I can make you understand about what we're going to do after k-means clustering and how to analyze it. So the numbers are present. They are placed very haphazardly. So what I have done is that I've picked out each of the cluster center points, and then I have made a new table. Yes, so this is it. So you know that we have 4 clusters. We have got the 0th cluster, 1st cluster, 2nd cluster, and third. So 0, 1, 2, 3. Okay, so 4 clusters, and we have found out this cluster centers according to different features that we fed into my k-means algorithm. So what we observed here in WHC and WBS is that the winning percentage, or the winning chances, of Hillary Clinton was 0.9, whereas winning chances for Bernie Sanders was 0.1. And then if you observe the differences in the cluster centers for each feature, here you can see that there is not much difference, not even here. So it's 50, 49, 49, 51, and then it's, well, again, it is not much of a difference, but if you see here that it's 9 and it's going to 16. So you can do a more detailed analysis on Black or African American. So if you want to know the real support of Black or African American, and you want to see what was their voting pattern, or how popular was Hillary Clinton among them, so maybe this could be a good field to analyze because you see the variations in the number. Similarly, you can check out other features, and you can check out here at 16, 8, 9, and 36. So maybe, again, Hispanic or Latino field, and you should do some more analysis on it. And even here you can see in veterans there's 47,806, whereas we've got 182,000 all. So there is also a lot of difference. And here is only 2,759, and we've got in the 10,000s, we've got numbers, and even 100,000s here. So this is how we can identify that, which are the fields or which we can find the main reasons of the main points where you should make your analysis. So let's go back to our Zeppelin notebook, and here it is. So now what we're going to do is that we're going to visualize the result first. So we are counting from predictions. So you can see that in cluster 1s, the prediction means prediction contains my cluster. Since you know that I've stored my clusters, my cluster information and prediction, this is my output after k-means. So I've got this many clusters. So this is the count of my counties, or a count of different various that lie in my particular cluster. You can see that in cluster 1, I have got 1,917. In cluster 2, I've got 751. So maybe I should pay more attention on analyzing cluster 1, right? So that's why I've selected cluster 1 here, and we're making different predictions. So you can see that in the x-axis, I have got foreign-born people, and in y-axis, I have chosen language other than English spoken at home. And then we are grouping it by candidate. So you can see the lighter blue is for Bernie Sanders and the more dark blue is for Hillary Clinton. So all this light blue is for Bernie Sanders, and you can see that as the number of foreign people increases, you can only see Hillary Clinton in the scatter plot here. So there might be a few outliers, like back here in the sizes defined according to Black or African American alone. So you remember that this was the feature where we find a lot of variations in the numbers. So that's why we grouped it according to that. And you can see the bigger the circle represents, the more Black or African American alone. And that's what the conclusion we can find out from this scatter plot. And we can see that as the number of foreign people increases, the popularity of Hillary Clinton is more in larger groups of foreign people. You can also choose different parameters out of all the different features that you have chosen. So remember that we have also seen the variation in veterans. So let's choose veterans in a y-axis. So let's also change x-axis, and let me just use white alone here. So you can see here that there is the x-axis that has white alone, and this is the veterans. So you can see that Hillary Clinton is popular among veterans, also in a smaller group of veterans. Since we have decided the size in Black or African American alone, so the size also represents some values. She is popular among the African American veterans. And then as you go ahead and as the count increases, you can see actually, since it's a scatter plot, and it almost represents that this is a point as the number of people increases, or as the number of white people increases, the votes are equally kind of distributed between Bernie Sanders and Hillary Clinton, because there are a lot of points in this scatter plot over here. And you can go ahead and drag and drop different features, and you can make different visualizations on that. Now what we've done is that we know that there are 1,917 counties in my cluster 1. So I am going to do is that I'm going to see that among these 1917, how many were in favor for Hillary Clinton and how many were in favor for Bernie Sanders. So in cluster number 1, you can see clearly Hillary Clinton is the winner, and Bernie Sanders only has got 764, whereas she got 1,153. Similarly, in cluster 3, again, Hillary Clinton is the winner with 9, and Bernie Sanders with 1. Then it 2, she's also got 388, and Bernie Sanders was 363. So this was a very close call. And again, in 0, you've got 119 and 30. And then we went ahead and created a line chart also of the word distribution for Hillary Clinton and Bernie Sanders. So in keys, we have selected prediction. The values here are WHC and WBS, the sum that we have got over here. So definitely Bernie Sanders is lagging behind. So even though you don't have that table for you, you can also find it out according to this line chart. So you can see that in cluster 0, even again, Hillary Clinton was ahead of Bernie Sanders. In cluster 2, there was a very neck-to-neck competition, and you can see it in the graph year. So this represents cluster 2, and so you can see you have a neck-to-neck competition. And again, in cluster 3, they have got neck-to-neck competition. So this describes the distribution of votes for Hillary Clinton and Bernie Sanders, and definitely Hillary Clinton knows ahead, and that's why, of course, she won the primary elections. So again, you can go ahead, and we have created the same graph. It's only just area graph instead of a line graph. The key here are state and candidates. So I've got states and candidates over here, and the values is counties. Once, if you just hover onto this bar chart, you can see that in Connecticut, Bernie Sanders won 115 counties. In Connecticut, Hillary Clinton won 55 only. So in Florida, Hillary Clinton is 58, and in Florida, Bernie Sanders is 9. And here you can see in the Maine, Bernie Sanders won 462. So Bernie Sanders got a majority of votes for Maine. So you can also classify it state-wise. You can find out which are the states. And as Donald Trump, now you will know that which are the states that you can target, right? So you know that in Maine, a lot of people voted for Bernie Sanders, and maybe Hillary Clinton is not popular. So you can go ahead and lead out. So as Donald Trump's party member, you can just advise him to go in Maine and carry out different campaigns because Hillary Clinton is not so popular there. So maybe it would be a little easier to get votes from the people in Maine. So this is what you can make a conclusion from, and it might not be very accurate, but this will be very close. The thing is that you can make different charts. You can make bar charts, you can make pie charts, so whatever counties won have made in the bar chart. So here it is in a pie chart. It looks better, but it's not maybe as insightful. I just placed it so that I can show you you can make pie charts also. So these are the insights that you can make after analyzing your U.S. county data. And this is what you can tell Donald Trump. These are the different suggestions that you can actually go and tell Donald Trump that she is popular among the foreign people and the people who speak different languages. She is popular among the Hispanic people, and then in Maine, she lost a lot of counties. She almost lost all of the counties in Maine. So these are different insights that you have got, and then you can tell your superior or your employer who has hired you to do that. So this is what you can present, right? So this is for a very beginner's level, and there are some more analytics that you need to do. I just showed you a few options. You can go ahead and try more in the Democrats section also. And you remember that you have to do it for the Republican Party also. Now let me see what you've learned today. So if you have any questions right now, you can just go ahead and ask me. So does anyone have any questions? So now we will move on and find out the solution for the instant cab use case. You remember that we have got the Uber data set, which contains the pickup time and the location by 2 columns, latitude and longitude, and we have also got the license number for a particular Uber driver. And what we have to do is that we have to find the beehive locations. That is the point where we will find the maximum pickups, and then we will also have to find out what is the peak hour of the day. So this was the entire strategy. So we've got the Uber pickup data set, and then we store the data into HDFS. We will transform the data set and make predictions by using k-means clustering on the latitude and longitude and find out the bee point or beehive point. So now let me open my other notebook, the Uber notebook. So again, the first thing that you have to do is copy the Uber dataset into your HDFS. Now we've done that before explaining to you the U.S. county analysis. So again, the code is kind of the same. The first thing is that, again, we are importing some Spark SQL packages and some Spark ML-lib packages because we are going to use k-means clustering. And you can see vector assembler here again, Spark ML clustering, k-means, and other Spark SQL packages. So then we have to start our SQL context, and we're doing it the same way. Then the first thing, again, we have to define a schema. So now I don't have many fields. I've got only 4 fields if I remember. So the first field was the date and timestamp that defines the time. So we're defining it as DT. And the next field is the latitude, the longitude, and base. Then I'm going to read my data set. This is the path in my HDFS where my Uber data set is there. So I define schema as schema here. The header is true because, again, my data set contains column headers, and I'm going to store in df. So feature calls here is going to be latitude and longitude because I'm going to find out the beehive point, the point where I will get my maximum kick-up from. So again, I have set the input calls as feature calls and output calls as features. So I'm using the assembler to transform my data set, and then again I'm using k-means, and we use the same elbow method. We found out that we should make 8 clusters for this data set, okay? And then we are selecting the prediction column and the output column as predictions, and then we have printed the cluster centers for each cluster. So definitely whatever result we are going to find, the cluster centers will tell me the exact location. So this cluster centers that we will find after k-means is actually the beehive points. This will be the point where I will find maximum pickups, right? So here I have printed my cluster centers, and this defines the latitude and longitude. And this is going to be my location where I'm going to find the maximum pickups. And I got 8 results like that because I got 8 clusters and defined the 8 centers for different clusters. So this is exactly like the K-school problem that I explained to you in k-means. This is exactly what happens just as we found out the center of each cluster, and that is where we are replacing the school or building, the new school. So similarly, this is going to be my beehive point, and this is where I will place my maximum number of cabs, okay? So we found out the beehive points. The next thing we will need to do is we need to find the peak hours, because I also need to know at what time should I place my cabs in the location. So what we're doing now, we are taking a new variable called q, and we are selecting hour from the timestamp column, and then the alias name should be hour, and we're getting it from our prediction or from the result that we got after my k-means clustering. So now we are grouping it, and it will have the different hours of the day, and then it will just show me the pickups at the different hours of the day in the location that we found out are the beehive points. And then we're going to count how many pickups we are going to get from that place, right? So we're ordering it by descending. So the smaller pickup count will be the first, and then the larger will be at the bottom. Similarly, again, we are creating a new variable called t, and we're going to do the same thing. So here what we're doing is we are selecting the time, the hour, the date, the latitude, longitude, prediction, and we filter by hour, which is not null. So we're filtering out the null values from here. So now we have created a table view for categories. So let me show you what the categories contain. Okay, let me just go down. So I've done some few operations here. So let's scroll back up and I'll show you. And again, we have created table views for T and Q also, which is again T and Q, all right? And then I have made some visualizations for each. So then we have created a value P where hour is not null. So again, we have filtered out the null hours, and we have created a new view called P. So here is my hours. This is my count, and in the x-axis that show how many pickups were there, and this contains different hours of the day. And then I have grouped it by prediction. So the size is according to the count. So you can see that the bigger the circle means the more pickups. So you can find out the biggest circle, and you know that you can find the biggest circle as you go along the x-axis, because this is where the count increases. So you can find out the biggest circle would be here, and it lies in my 4th cluster. And you can see that there are 8,915 pickups at the 17th hour of the day, which is around 5 p.m. And so you know that the maximum pickups are around 4 o'clock or 5 o'clock, and this lies all in my 4th cluster. And so it means my peak hours are around 4 or 5 o'clock in the evening, right? So this is what insight we have gained, and you can tell Instant Cab CEO that I have found out that your cabs should be ready around 4 or 5, because that's the time when people go home from offices or they're going out for dinner or something. And this is what another table view looks like, which is T. So here we have latitude and longitude, and this is where we are finding the beehive locations. So I have got the distribution in a scatter plot again, and you can see that we have got very dense points over here it means that these represent the beehive points. So what you can do is that you can just put the US map and scale it according to this scale over here, and then you can exactly find out what is the exact location where you need to put your cabs around the 17th hour or the 16th hour of the day. All right? And you know that we had a lot of rows, but the results are only limited by 10,000 if it's around 10,000 rows. But we obviously had a lot more, and you can check in different clusters. So now we are analyzing cluster 0. So here, if you see this point over here, this lies in cluster 4. And this lies in cluster 5, and this lies in cluster 0, so you can analyze each cluster also. So here I have just laid out the latitude and longitude for my 0th cluster, so you can see here where prediction is equal to 0, and I've selected this from the table view of T. So here you can find out the exact latitude and longitude. And here the latitude is 40.722 and the longitude is negative 73.995. So this is how you can pinpoint location where your cab should be during the peak hours. Again, if you see this distribution, this is just a pie chart that I've created with that tells you what is the count of pickups at each hour of the days, starting from 0 to 23. There are 24 slices in this circle. So you can see that these few slices are the bigger chunks, and this is the 19th hour of the day, which is around 7 o'clock, 6 o'clock, 5 o'clock, 4 o'clock, 3 o'clock, and so on. So you can see the midnight, maybe nobody travels, so maybe your cabs could rest, or you don't have to place any more cabs during this part of the day. These are the insights that you gained. So any questions on that? I think after doing the U.S. county election, this was pretty easy to do, and this is also pretty easy to understand, and the results, which were also much more clear, correct?
What is actually a Hadoop ecosystem? Okay, the very first thing is Hadoop ecosystem is not one tool. It's not a programming language, or it's not a single framework. It is a group of tools that are there which are used together by various companies in various domains for different tasks. Okay, Hadoop alone cannot provide all the facilities or services that are required to process the big data. Okay, so like for example, Hadoop can store big data, Hadoop can process big data up to a certain limit. However, there are much more other requirements that are there. For example, we would like to create recommendation engines over big data. We would like to run clustering algorithms over big data. We would like to get the real-time insights using big data itself, because Hadoop is a batch processing framework, right? So if I want a real-time insight, I would need another tool that can run over HDFS, that can utilize and leverage HDFS, right? The basic thing that you need to understand here is one single tool like Hadoop is not going to solve all your problems. You'll have to use various other tools over Hadoop or along with Hadoop to get rid or get the solution of every problem that you have. Okay, but before that, before doing so, it is important that you know what are the different tools that are there which can work with Hadoop. And in today's session, we'll exactly do that. We'll try and find out what are the various tools that are there which can be used with Hadoop and what functions they can perform in their own domains. We'll now move on to the next slide. Okay, the very first tool that we'll understand is HDFS. Now, as you know, HDFS is nothing but Hadoop Distributed File System. It is the storage unit of Hadoop. HDFS is entirely the Hadoop cluster, which is formed by data nodes. Data nodes are nothing but commodity hardwares, which are cheap hardwares, which can be clustered together using the Hadoop framework, and then an entire file system that gets created on which you can store big data is called Hadoop Distributed File System. Using HDFS, you can store any kind of data, be it structured, be it unstructured, or be it semi-structured. Okay. Now, once you store the data in HDFS, you can view the entire data as a single unit as well. HDFS stores data across various nodes. These nodes are nothing but the data nodes, and it also maintains the log files of what data is stored at which position. So basically, HDFS has got two components. One is the name node and other is the data node. Name node is the one which manages the entire cluster which manages the entire set of data nodes and keeps the information, keeps the metadata of the data that is stored in these data nodes. Data nodes, on the other hand, are the slave machines, the commodity hardwares which actually stores the data. So HDFS is the one which solves the primary problem of storing big data. So it's time we move on and explore the next tool in Hadoop ecosystem, which is Yarn. Now we'll explore Yarn. Now, as the name suggests, it is nothing but a resource negotiator. Okay. The main purpose of Yarn is to allocate resources to run particular tasks over the Hadoop cluster. So Yarn has basically two components. One is the resource manager and the other one is the node manager. As soon as the client submits a job, these resources are nothing but the containers in which the jobs can be executed. Okay, node manager is the one which finally executes the job within these containers and manages the entire thing on the data nodes. Okay, so the resource manager is the master daemon and the node manager is the slave daemon. Apart from that, I would like to tell you one important thing about Yarn. Yarn was introduced in Hadoop 2.0, which enabled various ecosystem tools to connect with Hadoop distributed file system and leverage big data. Okay, so we'll understand this better when we come to the MapReduce slide. Okay, we'll move on to the next slide. So we now come to MapReduce, which is the processing unit of Hadoop. So once the data is stored on Hadoop distributed file system, the next task is to process that data. For doing so, one can use Apache MapReduce. In Hadoop 1.x, MapReduce was the only framework that can be used to process the distributed data that is present on HDFS. However, so Yarn was the next layer over HDFS, and MapReduce now connected with Yarn to allocate resources for executing the MapReduce task. Similarly, many other ecosystem tools or databases now can connect with Yarn and leverage HDFS. Okay, so it happened after Yarn. So essentially it has got two functions. One is the map and the reduce. Map function is used for filtering, grouping and sorting kind of functions, and the result of the map function is then aggregated in the reduce phase and the entire summarized result is dumped on the HDFS itself. So this is how Hadoop MapReduce works. Now it's time we move on to the next slide and we'll explore what is Apache Pig. Apache Pig was a tool that was developed at Yahoo. So it is nothing but a data processing tool that runs over Hadoop, or you can say that it sits on top of the Hadoop. Apache Pig has its own language that is called Pig Latin, which is nothing but a data flow language, or you can call it as an instructional language. For example, if you want to load a data, you have a command like load this data from path, and then you can dump that data or perform various functions like filter or group. Okay. So using Pig Latin, the life of the developers became very easy. They need not write the entire full MapReduce job for executing some processing over the big data. For people who cannot write a MapReduce program or were not comfortable with MapReduce, for them Pig Latin came as a blessing. Or for them, Pig came as a blessing. By using Pig, the task for them became very easy and they were able to leverage big data. It is said that approximately one line of Pig Latin is equals to 100 lines of MapReduce. So just think how much time are you saving there. Okay. You can perform all the ETL operations that you would like to execute over big data using Pig. So I hope this gives you a clear picture how Apache Pig came into picture. What is the importance of Apache Pig? Okay then, we'll move on and explore the next tool in the chain, that is Apache Hive. Apache Hive is one of the most important tools that is there in the Hadoop ecosystem. Apache Hive was developed at Facebook. Now the idea behind Apache Hive was, the time when it was developed, the relational databases were flourishing. These were the databases that were used by most of the organizations, most of the companies. Nobody knew about NoSQL or a file system like Hadoop. Even Facebook had its website on MySQL. So the workforce there mostly was working on MySQL or SQL-like queries or PLSQL. So for Facebook, it was a problem because their workforce was skilled in SQL. However, for writing a MapReduce program, you had to know some other programming language. So what Facebook did is, Facebook came up with a tool that is called Hive. using which you can write SQL-like queries, that is called Hive query language, and execute the same task over the Hadoop cluster and leverage big data. Just like Pig, using Hive, you can write simple SQL-like queries, and the task that you were executing using MapReduce now can be executing using Hive without getting into the complexities of MapReduce. Okay. Even using Hive, you can connect from client applications like Java as well if you have that requirement. Okay. So Hive is one important tool that is used by a lot of people out there who do not want to get into writing the MapReduce program. So let's move on to the next tool, that is 𝐬𝐻 and Spark mlib. 𝐬𝐻 is a machine learning library written in Java. It can be used for creating recommendation engines or clusters of data, or classify your data into various groups. Okay, so all those algorithms that are there in machine learning can be implemented over big data using 𝐬𝐻. Okay, so it provides you a command line interface to achieve the same task. You would have heard about an analysis that is called market basket analysis, which can be easily executed using 𝐬𝐻 over big data. There are various other things like recommendation engine, as I mentioned, which you would have seen in many e-commerce websites like Amazon, Flipkart, or many more. Okay, so all those things can be done using 𝐬𝐻. Now we come on to Spark, which is a leading tool in the Hadoop ecosystem. MapReduce and Hadoop together can only be used for batch processing. That means you're not getting the results in real time. But out there is a requirement for real-time analytics as well, which cannot be done using Hadoop MapReduce, right? In that case, Sparks come into the picture, which can run standalone as well as it can run over the Hadoop cluster and leverage the same big data to provide you real-time insights, right? As well as Apache Spark is almost 100 times faster than Apache MapReduce. Okay, so I hope this excites you, right? So we'll move on to the next slide and explore Apache HBase. So what is Apache HBase? Apache HBase is a NoSQL database that runs over Hadoop. Apache HBase can be used for storing any kind of data that is there. Okay, it could be any structured or unstructured data, and Apache HBase has been modeled after Google Bigtable and can be utilized to store any big data that is there in Hadoop file system. With Apache HBase, you have an advantage, that is you can use HBase as a backend for a website or a web application to query in real time, which cannot be done with tools like Pig, Hive, or MapReduce, or even HDFS. And hence it is a very important addition to Hadoop ecosystem. Okay, so guys, are you clear with this? You can also write a Java application and connect with HBase using the REST APIs, Thrift APIs, or Avro APIs. Okay, now we'll go through another tool that is called Apache Drill. Apache Drill is again an open source application which works well with any distributed environment that is out there. It can work with any NoSQL database or a flat file system. Okay, the advantage with Apache Drill is that it can connect with various NoSQL databases or a flat file system or a simple file itself at the same time. So if you have data stored in various sources, like let's say you have a data stored in Hadoop distributed file system, you have a data stored in HBase, you have a data stored in MongoDB. Every one of them has their own syntax to execute queries on them to retrieve the same set of records. However, using Apache Drill, you can connect to all these databases at a single time, execute one query, and extract the results from all the three databases and use it for your application. Okay, Apache Drill is able to do that because it follows the ANSI SQL, which enables you to write a query that can execute or that can be understood by all the three databases. We'll move on to the next slide, and now we'll explore 𝐾𝐲. Apache 𝐾𝐲 is nothing but a scheduler in the Hadoop ecosystem. Now what does it mean? Let's say you have a MapReduce task that needs to be executed every hour. Now in that case, instead of manually triggering it, what you can do is you can define a workflow in 𝐾𝐲 and schedule your task to be executed after every 1 hour. Okay, when you see, you're doing two things. One is you're defining a workflow that could be one task or it could be a combination of tasks that are executed by various tools like MapReduce, Hive, Pig, etc. in a sequence, as well as you're defining the frequency in which the workflow needs to be executed. Okay, so your life becomes very easy. You need not go and execute or trigger your job every time that it needs to be done. 𝐄𝐲 can do it for you. Along with that, 𝐄𝐲 coordinator is another component that is present in 𝐄𝐲, which ensures that the job or the workflow is only executed when the data is available. So at times, if the data is coming from an external source, automatically it will ensure that as soon as the data is in the system, then only the workflow or the job is executed. So it is an event-based execution that can be triggered using 𝐄𝐲. Okay, let's move on, and we come to Flume. Flume is again one of the most widely used tools which is used for data ingestion into HDFS. Okay, so using Flume you can ingest any kind of data. It could be structured, it could be semi-structured, into the Hadoop distributed file system and perform various processing after that. Flume gives you the capability of extracting data out of social media like Twitter, Facebook, or you can also extract data from servers where logs are getting generated on a regular interval. So Flume can be utilized to extract data from there and move into the HDFS. Okay. Similarly, there could be many other use cases like getting email messages or network traffic, etc. The next tool in the order is 𝐶OOP. 𝐶OOP is again used for data ingestion. However, 𝐶OOP is used between relational database and the HDFS. So using 𝐶OOP, you can move your data from your relational database into HDFS and vice versa. That means you can also move data out of HDFS into an RDBMS. So it mostly deals with structured data. Okay. So if you compare Flume with 𝐶OOP, Flume is mostly used for moving data into the HDFS and deals with streaming data most of the time. However, 𝐶OOP works with structured data and it can move data in and out of HDFS, unlike Flume. So let's move on, and we come to the next tool, that is Solar and Lucene. Okay. So Solar and Lucene is again an Apache project which has been developed in Java. Lucene in itself is a Java library which is for developing search engine and indexers. Okay. Apache Solar is an application that is built using Apache Lucene. So if you want to develop a search engine or you want to implement search onto your website which works very fast using indexing, you can always use Apache Solar to do that. Okay. So this is the main purpose of Apache Solar, which is an application which is developed using Apache Lucene. We come to Zookeeper. As the name suggests, the job of Zookeeper is to ensure coordination between various tools that are there in the Hadoop ecosystem. Okay, so the main purpose of Zookeeper is to ensure that each and every tool is able to communicate with each other without any interruption, so that the entire ecosystem works together in achieving a particular task. Okay, it performs synchronization, it performs configuration management, grouping and naming of all these things. Okay, it also manages all the services that are running in the Hadoop cluster. Okay, so Zookeeper is very important component of Hadoop cluster. If Zookeeper is not there, your services, your daemons, your tools will not be able to interact with each other or communicate with each other, and hence you will get a broken system if Zookeeper fails. Now we come on to the final tool, that is Apache Ambari in the Hadoop ecosystem that we are going to discuss today. So Apache Ambari is a cluster manager. Okay, what does a cluster manager mean, or what does a cluster manager do? Cluster manager manages the Hadoop cluster. Okay, using Apache Ambari you can provision, manage and monitor the Apache Hadoop clusters. Okay, it makes very easy for you to set up a Hadoop cluster and then configure all the services that needs to run over the Hadoop cluster. It could be Apache Spark service, it could be a Hue service, it could be any other service that you need over the cluster, and it can be done very easily using Apache Ambari. So this was basically developed by Hortonworks. A similar tool is developed by Cloudera as well, which is called Cloudera Manager. Okay, however, Cloudera Manager is not an open source tool like Apache Ambari. So Apache Ambari was developed by Hortonworks. However, it was given to Apache later on. A similar tool, which is a proprietary tool developed by Cloudera named as Cloudera Manager, using which you can deploy the Cloudera clusters. However, it is a paid service. Okay. Using Apache 𝐸, you can also monitor health and status of your Hadoop cluster. Okay. Now you know the importance of Apache 𝐸 and how it can be used to make your life easy.
The prerequisites to install Hadoop in Windows operating system are Java. So we all know that Hadoop supports only Java version 8. So firstly, we need to download Java 8 version. Followed by that, a latest Hadoop version, which we need for our operating system, then the configuration files. So these were the prerequisites. Now let's quickly go ahead and download Java 8 version into our local system and also Hadoop. So you can see that this particular web page belongs to Oracle, and here you'll be getting your Java Development Kit number 8. So these are the various versions available for Java 8 for Linux as well as Windows. So we need a JDK which is compatible with Windows. So here you can see that Windows x64 JDK version which will support Windows. So this particular link will redirect you and download JDK 8 for you into your local system. Once you click on it, it will ask you to accept the license terms from Oracle. Now you can just click on download. Followed by this, you will be redirected into a login page where you need to create your own account with Oracle so that you can download this JDK. Don't worry, this account is free of cost. So you can see the JDK is getting downloaded here. So as the JDK is getting downloaded, we shall now move ahead and download Hadoop for our local system. So this particular web page belongs to Apache organization where we can download Hadoop for free. So these are the various versions available for Hadoop, which are 2.10, 3.1.3, 3.2.1 and many more. So we shall select the latest version of Hadoop. But while you're selecting the latest version of Hadoop, please make sure that you're not actually downloading the exact latest version of Hadoop. Here you can see we have 3 different versions. 3.1.3, 3.2.1, 3.1.2. As you can see, 3.2.1 is the latest version. We have to select the version which is earlier to it, which is 3.1.3, because this particular version will be the stable version. Now we shall move ahead and select binary. Once you select binary, you will be redirected into a new web page where you will have a mirror link. Select that mirror link and your Hadoop will be downloaded for your local system. As you can see, Hadoop 3.1.3 tar.gz is getting downloaded. Now here you can see I have successfully downloaded Hadoop version 3.1.3 tar file as well as JDK 8, and those 2 files are successfully moved into my C drive. Now let's install Java first. Now make sure that you create a new folder for Java. So select change, and here select Windows C drive. Then select make new folder. Now rename this new folder as Java, click OK. And now select next. You can see the installation procedure has now been started. You can see Java Development Kit 8 has been successfully installed. Now we shall enter into program files and move our JDK into Java file, because sometimes there will be an error while we set environment variables for Java. So you can see inside program files we have another folder called Java. So inside Java, there you have our JDK. So now what I'll be doing is just moving this JDK into Java file which we have created in C drive, this one. Now you can just delete this Java file from your program files so that you don't have to mess with duplication of Java file. Now you have your Java and JDK in one single file, which is Java, that is you have created in Windows C drive. Now we shall move ahead and set the environment variables for Java. So click Windows and then enter into settings, and inside the settings select system, and inside system just type in environment variables. And there you go. Select the edit the system environment variables option, and you have this dialog box. Here select environment variables, and inside the environment variables you need to set the Java home as well as path for Java. Now select new, and here just type in Java home, and here let us add the location of JDK bin. So here we will add in the variable value, that is the JDK bin location. So our JDK bin location is in the C drive, and inside the C drive we have the Java folder, and inside Java folder we have our JDK 1.8.0, and inside JDK file we have the bin location. So this will be the home location for Java. Select OK, and then now move into the next dialog box, which is the system variables, and inside that select path and select edit. Here create a new path variable, which will be the JDK path, the same location, that is the bin of JDK. Select OK, and now select OK again, and now OK, and close it. Now Java has been successfully installed into our local system. Now let's check Java is functional or not. We can do that by selecting Windows R, and inside Windows R just type in cmd so that you can open your command prompt. Here just type in Java C. If you see the set of files popping up into your terminal, then it means that Java is working properly. So you can see Java is working just fine. Now let us check the version of our Java installed into our local system. So this can be checked by typing in Java space -version. So you can see we have 1.8 version which is running in our local system. Now that we have successfully installed Java into our local system, let us now move ahead and install Hadoop into our local system. You can see that we have downloaded the tar version of Hadoop. So for that, we need to extract it first. Now you can see that the process of extraction has been completely finished, that is 100%, but you have 3 errors. You can ignore these errors. Now just close the extracting process. Then you have your Hadoop file. Now let us rename our Hadoop 3.1.3 as just Hadoop to reduce the confusion. Now that we have successfully extracted Hadoop, let's set environment variables for Hadoop. But before that, let's set the configuration of Hadoop. You can select Hadoop, and inside that you have a file called etc. And inside etc, you have another folder with the name Hadoop. And inside that, you have a set of folders. So out of these all folders, we have 4 important folders. They are core site.xml, then hdfs site.xml, followed by hdfs. We have another one which is mapred site.xml, and lastly the yarn site.xml file. So we need to edit all these 4 different files, and once after we edit these 4 files, we need to edit one last file, which is the Hadoop env Windows command prompt file. So here you're just going to add in the Java home location. Now let's quickly edit all those 4 files. So we have successfully opened our 4 important files, which are core site.xml, mapreduce site.xml, yarn site.xml, hdfs site.xml, followed by the 4 important files. The last file, which is the Hadoop environment.cmd file. Here we are going to set this Java home location. Now let's first set the values for core site.xml. So the values that are changed in core site.xml are the properties. So inside the configuration, I have added one property, which is the file location, that is fs.default file system, and the local host location, that is 9000. Now let us save this core site.xml. Similarly, we need to also edit mapreduce site.xml files. Here inside this, we need to add some properties. As you can see, we have also edited the configuration files of mapreduce site.xml. Let's save it. Now followed by the mapreduce site.xml, we have yarn site.xml. Let's edit this also. As you can see, the yarn site.xml is also been updated. Don't worry about this property file. I will link this in the description box below. You can have the access to it, and you can use the same configuration file and install Hadoop. Followed by yarn site.xml, we have the last one, which is hdfs site.xml. But before editing this particular file, I want you to create a new folder in Hadoop location, which is data. Let's see how to create it. So this particular folder is inside C drive. This is Hadoop, and inside this Hadoop file, you need to create a new folder with the name data. Inside data, you need to create 2 more new files, which are data node and name node. So the first folder will be name node, and now another folder which will be our data node. So now let's copy the location of data node and name node. So this location is the data node location, and followed by that, the name node location. So this particular location will be the name node location. We have the two locations copied onto our clipboard. Now let's go back to the hdfs site.xml file and edit the configurations here. So you can see that we have edited the configuration file of hdfs site.xml, and inside the configuration, we have provided the replication factor, which is the first property, and we have set the value as 1. Since we're using our local system, we might want to save memory, so the replication is only 1, but the default value for the Hadoop replication factor is 3. And followed by the first property, the second property, which is our name node. So we have provided our name node location, which is Hadoop file, and followed by that the data file, and inside that we have the name node. And similarly, the last property, which is the data node property, so here the value is Hadoop data node. Now let's save it. Now that we have successfully edited all our 4 important files, let's get back to Hadoop env.cmd file and edit the Java home location. So for safer side, let's get back to environment variables and get our JDK location. So this particular location is the location for Java home. We might want to remove the bin over here. So only C Java JDK is enough to set the Java home into our Hadoop env.cmd file. Now let's save this particular file and close it. So all the important files have been now successfully edited. Now let's go back to environment variables and set home and path for Hadoop. Now select new and write in Hadoop home. So this particular location, that is C Hadoop bin, is the location for Hadoop home. Now select OK. Now let's get back to path and set path for Hadoop files. In here, let's set up a new path variable, that is Hadoop bin. And now remember to create another path variable, that is your sbin. So to locate sbin, get back into Hadoop and select sbin, and this will be the location or path value for your sbin. Select that and edit a new variable in path and paste it. So that's how you set sbin, and select OK, OK, and finally another OK, and close the system properties. Now that we have successfully set home and path for Hadoop, let's go ahead and fix the configuration files. You can see that inside the bin folder of Hadoop, we are missing some important configuration files. To fix this, we need a new configuration file, which will be available in the description box below. You can click on that particular link and the required configuration file will be downloaded into your local system, and all you need to do is just replace that particular file with your bin folder in your Hadoop. You can see that there is a new file in my Hadoop, which is Hadoop configuration fixbin1.rar. Now all you need to do is just extract this particular folder. You can see that the folder has been successfully extracted, and all the executable files that you require in your Hadoop have been downloaded successfully. Now, what you need to do is just move this bin into your Hadoop bin. So cut this bin and get back to Hadoop and enter bin. So just delete this particular bin and replace it with a new one. So there you go, you have successfully done it. Now let's delete the unnecessary files. There you go, as good as new. So you have all the executable files and your Hadoop has been set. To check if Hadoop is functioning properly or not, let's open CMD and type in hdfs space name node space hyphen format. If you see a set of files popping up on your terminal, that means you have successfully installed Hadoop. You can see that the name node has been successfully getting started. Now let's open a new terminal and start all the Hadoop daemons. Here, you just need to enter your Hadoop location file, that is cd space Hadoop. Now you are inside Hadoop, and inside Hadoop enter sbin. Now you are inside sbin. Now you need to type in startall.sh or startall.cmd. And there you go, all your daemons are getting started. So that's how you install Hadoop into your local Windows operating system with the version Windows 10.
So what were the problems associated with the relational database system? As I have already mentioned that for a Hadoop developer, actual game starts after the data is being loaded in HDFS, and the developers play around this data in order to gain various insights that are hidden in the data stored in HDFS. So, for this analysis, the data residing in the RDBMS needs to be transferred to HDFS. And you all know that the task of writing MapReduce code for importing and exporting the data from relational database to HDFS is tedious. So this is where Apache Scoop comes to rescue and remove the pain of data ingestion. So why do we need Scoop? It's a known fact that before big data came into existence, the entire data was stored in relational database servers in the relational database structure. But with the advancement of Scoop, it makes the life of developers easier by providing CLI for importing and exporting the data. And Scoop internally converts a command into MapReduce tasks, which are then executed over HDFS. It uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. It also uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. Not only that, it is also very useful for data analysis, high in performance, and provides command line interface. Now let's understand what is Scoop. So before I tell you what is Scoop, let me tell you how the name Scoop came into existence. By now, I hope that you have got an idea that it is used for data transfer between relational database and HDFS. So before I tell you what is Scoop, let me first tell you how the name came into existence. The first two letters in Scoop stands for the first two letters in SQL, and the last three letters in Scoop refers to the last three letters in Hadoop, that is OOP. So it clearly depicts that it is SQL to Hadoop and Hadoop to SQL. That is how the name of Scoop came into existence. So what is Scoop? It is a tool used for data transfer between RDBMS like MySQL, Oracle, SQL, etc. and Hadoop like Hive, HDFS, HBase, etc. It is used to import the data from RDBMS to Hadoop and export the data from Hadoop to RDBMS. Simple. Again, Scoop is one of the top projects by Apache Software Foundation and works brilliantly with relational databases such as Teradata, Netezza, Oracle, MySQL, etc. It also uses MapReduce mechanism for its operations like import and export work and work on a parallel mechanism as well as fault tolerance. As I have already mentioned that it provides command line interface for importing and exporting the data, the developers just have to provide the basic information like database authentication, source, destination, operations, etc. And the rest of the work will be done by Scoop tool itself. Sounds much reliable, correct? Now let's move further and talk about some of the amazing features of Scoop for big data developers. First, full load. Apache Scoop can load whole table by a single command. You can also load all the tables from a database using a single command. Next, incremental load. Scoop provides the facility of incremental load where you can load the parts of a table wherever it is updated. Next, parallel import and export. Again, as already mentioned, Scoop uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. Next, compression. You can compress your data by using gzip algorithm with compress argument or by specifying compression codec argument. Next, Kerberos security integration. So what is Kerberos? It's a computer network authentication protocol which works on the basis of tickets to allow the nodes that are communicating over a non-secure network to prove their identity to one another in a secure manner. Next, load data directly into Hive and HBase. Here, it is very simple. You can load the data directly to Apache Hive for analysis, and you can also dump your data in HBase, which is a NoSQL database. Now let's see what's next. The architecture is one of the empowering Apache Scoop with its benefits. Now, as we know the features of Apache Scoop, let's move ahead and try to understand Apache Scoop's architecture and its working. So when we submit our job or a command through Scoop, it is mapped into map task, which brings the chunks of data from HDFS. And these chunks are exported to a structured data destination. And combining all these exported chunks of data, we receive the whole data at the destination, which in most of the cases is RDBMS server. Next, reduce phase is required in case of aggregations, but Apache Scoop just imports and exports the data. It does not perform any aggregations. Map job launch multiple mappers depending on the number defined by the user. For Scoop import, each mapper task will be assigned with the part of data that is to be imported, and Scoop distributes the input data among all the mappers equally in order to achieve high performance. Then each mapper creates a connection with the database using JDBC and fetches the part of the data assigned by the scoop and then writes that data to HDFS, Hive or HBase based on the arguments provided in the command line interface. So this is how scoop import and export works. Like they gather the metadata. Again, it submits only map job. The reduce phase will never occur here. And then it stores the data in HDFS storage. Coming to scoop export, it's the same thing. The data will be reversed back to RDBMS. So here, the scoop import tool will import each table of the RDBMS in Hadoop, and each row of the table will be considered as a record in the HDFS. And all the records are stored as text data in the text files or binary data in sequence files. On the other hand, the scoop export tool will export the Hadoop files back to the RDBMS tables. Again, the records in the HDFS files will be the rows of a table, and those are read and passed into a set of records and delimited with the user-specified delimiter. So this is all about the scoop architecture and its import and export. Now, let's execute some scoop commands and understand how it works. So at the first, we have scoop import. That is, it imports the data from RDBMS in Hadoop. The command goes very simple. Here, you have to just provide the connection for MySQL, your IP address, your database name, your table name, the username for MySQL user. If you have set privileges for password, you can specify the password or it is not required, and the target directory. Now, let's see how to execute. So I'll open my terminal and check whether all my Hadoop daemons are up and running or not. So I can see that all my Hadoop daemons are up and running. So now let's execute scoop help and see whether the scoop has been properly installed or not. So these are the available commands in scoop. Here I will show you the execution and explain you few of these commands. Now this is also properly been set. Now I will open another terminal and connect to MySQL database. The command goes like this. My user is Edureka, so I'm giving it as Edureka. You can give it as root if your user is root. Simple. So now I'm into MySQL database. If you want to create a database, you can create the database by giving this command, create database, database name, etc. As I have already created a database, so I'll just specify show databases command to list the database present in the MySQL database. So now these are the list of database present here. So now I want to use employees database. So I'll give use employees. Database got changed. Now I want to list the tables present in the employees database. So I'll give show tables. So these are the 11 tables present in the database employees. Now let's say I want to use employees table. So what will I do? I'll just give select star from employees. That is table name. So it's just a huge amount of data that is present in this database. So there are these many rows present in this table. Now open the other terminal where you have executed this command, and here I will show you how to import the data present in that table to HDFS. So how we are going to do that? By using scoop import command. The command goes like this. The IP here is localhost, and you know that employees is my database name, and the username will be Edureka, and the table that I have chosen is employees. So I have not set any privileges for password, so I'm not specifying the password over here. So it got executed, and you can see the number of job counters, the MapReduce framework, the input records, output records, etc. So what happens after executing this command? The map task will be executed at the backend. Now let's check the web UI of HDFS. That is, the web UI port for HDFS is localhost 50070. And let's see where the data got imported. One important thing to note, I have not specified target directory. So by default, the data will be imported to this folder, user, Edureka, and employees. So here you can see the 4 different part files where our data got imported. So you might be thinking, why 4? Correct? Here I have not specified the number of mappers. So by default, it takes the number of mappers to 3 and then gives the output in 4 different part files. So let's open the part file and see how the output will be. So here you can see the data is imported from RDBMS to HDFS. There's lots of data being present over here. I'm just scrolling down and it's not coming to an end. Similarly, the output will be same in the other part files as well. So this is all about the simple scope import command without specifying the target directory and the number of mappers. Now let's see how to import the data from RDBMS to HDFS by specifying the target directory. This part remains out to be the same. Now I will do one thing. I'll specify the number of mappers as 1 so that your output will be in just one single part file, and then I will specify the target directory as well. And I will name the target directory as employee 10. Enter. Again, it takes a lot of time to execute because there is a lot of data present in the database. So it got executed and retrieved these many records. Again, you can see the MapReduce framework, the number of bytes written, number of read operations, write operations, etc. Now again, let's go to the HDFS browser and see the output. So I had specified the target directory name as employee 10. So you can see it here. And the output is just in one single part file because I have specified the number of mappers as 1. In this case, you can control the number of mappers independently from the number of files present in the directory. So the entire records will be present in one single part file. So this is the output. Now let me tell you how to import the command using where clause. Here you can import a subset of the table using the where clause in scope import tool. It executes a corresponding SQL query in the respective database server and stores the result in a target directory in HDFS. So this is how the command goes. The same command as before. I'll just change the name of the target directory. I'll specify employee 11 and I will increase the number of mappers to 3. And here I will specify the where clause. So let's give a condition like where the employee number will be greater than 49,000. It should display the output. Enter. So what you expect your output will be. So here it displays the output records of the employees whose employee number is greater than 49,000. So here it retrieved these many records which are above the employee number 49,000. Now let's check the output. So I have specified the target directory name as employee 11. So here you can see the output that it has retrieved the records of employee number which is more than 49,000. So I hope you understand how to do this. Next, let's see how to import all the tables from the RDBMS database server to the HDFS. Here, each table data is stored in a separate directory and the directory name is same as the table name. It is mandatory that every table in that database must have a primary key field. The command will be simple like simple import, but just that you have to remove the table name and you have to replace the import with import all tables. That's all. So it will retrieve all the tables present in the employees. Okay, so it imported all the tables from RDBMS to HDFS. Now let's check the output. Again, I have not specified the target directory file. So by default, it will be in user Edureka, and you can see here it imported all the tables present in the database to HDFS. So these are the various tables present in RDBMS and now it is present in HDFS. So this is how import all tables command works. So this was all about executing import command in various ways. Now let's move further and see how does scope export works. It exports the data from HDFS to RDBMS, correct? Again, the command goes very simple. You have to specify the connection, your table name, username, and instead of the target directory, you have to specify the export directory path. So let's see how it works. One important thing to notify, the target table must exist in the target database. That is, the data is stored as records in HDFS, and these records are read and passed and delimited with the user specified delimiter. The default operation is to insert all the records from the input files to the database using the insert statement. In update mode, 𝐶𝐝 generates the update statement that replaces the existing record in the database. So first we are creating an empty table where we will export our data. I'm going to create a table called employee 0. The primary key value should never be null, so I'm specifying it as not null. So here I created an empty table called employee 0, and now I'll show you how the scope export works. Here, instead of import, I'll make it as export. This is the database name, and I have created a table called employee 0, and I'm going to specify the path for export directory. Simple, that's all. So you can see here it exported all these records into the RDBMS. So now let's cross-check. I'm going to give select count star from the table name that I have specified to export the tables. So you can see the entire records got exported to this table. So this is how the scoop export works. Now let's see how to list the database present in the relational database. Here, you need not even specify the database name because you're going to list the database that is present in the relational database system. So you're going to specify list databases and execute the command. So the databases present in the relational database system is test, JDBC test, employees and information schema. Again, let's cross-check. I'm going to give show databases. It retrieved the same database. So the result tallies. So we can also list the tables present in the database. Let's see how to list all the tables present in the database. Again, it's very simple. You have to just specify the database name, like here, and give list tables instead of import. So you can see that it listed all the tables present in the database, employees. So again, let's cross-check. Show tables. Same thing. And now let's see what is 𝐄𝐝𝐿. In object-oriented application, every database table has one data access object class that contains getter and setter methods to initialize the objects. And 𝐄𝐝𝐿 generates 𝐷AO class automatically. And it also generates the 𝐷AO class in Java based on the table schema structure. So this is a simple command. Let's see how to execute it. Here I will give scoop 𝐄𝐝𝐿 and give the connection and the database name as employees. Then I'm going to specify the table name as well. So it is going to create an employee jar file in which the backend code will be generated. So I'll copy this path and jump into this directory. So you can see here that it created employees class, jar file and the Java object file as well. So now let's open the file system and check for the file. So what was the name of the file? It ends with 539D9. So here is the folder. So in this you can see the object file that is being generated. So this is the backend code that is being generated. So this is all about how the scoop 𝐄𝐝𝐿 works.
What is Apache Pig? So Apache Pig is an abstraction over MapReduce. It is a tool or platform which is used to analyze larger sets of data representing them as data flows. Pig is generally used with Hadoop. We can perform all the data manipulation operations in Hadoop using Apache Pig. To write data analysis programs, Pig provides a high-level language known as Pig Latin. This language provides various operators using which programmers can develop their own functions for reading, writing, and processing data. To analyze data using Apache Pig, programmers need to write scripts using Pig Latin language. All these scripts are internally converted into map and reduced as respectively. Apache Pig has a component called Apache Pig Engine that accepts the Pig Latin scripts as input and converts those particular scripts into MapReduce jobs. So this was the basic introduction to Apache Pig. Now moving ahead, we shall understand the different modes in which Apache Pig functions. There are two particular modes in which Apache Pig functions. Those are the local mode and MapReduce mode. First, we will understand what exactly is local mode. In local mode, Apache Pig is designed to execute in a single JVM and is used for development, experimenting, and prototyping. Here, files are installed and run using localhost. The local mode works on local file system and the input and the output data is stored in the local file system. To access the command or the cron shell in local mode, you need to execute a command called pig-x local. We shall practically execute this in the demo section. Now moving ahead, we shall discuss about the second type of mode in which Apache Pig can be run. That is the MapReduce mode. The MapReduce mode is also known as Hadoop mode. Apache Pig chooses Hadoop mode as its default mode. In this, Pig renders Pig Latin into MapReduce jobs and executes them on a Hadoop cluster. It can be executed against semi-distributed or fully distributed Hadoop installation. Here, the input and the output are present on HDFS. The command for executing Pig in MapReduce mode is pig or pig-x MapReduce. Again, we shall discuss about this particular command in our demo section, where I'll show you both the modes and execute the pig scripts there. Now, followed by the pig modes, we shall understand the ways to execute pig program. So basically, the pig scripts are executed in three particular modes. Those are interactive mode, batch mode, and lastly, the embedded mode. Don't worry, I'll explain to you each of these modes. Firstly, we shall discuss about the interactive mode. In this particular mode, the pig is executed in a grunt shell. To invoke grunt shell, run the pig command. Once the grunt mode executes, we can provide pig Latin statements and command interactively at the command line itself. So the next mode is the batch mode. In this particular mode, we can run a script file having a .pig extension. These files contain the pig Latin commands. So basically what we do is we write the pig command or the pig script and store it in a location. And using the terminal, we will access that particular location and that particular file and run the code present in that file. So this is what happens in batch mode. So followed by that, the last mode is the embedded mode. In this particular mode, we can define our own functions. These functions can be called as user-defined functions. Here, we use programming languages like Java and Python to define our own user-defined functions. So these were the three different modes in which we can execute pig scripts. Now moving ahead, we shall enter into our next topic, that is the features of pig. So there are 5 different and important features of pig. So first up, we shall understand the ease of programming. Writing complex Java programs for MapReduce is quite tough for non-programmers. Pig makes this process very easy. In the pig, the queries are converted into MapReduce processes internally. So obviously, it has grown the ease of programming. Followed by that, the next important feature is the optimization opportunities. So what exactly is optimization? It is how the tasks are encoded permits the system to optimize the execution automatically, allowing the user to focus on semantics rather than efficiency. So followed by the optimization, we have the extensibility. A user-defined function is written in which the user can write their logic to execute over the datasets. So this increases the extensibility of the programmer. Followed by that, the next important feature is it is highly flexible. Apache Pig can easily handle structured as well as unstructured data. So Apache Pig tool is considered to be highly flexible, irrelevant of the data type. Followed by that, the last and important feature is inbuilt operators. Apache Pig contains various types of operators such as sort, filter, joins, and many more, which are inbuilt. So here, the programmer doesn't have to program these functions externally. Instead, he can just directly get an access to those inbuilt functions and execute them. So these were the 5 important features of Apache Pig. So the next topic in our today's discussion is Apache Pig installation into our local system. Now we shall discuss about one of the easiest ways to install Apache Pig into our local system. So today I'll explain you how to install Apache Pig into Windows operating system. So to do this, the easiest way is to download one of the virtual machines. So I would prefer you to download Oracle VirtualBox for this particular task. Followed by that, we shall also download a quick start VM of Cloudera. Don't worry about these softwares, I'll drop down the link for those softwares in the description box below. You can use that and download them. So once after the Oracle VirtualBox is installed into a local system and it is running, this is how it looks like. Now, what we want to do is to add a new virtual machine into our virtual box. So for that, you just need to select import option, and it will give you a new dialog box. And from here, you must redirect to the location where your virtual box is located. So in my system, it's located in F drive, and inside F drive, CCA, Cloudera VirtualBox Cloudera Quick Start VM. So there you go. Now you just have to select open. And before we actually select the button import, you might want to select the RAM and increase its size to at least 8 GB. So I'll just write in 9000 MB, which is just a little above 8 GB. Now we are good to go. Just select the option import and your VirtualBox will be imported. You can see that the Quick Start VM is getting imported. Now you can see that the virtual machine got successfully imported. Now to start it, all you need to do is just click on it and then select the start button. So you can see that the Cloudera Quick Start VM version 5.13.0 has been successfully imported and booted up. Here we are. We have the Quick Start Cloudera VM welcome note. And now if you want to start up with Pig Editor, you might want to log into Hue first or your HDFS. Remember, in Cloudera, the default username is Cloudera and the password also is Cloudera. Now let me tell you, in Cloudera, the default username and password for everything is Cloudera. For example, let's log into our Hue using the username Cloudera and password Cloudera. Now you might want to just select remember to remember your password. And there you go, you have successfully logged into Hue. And now, if you want your query editor for Pig, you can just select the bottom arrow mark, and there you can select editor, and inside editor, you have the editor designed for Pig. Now you are in the window where you can write Pig scripts and execute them. Now we will move ahead into our next topic, and after finishing the theory part, we shall come back into our Cloudera and execute some of the basic operations on Pig terminal. So our next concept is understanding the Pig architecture. So first of all, let us go through the diagram of Pig architecture. The following diagram represents the architecture of Apache Pig. As shown in the figure, there are various components in Apache Pig framework. Let us look at the major components. Firstly, the parser. Initially, the Pig scripts are handled by the parser. It checks the syntax of the script, does type checking and other miscellaneous checks. The output of the parser will be a DAG, which is directed acyclic graph, which represents the Pig Latin statements and logical operators. In directed acyclic graphs, the logical operators of the scripts are represented as the nodes and data flows are represented as edges. And next, the optimizer. The logical plan for directed acyclic graphs is passed to the logical optimizer. This carries out the logical optimizations such as projections and pushdowns. Next comes the compiler. The compiler is used to compile the optimized logical plan into the series of MapReduce jobs. Followed by that, we have the execution engine. Finally, the MapReduce jobs are submitted to the Hadoop in a sorted order. Finally, these MapReduce jobs are executed on Hadoop, producing the desired results. So this was a basic explanation based on Apache Pig architecture. Now moving ahead, we shall understand the major advantages of Apache Pig. So some of the major advantages of Apache Pig are less code. The Pig consumes less than a line of code to perform any operation. So this reduces the number of lines included in the code. Followed by that, code reusability. The Pig code is so flexible enough to reuse it again. You can basically write the Pig script into a file and access the file whenever you need it. So followed by that, The next important advantage of Apache Pig is the nested data types. The pig provides a useful concept of nesting data types like tuple, bag, and map. So these were the few important advantages of Apache Pig. Now we shall move ahead into the next topic, which is about the differences between Apache Pig and Apache MapReduce. So there are basically 4 differences between Apache Pig and Apache MapReduce. So first up, we will begin with MapReduce. In MapReduce, we have low-level data processing. When it comes to Apache Pig, it is considered as a high-level data processing tool. Followed by that, the next important difference between MapReduce and Apache Pig is that we find complex Java programs when we are using MapReduce. But when we come into Apache Pig, we have simple programming scripts, which are shorter in code length and easily understandable. Followed by that, the third difference is the data operations are completely tough and complicated in MapReduce. But in Apache Pig, you don't have to worry about those operations because they're already built in. Next, and the last difference between MapReduce and Apache Pig is Apache MapReduce does not allow nested data types, whereas Apache Pig allows nested data types. So these were the basic differences between Apache MapReduce and Apache Pig. So the next topic is the Pig demo. Here, we will understand all the basic commands in Apache Pig and the basic functionalities which are available in Pig. Now, without further ado, let's quickly begin with our demo for today's session. Now, we have come back to our cloud era that we have installed into our local system. Now, let's start Pig. As we have discussed before, Apache Pig can be executed in 2 modes. They are the local mode and the MapReduce mode. Firstly, we shall execute an example based on local mode. To start Pig in local mode, you need to type in the command pig space -x space local. Firing this command will enable Pig in local mode. As you can see, the command is getting decrypted. Now you can see that it has successfully started the grunt shell in local mode. Now what are we going to execute? We are going to execute a very simple word count program. For this particular word count example, I have considered a basic text, that is the definition of Apache Pig, which happens to be Apache Pig is a high-level platform for creating programs that run on Apache Hadoop. The language for this particular platform is called Pig Latin. Pig can execute its Hadoop jobs in MapReduce, Apache Test, and Apache Spark. So we will consider this particular paragraph, and we will also count the number of words which are included in this particular paragraph. Now let's quickly go back to our terminal and execute our program. So now we have come back to our terminal. Let's clear it using the command Ctrl+L. Now let's quickly start up typing our commands. So as discussed before, we are going to execute this particular program in local mode. So here we are not loading the data into HDFS. Instead, we are considering the local location, which is the local location that is home cloud era desktop word count. Now we're going to run this command and see the output. So the data has successfully loaded. Now we'll execute the next command. So now we're going to tokenize each and every single word in this particular paragraph, and we'll be considering each and every word as a single word, and we are going to separate each and every word by using a space. Now let's fire up this command and see the output. Yeah, the command just got executed, or the script just got executed. Now in the next script, we are going to group the words according to their occurrence. Yeah, even that is done. Now the next script would help us to count the number of words which have been repeated. So even that is done. Now the last script would be dumping the output which is stored in p-word-c, which is pig word count. Now let's enter the command and see the output. You can see some MapReduce jobs that are getting executed, and there you go. We have our output. So the words are a, n, on, for, its, days, Hadoop, Apache, and all those words. And along with them, we also have the number of repetitions of each and every word. For example, we have Hadoop, which is repeated 1 time, and the word Apache is repeated for 4 times, and so on. So with this, now let us move ahead and execute some examples based on Apache's Hadoop mode or MapReduce mode. Now let's close this terminal and open a new one And let's begin executing Hadoop in MapReduce mode. As discussed before, Apache Pig can be executed in both local mode and MapReduce mode. We have already executed some examples based on local mode. Now we shall execute some examples based on MapReduce mode. To do so, we will first load some local data into HDFS. So using this command, I'll be loading my local data, that is pictutorial.csv, into my HDFS, and I'll name it as Edureka in. As you can see, the command is getting deprecated and the data has been successfully loaded. Now let us use cat command and see what exactly is present in that particular data. As you can see, the command got deprecated and the data is a simple CSV file related to students that has ID, name, department, and year. Now let's start Pig in MapReduce mode. To do so, we just need to type in PIG and strike enter. There you go. We have successfully started Pig in MapReduce mode. Now let's execute some commands. So using this command, we will be loading edureka.in, that is the data, the CSV file which we have discussed before, using pig storage as comma separated file, and the schema for the data will be ID as character array, name as character array, department as character array, and year as integer array. Now let's strike an enter and see the output. There you go. The data has been successfully loaded now. Now let's use dump command to see the data what we have loaded. So there you go. The data has been successfully dumped. So this was the data which we have loaded. Now let's move further and execute few more commands. Now we shall use for each command, and for each data present in our data file, we will generate ID, name, and department. There you go. The command got successfully executed. Now let's dump the data using dump command. So pig for each is our variable that stores the data. Now let's type in semicolon and enter. So there you go. The for each command has been successfully executed and we have generated ID, name, and department. Now we shall execute few more examples. Now we shall use descending operator to arrange the data in the form of descending order of ID. So it's been executed. Now let's dump the data and see the output. There you go. We have successfully executed the dump command and the IDs are being arranged in the descending order now, as you can see it. Now this is how the order by descending function works. Now let's move ahead and execute one last command. As you can see here, we are using filter operation. We are going to filter the students based on their department, where department is equals to CSE. So executing this command will give us the students which are inside the department CSE. Now the command got executed. Now let's dump the data using dump command. So there you go. You can see some commands getting deprecated. Here you can see the MapReduce jobs getting executed. So there you go. You can finally see the output, which has the students that belong to the CSE department. Why exactly we needed Apache Hive? It all began in the early 90s when Facebook started. Slowly, the number of users at Facebook increased, that is, nearly 1 billion users, and along with the users increased the data, which is nearly equals to thousands of terabytes of data and nearly 1 lakh queries, then also 500 million photographs uploaded daily. And this was a huge amount of data that Facebook had to process. And the first thing that everybody had in their mind was to use RDBMS. And we all know that RDBMS couldn't handle such a huge amount of data. And neither it was capable enough to process it. And the very next big guy who was capable enough to handle all this big data was Hadoop. Even when Hadoop came into picture, it was not too easy to manage all the queries. It used to take a lot of time to execute all the queries performed. So one common thing that all the Hadoop developers had was the SQL. So they thought to come up with a new solution that has Hadoop's capacity and interface like SQL. That is when Hive came into picture. So now we understand the exact definition of Apache Hive. Apache Hive is a data warehouse software project built on top of Apache Hadoop for providing data query and data analysis. Hive gives a SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop. Also, Apache Hive has data warehousing software utility. It can be used for data analytics. It is built for SQL users, manages querying of structured data, and it simplifies and abstracts the load that is on Hadoop. And lastly, no need to learn Java and Hadoop API to handle data using Hive. So followed by this, we shall understand Apache Hive applications. Apache Hive is used in many major applications. Few of the major applications are as follows. Hive is a data warehousing infrastructure for Hadoop. The primary responsibility of Hive is to provide data summarization, query, and data analysis. It supports analysis of large datasets in Hadoop's HDFS as well as on Amazon S3 file system. Followed by that, we have document indexing with Hive. The goal of Hive indexing is to improve the speed of query lookup on certain columns of a table. Without an index, queries could load an entire table or partition a whole process as rows. This would be troublesome. So, with Hive, we have solved this problem. Followed by that, predictive modeling. The data manager allows you to prepare your data so it can be processed in automated analytics. It offers a variety of preparation functionalities, including the creation of analytical records and timestamp populations. Followed by that, the next important application of Hive is business intelligence. Hive is a data warehousing component of Hadoop, and it functions well with structured data, enabling ad hoc queries against large transactional datasets. Hence, it happens to be a best-in-class tool available for business intelligence and helps many companies to predict their business requirements with high accuracy. Last but not the least, log processing. Apache Hive is a data warehouse infrastructure built on top of Hadoop. It allows processing of data with SQL-like queries and is very pluggable so that we can configure it to provide our logs quite easily. So these were the few important Hive applications. Now, let us move ahead and understand Apache Hive features. The first and the foremost important feature of Apache Hive is SQL type queries. The SQL type queries present on Hive will help many of the Hadoop developers to write queries with ease. Followed by that, the next important feature of Apache Hive is OLAP-based design. OLAP is nothing but online analytical processing. This allows users to analyze database information from multiple database systems at one time. So using Apache Hive, we can achieve OLAP with higher accuracy. Followed by the second feature, we have the third feature which says Apache Hive is really fast. Since we have SQL-like interface in Apache Hive, using this feature on HDFS will help us writing queries faster and executing them. Followed by that, we believe Apache Hive is highly scalable. Hive tables are defined directly in Hadoop file system. Hence, Hive is fast and scalable and easy to learn. Followed by that, it is known to be highly extensible. Apache Hive uses Hadoop file system, and Hadoop file systems or HDFS provides horizontal extensibility. And finally, the ad hoc querying. Using Hive, we can execute ad hoc querying to analyze and predict data. So these were the few important features of Apache Hive. Let us move on to our next topic, where we deal with Apache Hive architecture. The following architecture explains the flow of submission of query into Hive. The first stage is the Hive client. Hive allows writing applications in various languages including Java, Python, and C++. It supports different types of clients such as Thrift Server, JDBC Driver, and ODBC Driver. So what exactly is Thrift Server? It is a cross-language service provider platform that serves the requests from all these programming languages that supports Thrift. Followed by that, JDBC Driver. It is used to establish connection between Hive and Java applications. The JDBC driver is present in the class org.apache.hadoop.hive.jdbc.hive driver. Finally, we come to ODBC driver. So what exactly is ODBC driver? ODBC driver allows the applications that support ODBC protocol to connect to Hive. Followed by that, we have the Hive services. The following are the services provided by Hive. They are Hive CLI, Hive Web User Interface, Hive Metastore, Hive Server, Hive Driver, Hive Compiler, and lastly, the Hive Execution Engine. The Hive CLI or Command Line Interface is a shell where we can execute the Hive queries and commands. Followed by that, the Hive Web UI is just an alternative for Hive CLI. It provides a web-based graphical user interface for executing Hive queries and commands. Followed by that, the Hive Metastore. It is a central repository that stores all the structured information of various tables and partitions in the warehouse. It also includes metadata of column and its type information, the serializers and deserializers, which is used to read and write data, and the corresponding HDFS files where the data is stored. Followed by that, the Hive server. It is referred to as Apache Thrift Server. It accepts the requests from different clients and provides to the Hive driver. Moving on, we shall deal with Hive driver. The Hive driver receives queries from different sources such as Web UI, CLI, Thrift, and JDBC or ODBC drivers. It transfers the queries to the compiler. Followed by that, we have the Hive compiler. The purpose of Hive compiler is to parse the query and perform semantic analysis on the different query blocks and expressions. It converts Hive QL statements into MapReduce jobs. Finally, we have Hive Execution Engine. Hive Execution Engine is the optimizer that generates the logical plan in the form of DAG or directed acyclic graph of MapReduce tasks and HDFS tasks. In the end, the execution engine executes the incoming task in the order of their dependencies. Followed by that, we have the MapReduce and HDFS. MapReduce is the processing layer which executes the mapping and reducing jobs on the data provided. Lastly, the HDFS or Hadoop Distributed File System is the location where the data which we provide is stored. So this is the architecture of Apache Hive. Then moving next, we have Apache Hive components. So what are the different components which are present in Hive? They are, first one, the shell. Shell is the place where we write our queries and execute them. Followed by that, we have Metastore. As discussed in the architecture, the Metastore is a place where all the details related to our tables is stored, like schema, etc. Followed by that, we have the execution engine. So execution engine is the component of Apache Hive which converts the query or the code which we have written into the language which the Hive can understand. Followed by that, driver is the component which executes the code or query in the form of acyclic graphs. And lastly, the compiler. Compiler compiles whatever the code we write and executes and provides us the output. So these are the major Hive components. Moving ahead, we shall understand Apache Hive installation on Windows operating system. So Edureka is all about providing the technical knowledge in the simplest way as possible and later play around with the technologies to understand the complicated parts of it. So now let's try to install Hive into our local system in the most simplest way as possible. To do so, we might need the Oracle VirtualBox, which looks like this. So once after you download Oracle VirtualBox and install it into your local system, the next step would be to download the Cloudera Quick Start VM for your local system. The link to this will be provided in the description box below. Now let's quickly start our Cloudera Quick Start VM with our Oracle VirtualBox. Select Import option and now provide the location where your Cloudera Quick Start VM is existing. In my local system, it is in the local disk drive F. There you go. Select Open and now just make sure your RAM size is more than 8 GB. Just randomly I'm providing 9000 MB, which is just above 8 GB, so that you have a smooth functionality of Cloudera. Now select Import and there you go. You can see that Cloudera Quick Start VM is getting imported. Now you can see that Cloudera Quick Start VM has been successfully imported and it's ready for deployment. You can just double click on it and it'll get started. You can see that Cloudera VM has been successfully imported and it started. And also you can see that we have gone live on Cloudera. You can see all the 𝐸, Hadoop, HBase, Impala, Spark, which are pre-installed in Cloudera. Now our concern would be to start up Hive. So to start Hive, you need to start up 𝐸 first. So let me remind you one thing. In Cloudera, every single password and username is Cloudera by default. So for example, we have got 𝐸 username and password here. So the username, that is the default username for Cloudera's 𝐸 would be Cloudera. And along with that, even the password will be Cloudera. That is by default. So we have got Cloudera and Cloudera as username and password respectively. Let's just sign in. You may select remember option in case if you forget your passwords. So now we are getting connected to 𝐸 and we are live on 𝐸 now. There you go. We've got started our 𝐸. So now we'll enter into HDFS. There we go. We have our Hive here. Now that we have successfully installed Hive into our local system, let us move further and understand a few more concepts in Hadoop. Firstly, we shall deal with the data types. The data types are completely similar to any other programming language which we have. They are tiny int, small int, integer, big int. Similarly, followed by that we have float. And inside Hive, float is used for single precision. And if you want double precision, you can go ahead with double. And followed by that we have a string and boolean, which are completely similar to any other programming languages which we use in this daily life. Followed by that we have Hive data models. So these are the basic data models which we use in Hive, that we basically create databases and store our data in the form of tables. And sometimes we also need partitions. We will discuss each one of these data models in our demo ahead. So we'll first create databases, and inside databases we will be creating tables inside which we will be storing data in the form of rows and columns, and along with that partitions. Partitions, they are like advanced way of storing data. Like if you have, just imagine you're in a school, say standard 1, and inside standard 1 you have sections A, B, C, D. So partition is like you're getting partitions for section A, section B, section C, and section D. You're storing different students in different sections, so that when you're querying for a particular data, for example, say you're searching for a kid called Sam, and you have the section of his class as B. So you just don't have to just search for Sam in all the 4 sections. You can just directly go into section B and call in Sam, and you'll get access to him. That's how partitions work. Followed by partitions, we have buckets. So similar to partitions, even buckets work in the same way. Let's understand each one of these in much better way through a practical demo. After data models, we shall understand about Hive operators. So what are operators? Operators are any other operators that we use in normal programming languages, such as arithmetic operators, logical operators. We shall also go through some examples based on arithmetic and logical operators in Hive in the Hive demo. We will use some arithmetic operations as well as logical operations on the data which we have stored in the form of tables in Hive. We shall go through a brief look on that as well. So before we get started, let's have a brief look on the CSV files that I have created for today's demo. These are the small CSV files that I've personally created using MS Excel, and I've saved them as .csv files. I've made the CSV files to be smaller because just to make sure the execution time consumed is as less as possible. Since we're using Cloudera, the execution time might be a little more. So it's better if we use smaller CSV files. So this is my first CSV file, which is employee.csv, which has employee IDs, employee name, salary, and age. Similarly, we have another employee2.csv file, which has the same details along with one more column, that is the country column. I've included country because we will be using this country column in joins that we will be performing in future. Followed by that, we have the department. So here we have department ID and department name. So we have development, department, testing, product, relationship, admin, and IT support. Similarly, we also have student CSV. This is another CSV file that I have created. This has ID, name, course, and age of the student. Followed by that, we have another CSV. This is student report.csv, which has the reports of a particular student gender, ethnicity, parental education, lunch course, math score, reading score, writing score, and other. So these are the CSV files that we will be using in our demo today. So now let's quickly begin with our demo. So to start Hive, we shall open a terminal. So starting or firing up Hive in Cloudera is really simple. You just have to type in Hive and enter. There you go. Logging initialized using configuration files and etc. The Hive CLI is deprecated and migration to Beeline is recommended. And there you go. Your Hive terminal or CLI has been started. So first, let's try to create a database. To save time, I've already created the document which has all the codes that we will be executing today. So this is the particular file which I will be using today. So don't worry, this file will be linked in the description box below. You can use the same file and try executing the same codes in your personal systems just for practice if you feel so. So just to save time, I've already created the document which has the codes that we are going to execute today. So this code or this file will be attached in the description box below. You can get access to it and you can also execute the same codes in your own personal system to have a practical experience about this particular Hive tutorial. So the first thing that we will be doing today is to create a database. So I'm going to create the database using SQL type commands, which are create database, name of the database, which is Edureka. There you go. The database has been successfully created. So now you can also use the following command to check if your database has been created or not. So show databases will help you to find it. So there you go. You can see the first database, which is a default database, which will be pre-existing. And followed by that, you have our own database, which we have created now, that is Edureka. So followed by this, next we will move ahead and try to create a new table. So when you come into tables, you need to understand there are two types of tables in Hive. They are managed tables or internal tables, followed by that external tables. So what is the difference between these two tables? So internal table or managed table is the default table that will be created whenever you try to create a table in Hive. So for example, if you're trying to create a new table, say Edureka, then Hive considers that particular table as an internal table by default. So when you create an internal table, your data is not secured. Understand this. So when you create an internal table, your data is not secured. In case, just imagine you are working with a team and all your team members have access to your Hive or Hue. So the table has been existing in your Hive and some random newbie or some random inexperienced guy tries to change few things in your table and accidentally he ends up deleting the table. So when you delete the table, then if the table was created using an internal table code, then your data will be erased. So that's the disadvantage of using internal tables. But in case if you create an external table, even if somebody tries to delete your table, the table or the data, whatever is there, will be deleted from their own local system, but not from Hive. So that's the best part of using external tables. Don't worry, we will discuss about internal tables and external tables as well. So first we'll try to create an internal table. So this particular code is based on internal tables. So we are using SQL type command here, which is create table and the table name is employee. And the columns inside our table are ID of the employee, name of the employee, salary and age. So row format has been delimited, followed by that. Since this is a CSV file, so the fields will be terminated by comma. And don't forget, you have to use semicolon. Unless you use semicolon, your code is not complete. So let's fire and enter and see if the table gets created or not. Yeah, the table is created successfully. Now we shall see the table, or let's describe the table. So describing the table means you can see what are the columns which are present in your table. So to describe a table, you can use the keyword describe and name of the table, which is employee. And don't forget semicolon. There you go. So your table has the columns ID, name, salary, age. So those are the four columns which you have included in your particular table employee. Now let's move ahead and see if this particular table is an internal table or managed table, or the other type of table, which is the external table. So to do that, we can just write in describe formatted table name and semicolon. There might be a small issue here. Yeah, there is a typing mistake. That is describe. I missed S. So there you go. We got it. So this particular table is managed table, as you can see here. Now let's move ahead and try out external tables. Let's clear our screen first. You can use Ctrl+L to clear your screen. There you go, we have a clear screen now. Now let's try to create an external table. Creating an external table is completely similar to that of internal table, but the only difference is that you need to add in a keyword which is external. So this particular keyword is used to create an external table. Now let's fire and enter and see if the table gets created or not. You can see the table got created. Now let's try to describe the table, employee 2. Don't forget the semicolon. I'm saying this again and again because most of the times we miss semicolon and we will get an error. So you can see the table got described and we have the following columns inside our table. Now let's move ahead and see if this particular table is an external table or a managed table. To do so, you can type in describe formatted, the same code what we have used earlier, that is describe formatted, name of the table, that is employee 2. Semicolon, don't forget. There is some issue again. I think I've missed something, or maybe a typing error. Yeah, this is a typing error. Yeah, there you go. The table type is external table. So that's how we create an internal table or managed table and external table. So now that we have understood how to create a database and table and the two types of tables that are internal table or managed table, followed by that the second type of table, that is the external table. Now let's try to create an external table in a particular location. So for that you can use the following code, but the only difference is you are specifying the location, that is user Cloudera Edureka employee. EDUEMP is a file that we will be creating in our Hive. So let's fire and enter and see it if it's created or not. Yeah, it's successfully created. Let's go back to Hue and see if the following table is created or not. So one thing you have to remember is when you fire in a command or if you try to create a table, the first folder that will be created is a warehouse. So inside Hive, you have your warehouse, and inside warehouse, you have all the databases that we have created. Our first database was the Edureka database, and after that we have created table which is employee, and the second table is employee 2. So this is in the particular location which is user Cloudera, and the file is employee 2. Let's see that. This was the file. Yeah, sometimes Hue will not show it because of network issues. You don't have to worry about it. You will get back that data. Now followed by this, let us enter into Hue again. So when you come back into Hue, if you have to upload a file into Hue, you can just select this particular option which is plus. So selecting this will give you a dialog box which will be something like this. And here you can just select any of the files which you want to upload into Hue. Now let me select a student report.csv and select open. So there you go, upload is in progress. So the data file has been successfully uploaded. Now if you want to access your data file, you can just click on that. So there you go, you have all your data successfully loaded onto Hue. You can also perform queries on this particular data. You can just select query, and inside that you just need to select editor, and you have various editors over here which is Pig, Impala, Java, Spark, MapReduce, Shell, Scoop, and we also have Hive in here. So if you just select Hive, and there you go, you have the editor here. You can just type in your commands or queries, whatever you have. So you have many dictionaries as well. You can just select any one of those, select, and that's how you write queries on the Hive terminal. Now let's not waste much time here, and we have a lot to learn. So let's continue with the next topics in our today's session. Now we shall try to edit the tables. Now we have created the new table, that is employee 3, and we have named the columns as ID, name, string, salary, age, and float. Now we shall try to make some alterations to our table. So the first alteration that we will try to make to our table is to rename our table as EMP table. You know that our employee table was named as employee 3. Now we are trying to rename it to EMP table. So we are using the keyword alter here. So just fire and enter and see if this is possible or not. Yeah, it is possible. The name has been changed to EMP table. Now let's try if it's completely changed or clearly changed or not. You can just type in describe EMP table. semicolon. If we get the same column names in our description, then it should be changed. So there you go. We can see the same columns here. So we have successfully changed the name to EMP table. Now we shall also try to add in some more columns to our table, which is EMP table. So here we'll try to add in a new column, that is the surname of string data type. So I'm doing that by using the keyword alter, followed by that table. The table name is EMP table, and I'm using the keyword add columns, and the column name is surname, and the data type of that column is string. So now let's fire and enter. And there you go. We have successfully added a new row to our table. Now let's try to describe our table again and see if the column has been successfully added or not. There you go. You can see the last row, which is the surname that we have added most recently. So this is how you can alter the table, and you can also change the names of the existing columns. Let's try to do that one as well. Now what I'm doing is I'm changing the column name to first name. So one of the column name in my table EMP table is the name, which gives me the names of the employees. So since I added surname, I'll change this column name from name to first name. So this is the command that I'm using for that operation right now. Let's fire and enter and see the result. Yeah, the change has been made. Let's describe our table. Don't forget the semicolon. There you go. You can see that earlier we had name. Now it's been changed to first name, and we also have a surname. Let's clear our screen. So that's all for alterations. Now we shall move ahead into our next major topic, or the data model, which is partitioning. So we have dealt with the first two data models, that are databases and tables. So we have learned how to create a database, and we have learned how to create a table. We have learned how to create internal or managed table, and also we have created external table, and also we have learned how to create an external table in a particular location in your Hive and load data to your table, and also how to alterate your tables, the column names, the name of your table, and how to add or delete new columns to your table. So far so good, and now we shall continue with the next type of data model, that is the partitioning. As we have discussed earlier about partitioning, it's completely similar to a school or a college. Just imagine that you are in a college and you are in computer science section. So a college has many branches. So maybe computer science, mechanical, and electronics and communications. So imagine your name is Harry. So if someone comes to your college and if he's looking for Harry, so there are many Harrys in your school. So if the person is asking specifically about you, that is Harry from computer science, then can you imagine how simple is this query? So you don't have to search for electronics and mechanical. You just have to come into the class computer science and search for Harry, and there you go, you're present. So that's how partitions work. To execute commands or to execute queries on partition, we will create a whole new database here. Let's start everything from fresh. So we'll create a separate database for executing our new data model, that is partitioning. So I'm creating a new database, that is Edureka student. So there you go, the database has been successfully created. Followed by that, let's use this database now. To use the database, you just need to add in the keyword use and name of the database. So let's fire and enter, and now we are currently using Edureka student database. Now let's create a table in Edureka student database. So here I'm creating a normal table, that is the managed table. So inside my student table, I'll be having some basic columns such as ID number of the student, name of the student, what is his age, and course. So you're not finding course here because I'm going to partition the table based on course. So here you can find the course. I'm using the keyword partition, and on what terms? So on the terms of course, I'm going to partition students. So we have discussed about our students CSV file, right? So here we have our CSV file, and the courses that this particular institute is offering are Hadoop, Java, Python, and yeah, so these are the courses that this particular institute is offering. So I'm going to categorize, or I'm going to partition these students based on their courses. So this is how I'll be partitioning them using this following code. So basically the table has all the columns, and I'm going to partition the table using course. So let's fire and enter and see the execution of this particular code. The partition has been done. Now all we have to do is try to load in our data. Before that, let's try to describe it. Let's try to see what are the columns present in our particular table student. So as you can see, the course column is present. Don't worry. The code looks that we have messed out course, but we did not mess the course column. It is present in the table. The only thing is that we have just partitioned it based on the course that we are going to offer. Now let's try to categorize the students based on their course. So you can do that by using the following code. We are going to load the data using the command load data local in path. So this particular folder, that is the student.csv, is in my local location. So that is home, Cloudera, desktop, student.csv. And I'm loading the data present in this particular location into the student, which is present in Hive right now. So I'm going to partition the student based on their course Hadoop. Now let's fire in this command and see the output. Yeah, now you can see some map reduce jobs taking place. Yeah, the data has been successfully loaded. Let's now refresh our Hive. You can refresh your Hive or Hue based on two methods. The first one is just clicking refresh button on the URL, or you can also select a manual refresh. This is the manual refresh, and there you go, it's done. You can see the new database, that is the Edureka student database that we have right now created. And inside that you can see the student table that we have created, and there you go, we have the file of students based on course Hadoop. Now we will try to add in few more students based on the course Java. For that, all you need to do is just replace the course name with Java. There you go. Here we had Hadoop course, and now here we have Java course. Just fire and enter and you can see the output. Followed by that, we also had another course, that is Python. So let's also execute a code for that. There you go, Python. So now we have uploaded student details into our Hive, and we have also partitioned using one of our data models, that is partition, into three categories that are based on Hadoop, Java, and Python. Now let's go back to our Hue and see if the three categories are done or not. Yeah, we need to refresh that. There you go, you have successfully refreshed. Still, there is no sign of Java and Python. Maybe a manual refresh could help. Yeah, the manual refresh has resulted in the two new files, which are Java and Python. So you have all the three partitions here, Hadoop, Java, and Python. Just enter them and you can see the student details. And now that we have understood partitioning, sorry, I forgot to mention, we have two types of partitioning, which are dynamic partitioning and static partitioning. So the static partitioning is in static or manual partitioning. It is required to pass the values of partition columns manually while loading the data into the table. Hence, the data file does not contain partition columns. You can see that we have sent the partition columns manually for Python, Java, and Hadoop. But when it comes to dynamic partitioning, you just need to do it once, and all the three files will be automatically configured and the files will be created. So now what is dynamic partitioning? So dynamic partitioning, the values of partition columns exist within the table. So it is not required to pass the values of partition columns manually. Now what is this? Don't worry, we shall execute the code based on dynamic partitioning, and we shall understand this in a much better way. Now let's clear our screen. Now let's start fresh again. Let's try to create a new database for dynamic partitioning, and let's start again fresh. So here we'll be creating a new database, that is Edureka student 2. So earlier we created Edureka student, and now we'll be testing our dynamic partitioning on our new database, that is Edureka student 2. So there you go, the database has been successfully created. Now we shall use this particular database. Currently we were in Edureka student 1 database. Now we'll enter into student 2 database. So we'll use it now. Now we are in Edureka student 2. Now before we start up with dynamic partitioning, we have to set Hive execution to dynamic partition is equals to true. because by default, the partitions that will be taking place in Hive will be static. So we need to convert that into dynamic partition by specifying this particular code. Now we are good to go with dynamic partitioning. Along with that, we need to execute another command which says partition mode would be non-strict. So by default, when you are partitioning using the static partition, the partition mode will be strict. So now you're specifying it to be non-strict. Now let's execute this. So there you go. We have executed the 2 required codes for that. Now let's create a new table. So the name of the table will be Edureka student, that is EDUSTUD, and this will have the same columns, which are the ID of the student, name of the student, course, age, etc. Now we will try to load in the data from our local path, that is home, cloud, or our desktop, student.csv into the table EDUSTUD. So the data has been successfully loaded and the size is 267 KB. Number of files is 1. Now comes the tough part. So here we are going to partition. So we will be partitioning the table based on the same thing, which is the course, and we will be separating the data using the comma. Now let's fire an enter. Now the table has been separated based on course, and now we will be loading the data to this particular table, which is the student part. So this particular table that we have created based on dynamic partitioning, and we are going to partition the data based on course. Now it's been created. So the student part table has been successfully created. Now the only part remaining is to load the data to this particular table. Now we will be writing a code. So using that code, the MapReduce will automatically segregate the data members or the students based on their courses. So the guys which are in Hadoop will be separated. Guys in Java will be separated and loaded into different file, and similarly with Python. Now let's see how to do it using the code. So there you go. We are going to insert into student part, partition based on course, select ID, name, course, age from the table Edureka. So the data will be imported from the table what we have created here, that is Edureka student. So this particular location has the student.csv file. Now let's fire an enter and see if it's created or not. Fine. You can see some of the MapReduce jobs are getting executed. You can see we have 3 jobs. So first one is getting executed. We have 3 because one is for Hadoop, one is for Java, and one for Python. So this will take a little time. So this is the reason why I have chosen smaller CSV files, so to save time. When you take up the course from Edureka, then you can work on real-time data so that you get hands-on experience from real-time, and you can get yourself placed in some good companies with the experience what you gain from this particular course. So the stages have been successfully finished and the data has been loaded. Now let's see what are the data present in the particular table, student part. There you go. You have the output executed here. So these are the data members present in the partition student part. So these are the data members which are separated based on their courses. That is the partition based on their courses, that is Hadoop, Java, and Python. So now that we have understood dynamic partitioning and static partitioning, we shall move ahead into the last type of data model, which is bucketing. Once after we finish the bucketing, we shall enter into some query functionalities of Hive or query operations which can be performed in Hive. And followed by that, we will also learn some functions which are present in Hive and some of the other things like group by, order by, sort by. And finally, we shall wind up the session with joins which are available in Hive. For now, let's get continued with bucketing, the last type of data model present in Hive. So for that, let's again start fresh. We shall create a new database for that. Before that, let's go back to Hue and check if our partition has been made or not. Let's refresh. Also, let us make a manual refresh. So our database was Edureka student 2 database. And inside that, we have the table that is student part. And there you go. You can see the files which are based on the partition. So 22 is for a different course, 23 is for a different course, and 24 is for a different course. And this is the default partition which has all the data members. As we discussed earlier, now let's start with the last data model in Hive, that is bucket. Now we have created a new database, that is Edureka bucket. Now we shall also create a new table for that. Before that, we need to start with this particular database, so we can use the command use Edureka bucket. Now we are in Edureka bucket. Now let's create a new table. So the table name will be Edureka bucket, and it will be containing the ID, name, salary, age of the employees. The table is created. Now let's try to load the data. So the data file that we will be using is the same one, that is the employee.csv. So the data has been successfully loaded into the location. Now comes to the major part, that is the bucketing part. So to start bucketing in Hive, we need to use the command set hive.enforce.bucketing is equals to true. So that's done. Now we will cluster or classify the data present in this particular file using this particular code. So we will be clustering based on the ID, and we will be categorizing them into 3 different buckets. So let's fire in this command and see if it happens. Yeah, that's successfully done. Now we will override the data using the following command. Now we'll be inserting data into this buckets that we have made, that is 3 buckets, and we will override the table using this particular code. There you go. You can see some MapReduce jobs to be taken care of now. So 1 mapper and reducers are 3 for now. So stage 1 is getting done. So we should be having 3 tasks basically. So let's see what's the output. Stage 1 is finished. The process is finished and data has been successfully inserted. Now let's go back to Hive and check if it's done or not. So before that, let's do a refresh. Now a manual refresh would be much better. There you go. We have our database here, which is Edureka bucket. And inside Edureka bucket, we have EMP bucket, and that's our data, employee.csv. There you go. Now let's move ahead and understand the basic operations we can perform in Hive. So for that, let's start fresh again. Let's create a new database. I'm creating a new database for each and every option or each and every operation that I'm performing in this particular tutorial, just to make things or keep things in a sorted manner. So as you can see here in our particular file system, I have separated each and everything, like I have sorted everything. So for bucketing, I've got a separate database, and for partitioning, I've got a separate database, and for understanding how to create database and tables, I've got a separate database for that, just to keep things arranged and sorted. This looks in a much better way. So now let's discuss about the operations that we could perform in Hive. So I'm creating a new database again for this. So the database would be Hive query language. Now let's use this particular database. This creates a habit of learning things in a better way, or it's like a revision for the things what you have performed or learned so far. As you can see, the table has been successfully created. Now let's try to add in some data into this particular location. That is employee data. It's been successfully loaded. Now let's try to see what are the details present in this particular file. We can use in the command select star from the table Edureka employee. So there you go. These are the details or information present in the table Edureka employee. Now we shall see what are the functions that we can perform on this particular file. So since we discussed that the mathematical operations and logical operations can be performed on Hive, so let's try to perform an addition operation. So I'm selecting the column salary, and as we have seen here, the salaries are 25, 30, 40, 20,000 rupees for every employee. Now let me add in 5,000 more to each and every employee. So I'm adding the value 5,000 by using the addition operation. So let's enter. You can see we have added 5,000. So the first element was 25. Now it's 30. So similarly, all the other employees got 5,000 rupees hike all of a sudden. Now let's try to remove 1,000. So to do so, all you need to do is replace the addition operation with a subtraction operation, that is minus, fire and enter, and there you go. Each and every employee lost 1,000. So the initial amount was 25,000, so removing 1,000 from that will result in 24. So this is considering the first initial values. So this is how it's working. Followed by that, let's also perform some logical operations. Let's clear the screen, and yeah, here I'm fetching for the employees who are having a salary equal to or greater than 25,000. So these are the employees which are having the salaries above or equal to 25,000. Similarly, let's execute another one which detects the employees with salaries less than 25,000. So we have got two employees which are having lower salaries, which are Amit and Chaitanya. Fine. So this is how you perform some operations in Hive. So now let's move ahead and understand the functions which you can perform on Hive. So in the same way, let's create a new database again, and let's use this particular database, that is Hive functions. Now let's create a table in this particular database. So the table is employee function and it's created. Now let's try to load in the data. Yeah, the data has been successfully loaded. And now let's see if the data is correctly loaded or not. Yeah, the data is loaded correctly. Now let's try to apply some functions in this particular data. So the first thing, or the first function I'm going to apply, would be a square root function, where I'll be finding out square root of the salaries of the employees. So there you go. The square root of 25,000 was 158 dot decimal numbers. So this is how you perform some basic functions on your data. Now let's try to find out the maximum salary. So yeah, the job is getting executed. You can see some MapReduce jobs here. I think the biggest salary would be from Sanjana. So the maximum salary is 40,000. So this is how it works. Since we are working on Cloudera and the system configuration is limited, the execution speed is a bit low. But if you're working in real time, then this process would take like a few seconds and it's done. There you go. You have the value 40,000 as shown here. So 40,000, the employee name is Sanjana, is the maximum salary. So that's what we got here. Now let's try to find out the minimum salary. So the minimum salary is 15,000, and who would that be? Yeah, it's Chaitanya with minimum salary 15,000. So that's how you do some operations in Hive. Let's execute some more operations, such as converting the names of the employees to uppercase. So you can see the employee names are converted to uppercase here, and similarly, let's try to convert to lowercase. So here you can see we have converted them to lowercase. So this is how you learn technology. You need to play with the technology. Then you'll come to know the advantages and disadvantages. So you can learn the possible ways where you can make things work out. This is how you do it. Now let's move ahead and understand group by function in Hive. So for that, we'll be creating a separate database that is group. Now we will use this particular database, that is group. So we'll type in command use group semicolon. Now we'll create a table. So the table has been successfully created. Now we will load data into this particular table. Now we will use the new CSV file, which will be employee2.csv. Now we are using this particular table because we have an additional column in this particular table, which is the country column. Now, as discussed before, we will be grouping the employees based on country. Let's see our data first. So we have countries such as USA, India, UAE. So these are the three countries that we are having in our CSV file. So we will be categorizing the employees based on their countries. So this is the particular command that we will be using. So maybe I made an error while creating the table. I think I gave a wrong table name here. So let's drop our table. So by mistake, I gave different table, that is employee order. So to drop a table, you just need to use the keyword drop and it's done. Yeah, the keyword table was missing. So you need to type in drop table and the table name, and the table gets dropped. So we were supposed to create a different table, that is employee group. So now let's create a new table, that is employee group. Employee group has been created. Now let's try to add in data into the employee group. So we have used employee 2 here because the employee 2 has another column which is based on country. So the countries that we are having here are India, USA, and UAE. So we will be using the group by function here, and we will categorize the employees based on their countries. So there you go. You can see some MapReduce jobs getting executed. Yeah, there you go. We have categorized the employees based on their countries, that is India, UAE, and USA, and the sum of the salary. So the guys working in India and their summation of the salary is 90,000, and similarly UAE is nearly 1,05,000 and USA is 80,000. Now let's also execute a different command based on group by. So here we'll be using group by function, and we will categorize based on the country as well as the summation of the salary, which is greater than or equals to 15,000. So it's similar to the previous command. So you can see the data got executed and we got the same output. Now let's move ahead and understand order by and sort by methods. So for that, we'll create a new database orders. Now we'll use orders. Now let's create a new table again. So the new table is employee order, and the table got created. Now let's load the data into this particular table. By now, I think you have some good practice of how to create a database, how to create a table, and how to load data into that particular table. So the data got loaded, and now we are going to order the data present in this particular table based on the descending order of their salary. So you're seeing some MapReduce jobs going ahead. So here we'll see the employees ordered based on their salaries in descending order. So the highest salary will be at the first place and the lowest salary will be at the last place. Yeah. So we have Sanjana at the first position with 40,000 as the highest salary, and she's working for UAE. And we have Chaitanya with lowest salary, 15,000, working for India. Now let us also execute another command based on sort by. So first we try to execute a command based on order by. Now let's see the same output using sort by. So basically both work in the same way. So there you go. We have sorted the records based on descending order of salary. Now that we have learned what are the various operations that can be performed in Hive, that are the arithmetic operations, logical operations, and also some of the functions such as maximum, minimum, group by, order by, sort by. So these are the various operations and functions that you can perform in Hive. Now let's move ahead into the last type of operations that can be performed in Hive. Those are the joins. So for that, let's again create a new database. So here I'll be creating a new database, that is Edureka join. And followed by that, let's use this particular database now. For that, we need to use the keyword use, and there you go. We are in Edureka join. Now let's create a new table for that. So the table will be EMP join here. You can see that I forgot to mention semicolon. So now the table got created. Now we shall load the data into this particular table. So now I've created the first table, that is employee table, and I'm loading the employee data into this particular table. Now to perform join operations, we always need two tables. So in this particular database Edureka join, I've already created the first table, that is employee join. Now let's create second table, that is the department table, which will be present in the same database. So this particular table is a department table, which will be having the entities that are department ID and department name. Now let's load the data of department into this particular table. So the data has been loaded. So you can see the employee2.csv had the columns ID, name, salary, age, and country. And similarly, the department.csv has the entities which are department ID and department name. So the department IDs are present here and the names are development, testing, product, relationship, and admin and IT support. Now we have created both the tables and we have loaded the data also. Now we have 4 different joins available in Hive. They are inner joint, left outer joint, right outer joint, and full outer joint. Now let's perform the first type of join, which is the inner joint. So in inner joint, we are going to select the employee name and employee department. And based on the employee ID and department ID, we are going to perform the join operation. That is the first join, inner joint. So you can see some jobs getting executed. So the map reduce task successfully completed. So the first set of join has been successfully finished and the output has been generated. Now let's try out the second type of join, that is the left outer join. So the only difference is that we are using the keyword left outer join. Now you can see one of the job got started. So you can see the output has been generated as well of the left outer join. Now let's move ahead and understand right outer joint. So for right outer joint, you need to use the keyword right outer join. Fire in the command and you can see the jobs getting executed. So you can see the output of right outer joint has been successfully executed or displayed. Now let's type in the last join operation, that is full outer join. So here I'm using the keyword full outer join. Fire in the command and you can see it's getting executed. So the output for full outer join has been displayed here. So this is how the join operations are executed in Hive. So we have learned how to create database, how to create table, how to load data, and the various data models present in Hive that are the tables, databases, partitions, bucketing. And after that, we have also understood various operations that are the arithmetic operations, logical operations, and functions that can be performed in Hive, such as square root and summation, minimum, maximum. And after that, other operations such as group by, sort by, order by, and also the joins that are possible in Hive, which are inner join, left outer, right outer, and full outer. So each and every operation that could be possibly executed in Hive have been displayed in this particular tutorial, and everything is sorted here in the base of databases, and you can get all the details about this. And you'll also get the code that I have used in the description box below, and you can try it out. And also, if you're looking for an online certification and training based on big data Hadoop, then you can check out the link in the description box below. And during the training, you'll get to have real-time hands-on experience with real-time data. You'll learn a lot of things in the training. And so far, so good. Now we shall also discuss some of the limitations of Hive. So Apache Hive limitations. So Hive is not capable of handling real-time data. Hive is capable of batch processing. If you have to work with real-time data, then you have to go with real-time tools such as Spark and Kafka. So it's like Hive will actually take in the data. For example, imagine you're working on Twitter and you have 1 lakh comments on a particular post. So if you had to process those 1 lakh comments, you'll have to first load all those comments into Hive. Then you need to process it. So while you're loading the data from Twitter to Hive, you may also get a few more comments that you will be missed out. So it's not preferable for real time. Hive is preferable for only batch mode processing. So followed by that, it is not designed for online transaction processing. So online transaction processing is something which only works in real time. So Hive cannot support real time processing. So last but not the least, Hive queries contain high latency. Yeah, Hive queries take a longer time to process. As you've seen, I have taken a smaller CSV file and the time consumed to process such a small CSV file was taking so long. So yeah, Hive queries contain high latency. So these are the few important noticeable limitations of Hive.
So this project is based on the e-commerce domain. So let me give you an introduction to this project in context of one of the biggest names of e-commerce platforms, none other than Amazon. So if you have ever shopped from Amazon before, which I presume you must have seen something like this when you click on a product. So you'll view the details of the product, something like this. And as you know, most of the e-commerce organizations do not have any inventory, so they tie up with different merchants. Similar is the case with Amazon. Amazon provides the merchants or the sellers a platform to get connected to the buyers. So when you click on the details of a product, you can see that Amazon gives you something like this. And you also find something like this. There are 28 offers from this price. And if you click on it, you can see the name of the different sellers who are selling the same product at different prices. And the prices they're offering are listed like this. But you can see over here that by default, Amazon has selected the Apache Retail Private Limited for this particular product. So how does Amazon do that? So it is actually based on a merchant rating system. And as a platform, as an e-commerce platform, you have to ensure that you always display the product from the best merchant in order to ensure quality, because you don't want angry customers, right? So it is very important that your customers are satisfied with their product. So you have to choose from different merchants for the same product in order to decide which merchant's product needs to get displayed by default. And hence Amazon has a merchant rating system in order to decide that. And this is what exactly we're going to build. All right. So we're going to make a merchant rating system similar to this. So here is the problem statement. So there are multiple merchants selling the same type of products. As you can see that merchant 1 and merchant 6 are selling the same shirt. Merchant 3 and 4 are selling the same shoes. And similarly, 5 and 1 are selling the same pants. And there are multiple other merchants who are selling the same kind of products. And you have to build a merchant rating system, or the company wants to build a merchant rating system in order to determine which merchant sells the best product so that their product would be displayed by default. And as a big data expert, let's just assume that you were hired by the company as a big data expert, you are assigned this task. So this is now your problem to solve. So the first thing your organization will give you before you start to do your work is the data set. So this is the data set that you're going to get. So this is the transaction data set and has certain fields like transaction ID, customer ID, merchant ID, timestamp when the purchase was made, the invoice number, the amount, and the segment of product that was bought. You have another data set, which is the merchant data. So these are the details about the different sellers or the merchants. So you have got your merchant ID, the tax registration number, the merchant name, their mobile number, start date, email, address, state, country, PIN code, description, longitude, latitude, the location basically. So these are all the details about the merchant that you have in your data set. So let me just show you the data set. So this is the data set that is in your HDFS right now. So here is the transaction data. So here is the transaction data, which is a 2 GB of file, and the merchant data set, which is 20 MB, because as you know, there are many transactions, but a limited number of sellers or merchants. So that is why the size of the data set, the merchant data set, is quite smaller as compared to the transaction one. And to tell you, we haven't actually used the entire data present in the data set. We have just selected a subset or a sub data set, you can say, because the original data set was quite huge. And this was a demo project. So just for your understanding, we have chosen a sub data set. We just took 2 GBs of data out of it. All right. And this is how it exactly looks like. So this is the CSV file of the data set that we have. This is the transactions data. All right. So this is the approach to solve. So the first thing we'll do is that we'll segregate the merchants based on the price of their products and their sales. So we will be segregating them into 4 categories. So the categories are the merchants who are selling products that are below $5,000 or less than $5,000. There is one more category for merchants who sells products between $5,000 to $10,000. Another category of merchants who sells products between $10,000 to $20,000, and another category greater than $20,000 or more than $20,000. We'll be using a simple logic to approach solving this problem. So let's say that if there is a merchant who's selling their products at quite a low price, and you see if he's not making a good number of sales, it means that he is not selling quality products, because if a merchant who's selling the product at quite a less price and people aren't still buying from him, it clearly indicates that his products are not up to the mark. So it's a low rating for a merchant. Similarly, on the other hand, if you see a merchant who is selling their product at quite a high price and yet he has a very good number of sales, so it clearly indicates that his products must be very good, because despite of the higher price, people are still buying from him. So in that case, obviously the rating of the merchant would be also very good. Right? So this is a simple logic that we're going to use in order to rate our merchants or sellers. And you have 3 options to choose from. So you have got Apache Hive, which is a great analytical tool. We have got Hadoop MapReduce and Apache Pig. And today we will be choosing Hadoop MapReduce. So MapReduce is the core component of Hadoop that processes huge amount of data in parallel by dividing the work into a set of independent tasks. MapReduce is the data processing layer of Hadoop. It is a software framework for easily writing applications that processes the vast amount of structured and unstructured data that is stored in your HDFS. HDFS is Hadoop Distributed File System. In Hadoop, MapReduce works by breaking the data processing into 2 phases, map phase and the reduce phase, and that is how exactly it gets its name, MapReduce. So the map is the first phase of processing where we specify all the complex logic business rules. Reduce is the second phase of processing where we specify lightweight processing like aggregation or summing up the outputs. But the question is, why choose MapReduce? Well, I'll give you 2 reasons for it. First is the custom input format. Now, input format is something that defines how your input files are going to be split and read. So in MapReduce, you can create your own custom input format instead of using the default input format. This actually makes handling of your data quite easier, because here we can create our custom input format for transactions and pass it as an argument. Then we have the distributed cache. So distributed cache is nothing but it is a facility that is provided by MapReduce framework to cache files. Files like your text files, archives, jars, etc. that is needed by your application. Let's understand this with an analogy. Just think about it that there are 3 students sitting on a table solving chemistry problems, and they have one periodic table. So you keep the periodic table in the middle of the table so the students, all the 3 students, can refer from the periodic table to see the atomic numbers of different elements and solve their problems, right? So one periodic table, everyone can refer to it and solve their own problems. So this is what distributed cache is. So with distributed cache, you can put the data that will be used by your different data nodes to refer in order to run MapReduce jobs. So we'll be learning more about how to create your custom input format and how to use the distributed cache in the demo part. All right. So before that, let us just understand how MapReduce exactly works. So this is a sample MapReduce job execution with an example. So this is your input file. This is a text input file. So it contains some words. So first, what will happen is that the input will get divided into 3 splits. All right, so I'm taking one sentence at a time. So I have got 3 splits over here, and this will distribute the work among all the different map nodes. Then we will tokenize the words in each of the mapper and give value 1 to each of the tokens or words. So deer 1, bear 1, river 1. Similarly here, car 1, river 1. And now a list of key value pair will be created where the key is nothing but the individual word and the value is 1. So this is the key and this is the value. And this will happen on all the 3 nodes. So the mapping process remains same on all the nodes. So after the mapper phase, a partition process takes place where the sorting and shuffling happens. Here all the tuples with the same key are sent to the corresponding reducer. So all the bear are together, cars are together, deer and river are together. So after the sorting and shuffling phase, each reducer will have a unique key and a list of corresponding values to that key. For example, bear 1, 1, car 1, 1, and so on. Now comes the reducing phase. Now each reducer counts the values which are present in the list of values. So reducer gets a list of values which is 1, 1 for the key bear, and then it counts the number of ones in the list and gives the final output as bear 2. Similarly for car, it's 3, deer 2, river, it will count 2 ones, so 2. And finally, all the output, the key value pairs are then collected and written in the output file. So this is your output file. So it has just combined the result from different reducers, and here is your final output. So I've understood MapReduce with the classic example of the word count program. Now this is the generic execution flow of the MapReduce job. So you have your input file over here. So the data for MapReduce task is stored in input files, and input files typically lives in the HDFS. The format of these files is arbitrary, while line-based log files and binary format can also be used. And you have an input format. Now input format defines how these input files are split and read. It selects the files or other objects that are used for input, and input format creates the input split. So it logically represents the data which will be processed by an individual mapper. One map task is created for each split, and thus the number of map tasks will be equal to the number of input splits. The splits are then divided into records, and each record will be processed by the mapper. Now let's talk about the mapper. So mapper processes each input record from the record reader and generates a key value pair. And this key value pair is generated by the mapper is completely different from the input pair. The output of the mapper is also known as the intermediate output, which is written to the local disk. The output of the mapper is not stored on HDFS, as this is temporary data, and writing on HDFS will create unnecessary copies. So then the mapper's output is passed on to the combiner for further process. The combiner is also known as the mini reducer. So Hadoop MapReduce Combiner performs local aggregation on mapper's output, which helps to minimize the data transfer between mapper and the reducer. Once the combiner functionality is executed, the output is then passed to the partitioner for further work. Now, partitioner comes on the picture if you're working on more than one reducer. And here we have 2 reducers in the example. So if you have one reducer, you don't actually need a partitioner. So the partitioner takes the output from the combiners and performs partitioning. Partitioning of output takes place on the basis of the key and then sorted. So by hash function, a key is used to derive the partition. According to the key value in MapReduce, each combiner output is partitioned, and a record having the same key value goes to the same partition, and then each partition is sent to a reducer. So by using partitioner, it allows to have an even distribution of the map output over the reducer. So after that comes the shuffling and sorting part. So now the output is shuffled to the reduce node. The shuffling is the physical movement of the data which is done over the network. Once all the mappers are finished and their output is shuffled on the reducer nodes, then this intermediate output is merged and sorted, which is then provided as an input to the reduce phase. Now comes the reducer. So it takes the set of intermediate key value pairs produced by all the mappers as the input and then runs a reducer function on each of them to generate the output. The output of the reducer is the final output, which is stored in HDFS. So if you have multiple reducers, the result from different reducers will combine, and that is going to be your final output, which will be written into the HDFS. So this was the MapReduce job execution flow. So we'll also be using the distributed cache. So you'll have different data nodes. Each data node will have their local copy of their data. And if each of the data nodes needs to refer something, we will keep that in the distributed cache. And in this case, we'll be keeping the merchants file. All right, so distributed cache is nothing but think of it as a shared drive, right? So if you have multiple users who wants to have access to one data set, so you can just put it up in the shared drive and all of your users can share the data, use the same data, right? So this is what distributed cache is. So applications specify the files via URLs to cache via the job conf. So I'll be telling you about the job conf later in the demo section. And the distributed cache assumes that the files specified via URLs are already present on the file system at the path specified by the URL and are accessible by every machine in the cluster. So the framework will copy necessary files to the slave node before any jobs are executed on that node. And distributed cache tracks modification timestamps of the cache files. So clearly the cache files should not be modified by the applications or externally while the job is executing. So how will it work? So in our case, we'll be storing the data into HDFS and we'll be executing MapReduce program over that file. So we'll store the merchant data in the distributed cache. Then we'll segregate the transaction data into categories such as less than $5,000, $5,000 to $10,000, $10,000 to $20,000, and greater than $20,000 with the merchant ID. Then we'll use the merchant file from the distributed cache and map the merchant ID with the merchant name. And at last, we'll receive the output as the merchant name with date indicating the number of sales in different categories. Now let us talk about the code sections. So the execution will start from the main method where we'll use the tool runner. So the tool runner can be used to run classes implementing tool interface. So it passes the generic Hadoop command line arguments and modifies the configuration of the tool. Then it will point to the run method, which will point to the run MR jobs. So here we are specifying the driver code. So I'll be telling you about the driver code later on. So next, the execution will move to the mapper class, which is the transaction mapper. The framework first calls the setup method, followed by the map method for each key value pair in the input split. So in setup method, we are loading the cache file and calling a method where we'll be resolving the merchant name from the merchant ID. Next, in the map method, we are creating the object of transaction, which we will be using to catch all the fields of transaction first, and then using the object of aggregate data, we will create the segment of transactions as we discussed before, the 4 segments, less than 5,000, 10,000, 20,000, those segments. At last, using the merchant ID name map, we will resolve or find out the merchant name. The output of the map method would be the key, which will be the combination of merchant name and date of sale, while the value would be in the form of number of sales of different categories. Next, the execution will go to the partitioner code, where we'll have the get partition method, which will send the records with the same key to the same reducer. And at last, the reducer code will execute, which will aggregate the data with the same key and provide the output. So I'll be showing you and explaining you all the codes involved over here in the demo part. All right, now let us move ahead. So first, let me take you through this transaction class where we are defining all the variables corresponding to the transaction file. As you can see, we have got the transaction ID, customer ID, merchant ID, timestamp, invoice number, invoice amount, and segment here. So these are the fields in the transactions, and we have created the variable for the same. So next we are creating the getter and setter methods for each of the variables so as to read the value of the field and we write the value of the field. So as you can see here, we are defining the method get. So get segment, we have got get segment here where we are returning the value of the field, and the set method here, the set segment, where we're writing the value of this field. So similarly, we're doing it for all the variables as you can see here. So we have the get and set for customer ID. So we have the get customer ID method, which returns the value of the field, and we have got the set customer ID, which writes the value of the field. So this is similar for all the fields in our transaction data. So similarly, you can have the aggregate data class, which we have used to create the categories of the product. So here we have fields like order below 5,000, order below 10,000, order below 20,000, order above 20,000, which are nothing but the different categories which we have defined earlier. And similar to the transaction class, here we are defining the getter and setter methods. So we have got get total order method, which returns the value of total order. And we have set total order method, which is writing the value of this field total order. So we have the same for all the different variables that we have defined in the aggregate data class, the getter and setter methods. Then we've got the aggregate writable class. So first here we are creating an object of 𝐿 class. So 𝐿 is basically used to convert Java objects to JSON format. Next, we're initializing the aggregate data object. Now we have two constructors. First one is the basic constructor, which is not taking any argument. The second constructor is taking aggregate data format as an argument and trying to initialize the aggregate data object. Next, we have the getter method for the aggregate data, which will return the aggregate data object. After that, we have the write method, which will write the value of corresponding fields using the getter method of the field. Like for order, get order below 5,000, get order below 10,000, order below 20,000, get order above 20,000. Then you have read fields method, which will be calling the setter method of each field to assign the values to the corresponding field. And at last, we are overriding to string method, which will convert the aggregate data object to JSON and then return the JSON. So I hope you guys are clear with the custom input format. So now let us take a look at the main Java file, which is the merchant analytics job.java. So the main class is the merchant analytics job class, inside which all the jobs will reside. So the execution will start from the main method. So first let us go to the main method. So here we are using tool runner. So tool runner can be used to run classes implementing the tool interface. It passes the generic Hadoop command line arguments and modifies the configuration of the tool. So toolrunner.run method runs the given tool after parsing the given generic arguments. It uses the given configuration or builds one if null. It sets the tool's configuration with the possibly modified version of the conf. Here we are passing the configuration object, merchant analytics job object, which is the main class, and arguments which we will be providing while executing the job. So in our case, there are three arguments. First is the path of the transaction file, second is the path of the merchant file, and third is the output directory. Now we will execute the run method, where we are returning the values of the run mr jobs method. We're also parsing the arguments, that is all the three paths, that is the transaction, merchant, and output directory to the run mr jobs method. Now let us see the run mr jobs method. So here we have the driver code. So first we initialize the configuration object and then we will initialize the control job object. So control job class encapsulates a MapReduce job and its dependency. It monitors the state of the depending jobs and updates the state of this job. And now we are creating the object of job class and we will define the properties of the job. So first we have the set output key class property, where we are defining the output format class of the key, which is text class. Similarly, we're defining the set output value class for output format class of the value, that is the aggregate writable class. Next, we have set jar by class, which tells the class where all the mapper and reducer code resides, which the merchant analytics job in our case. Now we are specifying the reducer class, which is merchant order reducer. And next, we are providing the input directory. So the set input, the recursive method will read all the files from the directories recursively if we are providing the directory path. So first, we're adding the input path of the transaction file, which is present in the argument 0. Then here we are also specifying the input format of the file and the mapper class, that is the transaction mapper. Next, we're talking about all the merchant file from the directory provided in argument 1 and adding this file to the distributed cache using the job.addCacheArchive method. And moving ahead, we are setting the output directory path, which is provided in argument 2, and we are also adding the timestamp as the subdirectory. And at last, we are setting the partitioner class, that is the merchant partitioner. And then we are returning 0 or 1 depending on whether the job has been executed successfully or not. And next, we will take a look at the transaction mapper class, which implements the mapper interface. So it maps input key value pairs to a set of intermediate key value pairs. So maps are the individual tasks which transform input records into an intermediate record. The transformed intermediate records need not to be of the same type as the input records. The Hadoop MapReduce framework spawns one map task for each input split generated by the input format for the job. And mapper implementations can access the job conf for the job via the job configurable and initialize themselves. The framework first calls the setup method followed by map method for each key value pair in the input split. So in the setup method, we are loading the merchant file from the cache using the getCacheArchives method. Then from each file, we are calling the load merchant ID name in cache. So we're calling this method and we are passing the path of the cache files and the configuration objects. Now in this load merchant ID name in cache method, we are initializing the object of file system using the conf. And next we're opening the file and then we're reading the data line by line from the file. Now here first we're removing the quotes from the line and then we're splitting the line using the comma. And at last we're putting the merchant ID and merchant name in the merchant ID name map variable. So here you can see in the merchant file that we have merchant ID at index 0 and merchant name at index 2. So this merchant ID name map will help us in resolving the merchant name from merchant ID. And next, we're defining exception to notify us if the cache file is not read. And at last, we're closing the object of the buffered reader. Now let's talk about the map function. So now the map function will be called. So the input format of key is long writable and the value is text. We're also creating a context of the mapper framework where we will be writing our intermediate output. Now the output format of the key is text and the value is aggregate writable. Again, here we are removing the quotes from the line and then we're splitting the line using comma. So in the split array, we have all the fields of the transaction data stored in the consecutive indexes. Now we are creating an object of transaction class and setting the values of the field using setter methods. And next we are creating the objects of aggregate data and aggregate writable class. Then using transactions getInvoiceAmount field, we are deciding that in which aggregate data field the transaction would lie. We will set the value of corresponding field of the aggregate data object to 1. And next we have the output key, which will contain the merchant name and the date of sale. We will set the value of corresponding field of that aggregate data object to 1. And next we have the output key, which will contain the merchant name and the date of the sale. So merchant ID name map method will return the merchant name from the merchant ID as we just discussed. So we are passing the values as merchant ID and the date. At last, we'll pass the intermediate result in the form of key and value to the context. Next, the result will be sent to the partitioner class, that is the merchant partitioner. So it's over here. So in this class, we are overriding the default getPartition method. And in this method, we are converting the key using hash function and using abs method to return the absolute value of a number. And at last, we're using the modulo function to get the remainder. And now we're dividing it with the number of partitions, so which is nothing but the number of reducers. And in our case, we have specified 5 reducers, so the modulo 5 would return the value between 0 and 4. And one more thing is, the same key would always have the same hash generated, and hence the modulo result would be also the same. And thus the records with the same key will be sent to the same reducer. And based on this, records are sent to the reducer. So next we have the reducer code, and it's over here. So it's the merchant order reducer. The reducer class, as defined in the driver code, resides in the merchant order reducer class. So here we have the key input as text and value input as aggregate writable, which was written by our mapper class. And the output key format is again text, and the output value format is aggregate writable. So here our execution will move to reduce method, where we are passing the input key, value, and context as argument. And here we are again creating the objects of aggregate data and aggregate writable class. And next we are taking the input values. Now here we are calling the setter function of each category, getting the earlier value of that category, and then adding the new value of the new aggregate data object for that category. So it will add the value to the corresponding fields if there is a record with the same key. And at last, we are writing the key and value in context.write method. So I have explained to you the code, so now let us just go ahead and execute it. So first, let us move to the project directory. So we have the pom.xml file, which has all the dependencies that we require in order to run our MapReduce job. So this is the command. So it has my jar file and the path of my jar file. Then I have got my main class over here, which is merchant analytics job. So this is where my main function is. And then I'm passing the 3 paths. So first is my transactions.csv. This is my data set. This is the path of my data set. Then my merchant data, this is the path of my merchant data. And finally, my output directory, which is the result. This is the path over here. So let us just go ahead and execute this command. So the code is run. So here are the different parameters on which this MapReduce job was run. So you can see the details over here. So you can see the number of reduced tasks were 5, since we had 5 reducers. So you can see all the details here. Let me just show you the result now. So it is in the results directory. So there are 2 directories over here, because this was the earlier one that when I had previously executed it. So this is the one that we have got right now. So let me just show it to you. So we have got 5 part files because there are 5 reducers. So I'm just clicking on one part, and you can just click on download. All right, let me just open it. So this is what you get. So you get the merchant name and the timestamp over here, and also the category or the segregation that we did based on the cost of the orders, right? So it was order above $20,000 at this timestamp, and the total order was 1. So this is the format of the result. So we have got a lot of rows. So this is the result. So we have just used a few fields or parameters from the merchant file. We have just used the merchant name and the ID over here. Since this is a sample project, sample demo project, but the scope of this particular project is huge. You can use a lot of other parameters that was mentioned there, like the location. You can analyze it based on locations, based on the time period where the order was placed. So you can take in account different fields and improve this or make this analysis even better by yourself. So when you're doing this project as a part of your course curriculum, so you will be exploring the other fields as well. I have just shown you with just using two fields, the merchant name and the ID.
What is Kafka? In general, Kafka is the producer to the consumer-based messaging system that has a producer that produces the message and the consumer that consumes the message. In between the both, we have brokers that distribute the messages to the consumers and data storage unit, which is none other than Apache Zookeeper. To understand more about Apache Zookeeper and Kafka, you can go through the article link in the description box below. Apache Kafka. So basically, Apache Kafka is an open source messaging tool developed by LinkedIn to provide low latency and high throughput platform for the real-time data feed. It is developed using Scala and Java programming languages. So followed by the definition of Kafka, we shall enter and understand what exactly is a stream. In general, a stream can be defined as an unbounded and continuous flow of data packets in real time. Data packets are generated in the form of key value pairs, and these are automatically transferred from the publisher. There is no need to place a request for the same. The below image depicts the key value pairs that are involved in data stream. Each and every single key value pair is one single unit of data, or it is also called as one single unit of a record. So followed by the stream, we shall understand what exactly is a Kafka stream. Kafka Stream is an API that integrates Kafka cluster to the data processing applications which are either written in Java or Scala. This API leverages the data processing capabilities of Kafka and increases data parallelism. Apache Kafka Stream can be defined as an open source client library that is used for building applications and microservices. Here, the input and the output data is stored in the form of Kafka clusters. It integrates the intelligibility of designing and deploying standard applications using the programming languages such as Scala and Java, with the benefits of Kafka server-side cluster technology. So this was the basic definition of Kafka Stream. Now, let us understand Kafka Stream API in a much better way through its architecture. Apache Kafka Streams internally use the producer and consumer libraries. It is basically coupled with Kafka, and the API allows you to leverage the capabilities of Kafka by achieving data parallelism, fault tolerance, and many other powerful features. The following image depicts the basic architecture of Kafka Stream. Here, you can see the Kafka cluster, which has the input streams and the output streams together. Followed by that, we have Kafka Streaming Application, or the API, which takes care of the queries which are received from numerous applications which are connected to Kafka Streaming Application. Followed by this, we have numerous components present in Kafka Stream architecture, which are as follows. They are input stream, output stream, instance. We have two instances here, which are stream instance 1 and stream instance 2. So inside every instance, we have consumers as well as local state and stream topology. So in Kafka Stream API, input stream and output stream can be one single Kafka cluster. Followed by that, we have a consumer which provides the input and receives the output. And inside the stream instance, we have stream topology and local state. We shall understand about stream topology in a much detailed way in the next slide. Stream topology is all about the directed acyclic graph, or the steps in which the particular process is executed. Followed by that, we have a local state. Local state is none other than a memory location which stores the intermediate data or the result provided by the stream topology. These results are produced after applying various transformations such as map, flat map, etc. So after the data is processed, the tasks are united together and sent back to output stream. So this is how the architecture of Kafka Stream API works. Now let us understand more about stream topology. So this particular diagram explains the stream topology. Here you can see the stream processor. All the dots which are provided here are none other than stream processors. And the line which is connecting them is the stream. The stream is none other than the key value pairs of the data or records. So basically, the input is read from Kafka cluster first. Followed by that, we apply various operators such as filter, map, join, aggregate, and many more. And finally, we will receive the results, which will be sent back to the output Kafka cluster. So this is how the stream topology works. Now, let us discuss the important features of Kafka streams that give it an edge over the other similar technologies. So the various important features of Apache Kafka Streams API are elastic, fault-tolerant, highly viable, integrated security, Java and Scala language support, and exactly once. Don't worry, we shall discuss each one of them in detail. Firstly, we shall discuss about elastic nature. Apache Kafka is an open source project that was designed to be highly available and horizontally scalable. Hence, with the support of Kafka, Kafka Streams API has achieved its highly elastic nature and can be easily expandable. So this was the first feature. Followed by that, we have the second feature, which is about fault tolerance. The data logs are initially partitioned, and these partitions are shared among all the servers in the cluster that are handling the data and their respective requests. Thus, Kafka achieves fault tolerance by duplicating each partition over a number of servers. Followed by fault tolerance, we have the next important feature, that is highly viable. Since Kafka clusters are highly available, they can be preferred to any sort of use cases regardless of their size. They are capable of supporting small-scale use cases, medium-scale use cases, also the large-scale use cases. Followed by highly viable feature, we have integrated security. Kafka has three major security components that offer the best-in-class security for the data in its clusters. They are mentioned as follows. They are encryption of data using SSL or TLS, followed by that authentication of SSL or SASL, and finally the authorization of ACLs. So followed by the security, we have its support for top-end programming language. The best part of Kafka Streams API is that it integrates itself with the most dominant programming languages such as Java and Scala, and makes designing and deploying Kafka server-side applications with ease. Followed by that, we have exactly once processing semantics. Usually, stream processing is a continuous execution of unbounded series of data or events. But in the case of Kafka, it is not. Exactly once means that the user-defined statement or logic is executed only once, and the updates to the state, which are managed by SPE or stream processing element, are committed only once in a durable backend store. So this is how Apache Kafka Streaming API is considered to be having exactly once processing semantics. So followed by the important features, we shall go through a sample program based on Kafka Streams API. So this particular example can be executed using Java programming language, yet there are few prerequisites on this one. One needs to have Kafka and 𝐶𝐝 installed in the local system, and it should be running in the background. If you have not installed 𝐶𝐝 and Kafka in your local system, then I have linked the article in the description box below, which will explain you about the detailed installation procedure of 𝐶𝐝 and Kafka in your local system. Once the 𝐶𝐝 and Kafka are installed into your local system, you need to fire them up. Once the Kafka and 𝐶𝐝 are successfully installed into your local system and they are running in the background, you can go to Kafka and define a producer, topic, and the consumer. Once the producer, topic, and consumer are defined, you can come back to Kafka article and execute the following code in any of the Java editors. The code will count the number of words that you have provided in your text document, and you will receive the output, as shown in the article. Here, the text given to the code was "Welcome to Edureka Kafka training," and this article is based on Kafka Streams. These were the two sentences given to the program, and the output is as shown below. Here, the word welcome is repeated for once, to is repeated for once, Edureka once, Kafka is repeated for 2 times, and training is once. This article is about streams. So all these words are repeated for once. So this is how exactly you should be receiving the output once after you execute the following code in your Java editor. So followed by the example based on Kafka Streams, we can move ahead and understand the important differences between Kafka and Kafka Streams. So now the first difference is that in Kafka Stream API, single Kafka cluster can support as both consumer as well as producer. While on the other hand, in Kafka, we need separate consumer and producer, and Kafka considers consumer and producer as separate entities. The second difference is that in Kafka API, exactly once processing semantics are supported, whereas in Kafka, it is not by default. But you can achieve exactly once processing in Kafka manually. The third difference is that Kafka Streams API is capable enough to perform complex operations, whereas Kafka is designed to perform only simple operations. The fourth difference is that Kafka API supports single Kafka cluster. On the other hand, in Kafka, you need two different clusters for producer and consumer. Followed by that, in Kafka API, the code length is significantly shorter. When you come into Kafka, the code length involved is highly lengthy. The next difference between the both is Kafka Streams API can support both stateless and stateful networks. What are stateless and stateful networks? In stateless networks, the client provides requests to the server and he gets instantaneous reply from server. And here, the cookies or the requests which are sent by the client are not stored. Whereas if you come into stateful network, the client requests the server along with some additional data which is required by the server. In this case, the cookies or the requests which are provided by the client are recorded. So Kafka Stream API is capable to support both stateless and stateful networks. But on the other hand, Kafka is capable only to support stateless network protocols. Followed by that, the Kafka Streams API can support multitasking, whereas Kafka is not capable to support multitasking at a single task level. Followed by that, Kafka Stream API does not support batch processing, whereas Kafka is capable to support batch processing. Kafka Stream API is all about real time, so it doesn't have to support batch processing. So these were the few important differences between Kafka Streams API and Kafka. Now, we shall move ahead and wind up the session with our last topic, which are the important use cases based on Apache Kafka Streams API. Apache Kafka Streams API is used in multiple use cases. Some of the major applications where Streams API is being used are mentioned as follows. Firstly, the New York Times. The New York Times is one of the powerful media in the United States of America. They used Apache Kafka and Apache Kafka Streams API to store and distribute the real-time news through various applications and systems to their readers. Followed by the New York Times, we have Trivago. Trivago is the global hotel search platform. They use Kafka, Kafka Connect, and Kafka Streams to enable their developers to access details of various hotels and provide their users with the best-in-class service at lowest prices. And finally, Pinterest. Pinterest uses Kafka at a longer scale to power the real-time predictive budgeting system of their advertising system. With Apache Streams API backing them up, they have more accurate data than ever.
Now, when we talk about big data, right, the very basic questions a lot of time pops up. What are 5 V's available in big data? Can anybody answer that? Okay, so Ravi want to answer this. Okay, let me unmute Ravi. Ravi, over to you.
First is volume. Volume of size of data, how much it is growing day by day. And next is variety. Varieties, we have 3 types of data, actually structured, unstructured, and semi-structured data. Structured data is nothing but relational database, all those things. Unstructured data is audio, images, files, all this data. Semi-structured is XML files. Velocity is how much fast is growing.
Okay, very much good answer. When big data started, IBM gave a definition with just 3 V's. The 3 V's were volume, variety, velocity. So what was in volume? Volume was when we talk about like in terms of amount of data what we are dealing with, right? For example, today's Facebook is dealing with very huge amount of data, right? When we talk about variety, now is it only Facebook which is generating data? No, right? Even Twitter is generating data. Okay, we are talking about just social media sites. No, Can we talk about medical domains? Yes, in medical domains also the data is getting generated, right? A lot of big data is getting generated. So that's a different variety of data. We have structured data, unstructured data, like we can have videos, audio, right? This is basically going to be called as a variety part. Third component is velocity. Like I said to you, Facebook is just a 10 to 12-year-old company. And imagine the growth they have made it in just 10 to 12 years. Imagine each user is also doing this activity, posting video, audio, all kind of chats, right? So with that, how much data they are dealing with. So that is, you will be calling that velocity. With the pace they have grown up from scratch to this level, with the speed they have grown up to this level is called velocity. Now, these were the three components which were actually going in the market for long. Actually, if you ask me, these three were the major components even go today. But slowly they started realizing there should be a fourth category of data, which is veracity, which also makes sense in big data, because what basically happens is that the data what we receive to us, right? The problem with that data is we cannot expect that the data is going to be always a clean data. There can be a missing data, there can be a corrupted data in middle. How to deal with this scenario? How to deal basically with those scenarios, because that is a component of now that big data, right? So basically that corrupted or the bad data what we are getting, how to or missing data what we are getting. So those category also they decided to call it as veracity. Now people started calling that, okay, these four are the major components, but we are not yet done. Now they started adding few more components. They started saying that no, we are not going to stop with four. When you are saying that veracity can be added, why not value? Because the data what I am getting, I want to know what is the value of data, how much important the data is. Now somebody said that I want to visualize the data. So visualization should also be one of the V factors. Somebody started saying that I want to see the vocabulary of the data or the validity of the data. Now they started keep on adding their V's. But majorly if you talk about, there are four V's which carry some good value. Okay. And usually in any interview, they will not expect you to know all the V's basically. If you know it all good, but they will be just expecting you to kind of understand that, okay, do you know at least four V's which are important? If you can answer that, they will be all good with it. Okay. So sometimes to make it tricky, they ask you 5 V's to just see that how good you are in terms of thinking. Like I generally do that. So when I generally ask questions, I generally see that, okay, that guy must be doing 4 V's. Let me ask 5 V's. Let me see that is he able to think little beyond what he knows already. Moving further. We just talked about something called structured and unstructured data, right? Can anybody explain me the difference between them? What basically are these structured data and unstructured data? Let me add one more component to it. Semi-structured data. That third category of data, let me add it. Now, can anybody explain this? Plus, give me the difference between them as well. Can anybody give me an answer? So, unstructured, not easy to save the data into RDBMS. That's the question's answer from Navesh. Okay. Structured data is basically in row and column format, easy to read and pass from Word. Okay. Narasimha saying structured data, RDBMS data. Unstructured is like log, audio, video. Semi-structured is like XML, JSON. Yes. So a lot of people are giving the right answer here. If we talk about basically structured data, if you go with basically 1980s and all, when this Oracle and IBM and all those companies came up into the market. So if we talk about 1970s, 1980, even at that time they used to have data, but that data was not huge. It was small data. But you will be surprised to hear at that moment it was still a challenge to deal with that data. Though it was having some sort of pattern, it used to have some sort of pattern, and it's a small data. Now people used to think that how to use it, how to manage it, how to store it, where to store it. All those questions were coming in people's mind, and that is where companies like Oracle, IBM and all came up into market with their RDBMS solution. Now they started delivering this solution that you can now store the data, you can now process that data, what sounding like having some pattern, and you will be all good. And today I need not tell you that today where these companies are, like Oracle, Microsoft, and all. In fact, everybody of you must be willing to work for them if given a chance, right? So they are basically now the market giant, and they have given the solution for that. It was going all good, but now slowly what happens? The other kind of data started coming. So the data what they were dealing with was structured kind of data. But with today what, right? Like Facebook came up in few years back, right? Now as soon as Facebook came up into market, I'm just giving an example. Now what you do in Facebook? On Facebook you either upload video, upload audio, pictures, right? So you started dealing with this kind of data. Now, do you think this kind of data can be dealt with my RDBMS system? Answer is no, right? Because now we cannot deal with this kind of data. Now, we cannot call this data as structured data because this kind of data do not even have any sort of pattern. And that is where we started calling it as unstructured data. Means any sort of data which do not have pattern kind of thing, like your audios, videos, we started calling it as unstructured data. Now, the third category of data is semi-structured data, right? So there are some sort of files. For example, let's talk about XML data. So as soon as you see XML, what is it sounding like? Does it have pattern or not? Does it have pattern or not? XML files. Can I get answer? XML files, JSON files, do they have pattern? Yes, it has pattern. So as soon as they say that it has pattern, our first answer which must be coming in your mind should be that, okay, it is a structured data. But now as soon as you tell me that it's a structured data, my question for you is, in that case, can you do all the activities what you can do in RDBMS to XML data? I know you can do today, even you can deal with unstructured data as well because they have introduced glob and 𝐶𝐿OB data types as well. But is that efficient? Can you fire triggers on that? Can you do all the things which you can do with your traditional data? No, right? Now it started sounding to me that it's a unstructured data. Now I am confused. Whether it's a structured data or an unstructured data, that's where they created a third category called as semi-structured. So that they can keep it in the middle. The data which is sounding something of the structured type or as an unstructured type, they created a new category called as semi-structured data. Everybody clear on this part? What basically is structured data, semi-structured data, unstructured data? Okay, moving further. Now, I have another question for you. How Hadoop differs from your traditional processing system using RDBMS? Can I get an answer? What would you answer this part? So these are like warm-up kind of questions. Right? Usually in interview, they will not start with the most complicated questions with you, right? So these are kind of warm up. They want to see your level of expertise, how much you know. So basically that is what is happening here. So can you answer this part? How Hadoop differs from traditional processing system using RDBMS? And friends, I have a request. Rather than raising your hand, please type it on chat window because this chat window I want to make it more interactive. Okay. Okay. I don't know why your name is showing up 𝐄𝐝𝐿, but let's take it. Processing is done where the data is done. No input output. Okay. Hadoop can store and process any type of data where RDBMS can store only relational data. Okay. I can take this answer, comment. Distributed storage and processing. Okay. Good answer, but parallel processing large data, distributed. So few people have just started answering what is Hadoop, right? Don't answer me that. I want difference. Like read the question properly. The question states, give me the difference. Do not tell me what this do and that do. Tell me the clear-cut difference. What are the differences what you notice with RDBMS system? Or I can ask you another way as well. Can Hadoop replace RDBMS system in future? Or maybe is it really replacing right now? Okay, this question can be asked in this way as well. Now can you answer me this part? So I hope anybody who know Hadoop basics should be able to answer this easily. Can I get some answers now? Who want to come on air also can tell me, I can unmute you. If anybody want to come on air and answer, both are complementary to each other. Okay, good. Anyone who want to come on air, want to answer it? This will give you good confidence also when you will be speaking in interview. It cannot replace RDBMS, but I want reason they do that. That's everybody know. It cannot replace RDBMS. But what's the reason? Very good, very good. Asset property is not supported. Or in other words, can I say CRUD operation is not supported? Create, delete, update. Can I do that at pro level? No, right? So that's the major reason you cannot go with Hadoop systems. Like you cannot replace them. Also, when the data is small, okay, if the data is small and it's a structured data, which is going to be more efficient, RDBMS or Hadoop systems? Yeah, that's basically in the latest version they are supporting it, but there are a lot of restrictions in it. That's all about Hadoop 3.x, Shri, which is yet to come in the market properly. So hold on till the time it come up because it has a lot of restrictions. It have right now a lot of restrictions. If you have already seen it, you might be aware of this part. Hadoop is used when we are more of write once, read multiple times. Very good. It follows WORM principle, WORM, which means write once, read multiple times. Okay. So, and one more important difference. RDBMS is free of cost. Is RDBMS free of cost? No, right? So basically it's a licensed software. You need to pay for it, right? But when it comes to Hadoop, it's completely open source. There are companies who are now basically making money with this as well. This because it's an open source community, right? Hadoop is an open source community. Now if you get stuck, where you will get the support? There is nowhere you can get the support. If you get stuck in RDBMS system, there are companies to support you. But what about Hadoop system? If you get, let's say, some bug, who will fix it for you? Right? It's an open source. So basically anybody can come and fix it, but let's say if nobody is fixing your bug, then what, right? So in that case, what people are doing is they are taking support. Okay. So a lot of companies are providing support also on this. So a lot of companies are providing support in terms of now they are making money from it. They say that, okay, if you want to use Hadoop, use it. We will give you the appropriate support, what is required, and you have to pay the money for it. So a lot of companies actually came up like this kind of idea that they are expert in Hadoop, and if you require any support, we will help you with it. So that is one thing which is happening. Now RDBMS can only deal with structured data, right? Basically, when we talk about RDBMS, you cannot deal with unstructured kind of data. Though you can right now deal with it as well, because like somebody just argued with me, he said that, you know, in the latest version of Hive, they're trying to support even CRUD operation, right? But it has a lot of restriction. It's not efficient at of the moment. Till the time it do not come out of the beta phase, we cannot say anything about that. Similarly, RDBMS also started creating CLOB and blob data type, CLOB and BLOB, right? Where what they say that you can now store unstructured data and can work on it, but are they efficient? Answer is no, right? So similarly, like most of the data what you deal with RDBMS is going to be structured data. But when it comes to your Hadoop system, it can be unstructured, semi-structured, as well as structured data, right? Because if you take an example of Hive and all, they deal with structured data, right? So that is one thing which is there. RDBMS, you work just on a single machine, right? So let's say you work on a single laptop where you have RDBMS installed and working. But when it comes to Hadoop, you are working in a distributed fashion, right? There will be multiple machines which can be involved in this case, right? And as I said, in RDBMS, mostly when the data is small, your speed will be very fast. Your computation is going to be very quick. At the same time, with Hadoop, your computation speed is not going to be that great. Okay, with the small data, it's not going to be that great. With Apache Spark pitching into the market, that's a different story. Now they are actually picking up basically because if your memory is good, then you can actually make up a good speed. But with traditional Hadoop, when we talk about MapReduce, the speed are slower. I believe if you have already done the classes of MapReduce, you might have already noticed this thing, right? When you were doing that word count example, right? I hope everybody must have done word count example in MapReduce, right? If you have taken the session, right? So in that case, you might have seen the speed of word count example that it is not that fast. So that is one thing with Hadoop system, if especially the data is smaller, your speed is not comparatively with RDBMS, it's going to be slower. Now, which brings me to another question. Can anybody tell me the components of Hadoop and their services? In fact, I'm showing you all the components. Can you explain these components? What are the components available of Hadoop and what are the services what they provide? Can I get an answer? Very good. So basically when we talk about HDFS, right, it is for your storage side. Okay, very good. Can I get more answers? I believe everybody must be knowing this part. Narsim is saying storage, HDFS is for storage, YARN is for processing cluster. Very good. So you can say YARN is a cluster resource manager, right? There are a few more things. Can I get more answers? Name node manages the cluster, data node stores the data. Okay, I can take this answer, but partially they would. Name node manages the cluster. Can you be a little more explicit in this part? YARN for resource allocation. Very good. RMD saying YARN to run MapReduce. Okay. You can say to schedule MapReduce. That would be better, anyone, right? Rather than saying to run MapReduce, can I say schedule MapReduce? Right? That would be a more appropriate answer here. But a good attempt. Name node has metadata. Very good. Right? Name node has metadata. You can take it of something of this sort. So, in your real-term scenario, right? Let me go back. You can simply relate it with this your real-time life also, right? Let's say in real-time scenario, what happens? Let's say you have a boss. Okay. How many people have kind of a smiling boss? Good boss? Smiling boss, but a cunning boss? Very cunning. He plays with your emotions. When I say emotions, I basically mean that basically he kind of is a very clever boss. Anybody who have it? Okay, Shri have it. Ariban have it. Narishan boss is very innocent. Okay, so let's say this boss. Okay, let me draw a smiling boss. Okay, so smiling boss. Now, usually every boss is smiling, right? They just keep on smiling. But the point to note here is the smile is cunning smile or what kind of smile? Now, what next? Now, these are people who are working, right? Like Shri said, that he reports to such kind of boss, right? So basically, Vivek said he's report to such kind of boss, who's a very clever boss, right? Now, let's say Narasim is saying that okay, fine, his boss is also kind of a very innocent boss, but you know, behind that innocence, there might be a lot of cleverness, I think, right? Behind the scenes. So let's say these three people are reporting to this clever boss. What happens? Boss get projects, right? Boss get project. Let's give the project. Now what happens? Boss will be getting a project. These three people are reporting to this boss, right? So what they will do? So boss usually will distribute the project, right? So let's say the project was P. He distributed into three parts: P1, P2, and the third component he made it P3. What he's going to do? So he is going to keep this P1, he's gonna come to Shri and say that work on P1 project. He will come to Vivek and say that work on P2 project. He will come to Narsim and say that work on P3 project, right? He will say that. Now, all the three people are working properly, given the project on timeline, boss is going to be happy. Now, imagine a scenario that Vivek ditch his boss. Not basically ditch, but maybe he said that, okay, fine, my boss was innocent, so let me take an advantage of him, telling him that, you know, I have a family emergency, I can't work, I have to take leave, something of family emergency kind of thing. Now boss is in trouble, right? Because boss needs to work on these two projects now, right? P1 and P3, who will deliver P2 project? So that is the problem. So boss, what they do? They come up basically with an earlier kind of backups. And boss is clever, remember, right? So boss is going to call Shri in his cabin and say to Shri, you know, you are doing very, very good job, right? So you are doing very good job. I'm thinking to promote you. If you keep on working like that, you will get promoted very quickly in the market for sure. And so you should take up some senior responsibilities from now, right? So as soon as she will not hear anything. She will just hear that, you know, boss is telling me promotion word. Okay, he will just hear promotion word and he will be very happy in his mindset. Suddenly his boss will throw a time bomb because boss is clever. So boss usually what he will say, we just discussed, right, that you are going to take up some senior responsibilities. So can you do one thing now? can you basically take the backup of Vivek first? Now, what happened in this case? Immediately, as he said that, can you take the backup of basically Vivek project? Now Shri came back to Santosh and started arguing, you know, I'm already busy. But he said that you have to just take backup. I'm not asking you to work, right? Just take backup of his work. If you did me, then only you have to work. Anyway, you are a senior candidate. Anyway, boss is boss. Shri will not be able to say no, right? You have to work for it. Similarly, he will go to Vivek. He will do the same stuff, right? Because managers usually tell this, right? Everything is confidential. So same thing he will do with Shri also. This is confidential. Do not speak about it outside. Same way, he will call Vivek, tell the same story, and he will ask now to take the backup of nursing project, right? So he is backing up this project. Similarly, nursing, if you note that, nursing have to back up Shri project. He did the same thing with nursing also, and basically now nursing have to back up this, basically the Shri project. Now, if you note in this situation, if Vivek took has emergency leave, now boss will not face any trouble, right? Now boss will not face any trouble because the work, who has to do the extra work? In fact, who will be sacked in this scenario? Definitely boss is not going to be sacked, but who is going to be sacked in this scenario? Definitely Shri is going to be sacked, right? So definitely Shri is going to face the heat of doing the extra work. Now, similarly, why I'm telling you all this? Because all the components you can relate here. So basically, when we talk about Hadoop, Hadoop is not much different with this. What Hadoop do is, and boss is also keeping one more information, right? So boss is also keeping information of, let's say, what all projects he have, who is working on what project. Let's say Shri is working on project P1 and he have also a backup of P2. So all these details what boss is keeping. When we talk about Hadoop, Hadoop is kind of doing that exactly the similar kind of stuff. When we talk about boss, the first thing is now in Hadoop, what every human is going to be replaced by machines. Now the first component what we were talking about, right? So if we talk about the first component, it was name node. The boss is representing name node. Second component was data node. These employees who are working basically for that boss, you can represent them as data node. The node where you are doing all the processing, because employee do the work, right? Employee do the work, boss only instruct or manage, right? Same story here. So these are your data node. Third property, what is this? Metadata, right? Even name node is going to keep all the data about data. That is called your metadata. Now, what is this? This basically secondary name node and all those stuff. So basically, we require some, like, this is the backup for the data part, right? For this data file P1, P2, P3. But what about this boss backup? So basically, we want to create some backup for that. So that's the reason we keep like passing name node and all those stuff here. Okay. So basically, that is the backup part. That's one of the components. Now, that is means like, let's say in your company, they have also backup of boss. Like if in case if this boss leaves, then I should have all the details. So that's what the backup means here. Now there is one more component called as node manager, resource manager. What are these things? Now what basically a boss is doing, right? What is boss doing? Boss is having the skill set to schedule the job, right? He only decided where to send what, all those details, right? So that you can call it as a part of your resource manager. Kind of scheduling the work. Who is helping you to schedule the work? You can call it as a resource manager, right? Boss have that skill set. Similarly, in your Hadoop, what your resource manager is going to schedule everything up. Now, the last part, right? Node manager. Now, do you think you will be able to work on this project without any skill set? No, right? You require some skill set to work on that project, right? So that skill set you can relate it like a node manager, which is managing your own node. Means you can relate it like your skill set, which is helping you to solve a project, right? So same way, the node manager, you can say that it is managing the whole node. It is kind of helping the node to execute the task. That you can call it as node manager. So this is how you can relate everything. I hope with this example, now it will make your life easy to remember all these components, because this is a very important question in basically in interview questions. They generally ask this question, what are the configuration files, what basically are the main components. So you should be aware of this, and that's the reason I have explained you with this analogy, so that you get some idea and you can relate to it, that if you have to explain in interview, you need not remember all this stuff. Okay, let's move further. Now, So can I ask this question now? What are the main Hadoop configuration files, right? So basically now we are talking about configuration files. This is related to mostly Hadoop administration interface. Now when you talk about Hadoop administrator, right? So there will be few files which you need to configure. So I hope there are people in this batch, in this session also, where people must have done some Hadoop administrator course, right? So I'm assuming that you two people know that. People who do not know that, let's not worry about this. That's the reason I'm answering this directly. So there are few important files here. One is Hadoop environment.sh. This is where you kind of mention all your environmental variables. For example, where is your Java home? Where is your Hadoop home? All those things you define in Hadoop env.sh. Core site.xml. So this file basically you define where your, let's say, your name node is going to run, right? So you need to tell the address of your name node, where you want to run that. Maybe you want to run at some machine at 9000 port. So you will be telling all that in your core site XML. When we talk about HDFS site XML, here we talk about what should be the replication factor, where should physically my data node should be present, where physically my name node should be present. All those things you define in HDFS site.xml. Yarn site and macret site basically defines the map jobs, right? What kind of cluster you are going to use? Are you going to use, let's say, Mesos, or you are going to use Yarn, or you are going to run a local distributed mode? All those things you will be defining here. Also, you will be defining where your resource manager should be running. It should be running on this machine on 9001 port, or whatever port you want to define, right? So those information you will be defining in Yarn site or macred site.xml. Now, last two files are masters and slaves file. In masters file, we usually mention where my secondary name node would be running. When I say secondary name node, it's like a backup. Not exactly I should call it as a backup, but I should call it as a snapshot of the name node. It's something like this, like somebody just copying the metadata. That's it. It's not going to become active as soon as the main node is down. It is copying the data, so that if name node is down, at least I should have a backup. That's it. Slaves, very clear with the name. Where are all my data nodes? What all machines are going to be my data node? That thing we define in my slaves machine. So people who slaves file, sorry. So basically people who have done this Hadoop administrator, you must have basically played with this file. These are the major Hadoop configuration files. There are others as well, right? Like Hive site XML. There are others like HBase site XML. Now these are very much kind of tool specific. So that's the reason they will not be called as the main Hadoop configuration file. When somebody says main Hadoop configuration file, your answer would be these 7 files. You need to remember these 7 files. Basically, these 7 files are the one which you will mention. If you are going for Hadoop administrator interview, expect good number of questions in this. Okay, they will ask you to explain each and every file, how basically you will be, what you do in which file, which I just explained you. Make a note of that, and that is definitely one of the favorite questions of the interviewer when you go for Hadoop administrator kind of role. Moving further, now let's talk about some HDFS questions. In terms of HDFS, now my question is, HDFS stores data using commodity hardware, which has higher chance of failure, which is obvious, right? Because my laptop can be one of the data node, right? Now, definitely my data node can fail at any moment. Now, so how HDFS ensures the fault tolerance capability of the system? Can anybody answer this? Very good work. Can I get more answers? I just answered it beforehand itself. Remember that boss and employee relationship. What that boss was doing? Boss was keeping backup, right? Boss was creating backup. Similarly, Hadoop also create backup, right? That backup in Hadoop word is called replication, right? So basically, if you have, let's say, one block P1, you are creating one backup or two backups of basically that block P1, and that is called replication. This is how Hadoop is ensuring that in case of any failure also, there should be no mistake. Okay, we should not be using data, because in case if one machine fails also, it's okay, it will all work fine for me. So that is what going to happen. So very good. A lot of people have given me the right answer in this case. So block replication is the answer in this case. As you can see in this example also, like block 1 is replicated 3 times. If you notice here, right? So block 1 is replicated 3 times. Similarly, if you notice, block 2 is also replicated 3 times. So these are 4 different machines, and I have replicated block 1, block 2, block 3, block 4, block 5. Okay, so this is what is happening. Edit log and FS image is used to recreate an image. FS image and edit log are 2 different things. These basically are 2 different things. You cannot relate with replication. If you want to know about that, let me just answer you here. So what happens? What is basically this FS image and edit log is? Now, what happens? Basically, you have a name node, right? You have a name node. Where you keep the data in name node? Anybody have answer? Where you keep the data in name node? No, not FS image file. Initially, where you keep the data in name node and not SDFS fetch. I'm asking in name node. This can also be an interview question. Very good, Anand. We keep it in memory. Why? Let me answer this part. Let's say there is one client came up. This is one client. This is client C2. This is client C3. Let's say there are multiple clients. Okay. Now, what is happening in this case is, let's say if this was my name node, and let's say my data in name node is my metadata is, let's say, sitting in disk. What would be the problem here? Let's say client 1 came and want to access some data. What is going to happen? This data will be moved, because any processing which need to happen, right? That happens in memory only, right? Now this data will come to the memory. Once this memory work will be over, then what will happen? Then basically again it will come back to this, right? It will remove it from memory. Now, don't you think there is an input-output operation happening? An input-output operation is always expensive, right? Now imagine if there are multiple clients asking at the same time to the name node. Don't you think there will be too many input-output operations? Every time we need to basically bring the block to the memory and then basically do the stuff and give the output. Now this is something which we want to avoid. In order to avoid, what they came up with the idea is that whatever metadata you are going to create should directly be created and kept in memory. Okay, that is what the idea they came up. They are not going to keep any data in the disk right now. Should be directly kept in the memory, which brings another question for you. In fact, a serious question for you. Now, since you are telling that the data what you can keep in memory, but my RAM is volatile. When I say volatile, I can lose the data at any moment, right? That's very obvious. I can lose the data at any moment because my RAM is always going to be volatile, right? Now I restart my system, my RAM data is gone, right? So I will lose all the metadata. In that case, how I will ensure that I should not lose my metadata? Now what they started doing is, okay, fine, I will create everything in name node memory only, but what I am going to do is, whenever any what I'm going to do, at some interval of time, I will keep on taking a backup of that metadata in disk. Okay, in this I will keep on taking the backup of that data, and whatever backup you are taking in the disk from memory is called your FS image. Now, don't you think this FS image is going to be big, right? This FS image is going to be big. Now, what usually happens is, let's say today my FS image is version FS1. Now, usually the backup what they take is every 24 hours. Just give me 1 minute. If any pop-up kind of thing comes up, it actually stops my system. Now, anyway. Now what basically is going to happen? So what happens is, every 24 hours we usually do this backup. Okay. So basically today we did some backup, tomorrow again this metadata is going to do backup. Now which brings another problem. The problem now again would be, let's say what about in 18th hour or maybe in 23rd hour my machine fails or my RAM fails. In that case I am going to lose that 23-hour data, right? Which is again not good. What should I do for that? Now for that what they came up is that let's create whatever activity is happening here. I will keep on writing in a small file that will be created for, let's say, 24 hours. Okay, and that file is called as edit log. Then what's going to happen for 24 hours, whatever activity you are doing will be getting stored as a edit log. Okay, now what's going to happen after every 24 hours, this FS1 plus edit log is going to be added up and FS2 will be created. Now in this scenario, even if I lose the data in 23rd hour, my edit log will be having the data, and that's how I am ensuring that I am not losing any data. Now are you clear about this edit log and FS image question? I usually see that people are very confused with this logic, that what is FS image? They just kind of bug up and come back and tell that, I know FS image and edit log, but what exactly are they? I have seen people actually kind of confused with this. So I hope you should be very clear now on this. In which file can this backup time interval be configured? So basically wherever the physical location of name node you have configured, and where you configured, I just told you what in HDFS site.xml, right? So wherever you have configured that, so there will be a name directory in it. In that name directory, there is another subdirectory called as current directory. In that current directory, there is another directory called as SNN directory, which is secondary name node directory. There we keep this FS image and edit log files. Clear about this part? So this is where we basically keep that. So can you please summarize the answer once? Sure. You have the same answer of FS image and edit log, but correct. Not exactly two files. One file will be kind of very big file. So that's the reason we are creating a smaller version of that file called as edit log. So that every 24 hours activity we can track. Edit logs are stored in the disk as well. Yes, in the name node. So it's kind of act like a backup. That's it. It's a very good interview question. That's the reason as soon as this question came up, I thought to answer it up, though it's not a part of this slide, but this is a very famous interview question. That can you explain this FS image and edit log? And I can tell you that most of the people fail to explain this. Here memory is RAM, correct. So it's just metadata which is stored, correct. It is just creating a backup of that metadata for the 24 hours activity. That means edit log is getting erased and get new data. Yes. Every 24 hours it just keep on working and kind of erase the data. That's what keep on happening. Okay, or it creates a new version. It depends how your admin have configured that. What if the block data goes more than the memory? Now in that case there is something called as fill. Basically, usually it do not go like that, but there is some concept called as fill. So in that case, there will be some input-output operation happening. You have to deal with that. So then you are making your name node slow. So you have to make sure if you should have a good configuration, but if you do not have it, then in that case, you have to do input-output operation. No other option. Then you have to keep in the disk, and then the data will be having input-output. The window is of 24 backup. Can be changed? Yes, it can be changed. To summarize this, what we just talked about. So in name node, basically you will be storing all the data. But the problem is my RAM is going to be volatile. Now because of that, I definitely want to have a backup. Now we keep a backup in the disk, and that whatever backup we are keeping, we call it as FS image. Now FS image backup is always taken in 24 hour slot. Now another problem started with this. What happened if I lose the data in 23rd hour? In that case, I should again create a smaller version of the file called as edit log. Okay, that will also be a file. Now these things will be added and will be basically given. What can be the RAM size? The bigger, the better. So definitely there is no right answer for it. Now definitely if you say that 32 GB is good, I will say how about 128 GB? If you say 128 GB is good, I will say how about 256 GB, because that will be better. What if I have more metadata? So we can keep on arguing and keep on increasing, right? So the more the RAM, better it is for you. Correct, Vivek. With every change in HDFS, there's a bit log. Yes, correct. That's what basically happened on the. Now let's move further. So I hope now everybody should be clear with this question. Though it's a separate question, but actually it's good that you brought it up, because that's one of the very famous interview questions. So I thought to cover it up. Now, another question. What is the problem in having lot of small files in HDFS? Please provide one method to overcome this problem. Can I get this answer? So what are the problems if you will have small files in HDFS? And also, can you give me basically a method to overcome this problem? change block size. If you change the block size, no, I want a better answer. I want a better answer. Name node memory will be overload. Good, good. Now you are coming to right track. See, RAM will run out. Yeah, because if you will have small data, right? If you will have small files, definitely your metadata is going to be kind of too much, right? Your metadata entry will be too many, and that's how you will be kind of filling up your RAM, right? Of your basically name node. We just learned that every metadata is stored in the RAM of the name node. Now, what are the solution for it? So this is the problem. What is the solution for it? Having larger data block size so that name node will have reasonable metadata to handle. I can take this answer, but I'm expecting a better answer sheet. More map jobs will be used. Yes, that's also one of the problems. Merge them and save them. Very good, George. Okay, what's your name basically? 𝐄𝐝𝐿𝐻. I hope that should not be a real name. I don't know why it's showing me 𝐄𝐝𝐿𝐻. Oh, is this your real name? Because it's telling me twice 𝐄𝐝𝐿𝐻. Okay, so it should be once, right? It should be once, I should call it. Okay, then fine. Now, so I don't know, this is occurring 2 times, so that's why I'm feeling it weird. So increasing block size in HDFS, merging the file with same, and it's easier to read and write the data. Somebody just answered. Can you combine everything? That is the right answer. We can create .har file. In your Windows, what you do? You create a zip file, right? Or a RAR file. Similarly, in Hadoop also you can do that. You can create a .har file, which is called as Hadoop archive. So you can bring all the small files into one folder together, kind of zipping it together. Now basically with that, what's gonna happen? It's gonna just keep only one metadata entry for it. The metadata entry is going to be reduced. How to do that? This is the command. Hadoop archive. Now hyphen archive name, whatever archive name you want to give it, your input location and output location. Okay, so basically this is how you can deal with the smaller files as well. Better to create a zip file. This is what you do in the real time also, right? When you have multiple files of the same type, you zip them, right? Just to keep them together. So the same thing you will be doing in Hadoop as well. Moving further. Now, another question. This is also a very interesting question and an easy question also. Suppose there is a file of size 514 MB stored in HDFS 2.x using default block size configuration and default replication factor. We did an assignment with image files. I'm on LinkedIn as 𝐄𝐝𝐿𝐻. Okay. Now I got it. So using default block size configuration and default replication factor, then how many blocks will be created in total and what would be the size of this block? Okay, before you answer this, can I get an answer? What is the default replication factor and what is the default block size if I'm talking about Hadoop 2.x? Very good. So replication, as everybody said, 3 MB. What is the size? Very good. 128 MB. Now it's very easy to answer. Can everybody answer how to split this 514 MB of file? How to split this 514 MB of file? It's in front of you. You can do the calculation and give me the answer as well. Can I get this answer? Very good. 15 blocks. Lot of people have given me basically less. They said 5 blocks. But don't you think there will be a replication also of all the blocks? So a lot of people who are giving me this answer of 4 blocks is completely wrong, Anand, right? Because there will be a block of 2 MB as well, right? If you notice what's going to happen, this is 128 into 4 is basically 512, right? There will be 2 MB blocks. So there are going to be 5 blocks. Because the replication is 5, now replication factor is 3, so it's going to be 5 into 3, 15 blocks. Okay, this is how basically you will be calculating. This is very famous interview question. Moving further. How to copy a file into HDFS with a different block size to that of existing block size configuration? Can I get an answer? What basically I'm asking is, let's say you have a block size of 128 MB by default. But when you are copying that data, right, when you are doing, let's say, SDFS-put, maybe you want to now use the block size of 32 bit. Not the default of 128 bit. Then what you will do to achieve this. Yes, there is a parameter, but what is that parameter? What is that parameter? Block size? No. Can you see this? DFS dot block size. Okay. So what you need to do? You need to just define the basically the bytes what you want to mention. So 32 bytes is equivalent to this number. Okay. 32 bytes is equivalent to this number. So you need to basically define the bytes what you want to put it up. Now while doing any command, let's say hyphen put or maybe hyphen copy from local, there you can mention this DFS dot block size and whatever number of bytes you want to mention. So you can mention that. Okay. If you want to check the block size, you have another command called as stat. Hadoop fs hyphen stat, and you can see all the statistics related to it. So it will tell you how many bytes it is basically distributed and everything up. You can basically directly use this stat thing and you will get that output as well. Okay. This is sometimes useful in projects, and that's the reason it's a very good interview question as well. Because a lot of time in the projects you don't want to use the default size. You want to change some other number. So in that case, you will be using this, because one way is either you change everything from your configuration files, which is not a good idea to do. So better thing is programmatically you deal with it, and here you can change it by the usage of DFS dot block size. Okay, so it's not block underscore size, correct? I hope you got your answer. What's the mistake you were doing? It should be block size, but you are close. Now, what is a block scanner in HDFS? Can I get this answer? This is usually a question in your Hadoop administration. This is basically what your Hadoop administrators do. So people who have done this Hadoop administration classes, can you answer this? I'm expecting this answer basically from you. Even others can answer. What is a block scanner in HDFS? What is a block scanner in HDFS? Can I get answer? Nobody is answering this. Who all have done administration code or no administrator, Hadoop administration? Can I get answers? Who all have done? I'm not asking you to answer me this part. Just to answer me, who all have done this Hadoop administrator course? Initially, few people mentioned it that I have done this administrator course. You must have read about block scanner. Okay, let me answer this part. Usually in a block scanner, okay, Bird is answering now to check if the block has any empty space left in the block. Okay, one of the answer I can take, but not exact answer. It's not very good. Scan the block and report the remaining spaces. Okay. Again, I can take partially this answer. Not just reclaiming space, but in fact it ensures the integrity of your data blocks. Okay, it basically keep on reporting every data node will keep on reporting to the name node, and it will keep on checking the integrity of the data block. Let's say if any data block got kind of corrupted, right, or maybe the replica value become low, right, all those things it keeps on monitoring and try to rectify it. Okay, so it will basically keep informing the name node. That's the reason this has been usually done by administrators, because they keep on monitoring the health of the data nodes, data block, name node. They're also responsible for this work, right? So this is what they keep on doing in order to make sure that they use block scanner basically to do that. Okay, there is one more way to check the replication factor. Anybody know what is that? There is one more way to check the replication factor. So this is about block scanner, but there is one more way to check the replication factor. Environmental file, no. Heartbeat, no. Heartbeat will just tell that data node is good or not. Data node, right? I'm talking about, let's say, some file got under replicated. In that case, who will kind of inform name node? Let's say block scanner is not there. There is something called as Hadoop load balancer. I'm not sure if you have read about that. Hadoop load balancer. That basically ensures that if your data blocks are not up, right, if they're under replicated or not, that basically informs that, okay, this is under replicated, let me take care of it. Okay, so this is basically the way also to check the under replicated or over replicated blocks. Can multiple clients write into an HDFS file concurrently? Can I get this answer? If somebody asks you this question, can multiple clients write into an HDFS file concurrently? Interesting. I'm getting 1 yes, 1 no. Now 2 yes, 1 no. Okay, 2 no, 2 yes. Lot of yes. Okay. Do you think it should be feasible to write multiple write? I'm not saying reading. I'm saying writing. Notice this part. Now can you answer? Don't you think it will make my file inconsistent? Yes, single file I'm talking about. Don't you think it will make my file inconsistent if I do that? Right? It will make my file inconsistent. So it is not allowed. Basically, it allowed only one writing and multiple reading stuff. So that's the reason. Single file, it will not allow you to basically keep on writing by, at the same time by multiple clients. It will not allow you to basically do that for multiple clients at the same time. Once one client is writing, it will be kind of file will be kind of locked for other clients. Once the client have written, after that only the other clients can write. But everybody can read concurrently. That is one thing which is very important in Hadoop. So writing at the same time is not possible concurrently, but reading is possible. That's how HDFS is basically created. Why they have not allowed multiple writes together at the same time? Because if they do, it can make the file inconsistent. That will be a big trouble, and that's the reason they do not allow you to do concurrent write. Because this is distributed system. If multiple clients will write on the same file, now maybe somebody can overwrite my change, right? So that's the reason they will not allow you to do this. Okay, this is my architecture. Another question. What do you mean by high availability of name node and how it is achieved? Can I get this answer? How this is achieved and what do you understand by high availability of the name node? In fact, I already answered this in boss example. You can answer me this part, not replication. The rack awareness, name node fails or crashes, they will be standby. So, okay, few people are giving right answer now. Active and passive name node. What basically happens in this cases? So let's say if there are two, in fact, let me show you the slide itself. We have drawn it properly. See this part. There will be two name nodes. One will be active name node and one will be passive name node. So what happens is, let's say this is my active name node which is running, okay, and what these data nodes are there at, who are reporting to the active name node. Now we also create a passive name node. Now this passive name node also, these data nodes will be reporting. This passive name node will not be doing anything, but it will just keep on collecting the data from your data nodes. Okay, that is what the role of passive name node would be. Now, as soon as this, because this now is reading, right? So it knows the status of data node. It knows that where the blocks are being written, everything, it has the information. Now suddenly if this machine is down, in that case my passive name node will ensure, it will immediately start acting like a backup, and that is how it is ensuring high availability. You are not going to lose your cluster time. So basically the downtime will not be there. Immediately your passive name node will start acting like an active name node. Okay, so this is how basically the Hadoop is ensuring high availability. This is a very famous interview question. Passive and secondary name node, good question. Difference between passive name node and secondary name node. Secondary name node we used to use in Hadoop 1.x. Now secondary name node, what used to happen was, secondary name node you can say is just like a snapshot of this machine. Means you're just copying the data to other machine. But if my active name node is down, if my main name node is down, in that case my secondary name node will not start acting like a backup. It will only keep the data, but it will not start acting immediately like a name node. It will just keep the data. You have to physically, manually kind of bring the name node up, copy the data from the secondary name node to primary name node, and then start working on it. But in Passive name node, yes, but so it's kind of a human intervention, right? Manual intervention is required here, and there will be a downtime. There will be a downtime here. But when it comes to the active and passive name node, passive name node is going to ensure that it is not only collecting the data, metadata, but as soon as active name node is down, passive name node start acting like a active name node. Clear on this difference, Gordon? No, Anand, you have asked this question, right? Clear about this question? Answer? Anand, the difference should be very clear to you. Wait. So let's move further. Okay. So we have few more questions now. So this is for MapReduce side. So let's do one thing, friends. Let's take a 5-minute break. Okay. Let's take a 5-minute break, and we will start with MapReduce questions. Okay. I'm not sure. Maybe Edureka guys, somebody will answer you. Just need a sip of water or so. So just give me 5 minutes. We will take a. Okay, you want 10 minutes? Ravi, this is just basically a 2 to 3 hour session, so we don't want to make it too much. Let's make it a 7 to 8 minutes. Will that work? Let's come up with a in middle kind of solution. So let's come back by maybe by 10:03. Okay, we will start there. Have a water break also. We will come back to MapReduce. Then we have Hive, we have Scoop, and that. So let's come. Everybody, please be back by 10:03. Exactly, I'm going to start by 10:03. Okay, so guys, everybody is back now. Everybody back? Naveen, you should be able to hear me now. Okay, looks like he's restarting. Okay, fine. So now we are going to start. So basically, now we are going to start with MapReduce topic. Okay. Now no, yeah, I'm not shared. I'm just going to share that. Just give me a second. It takes almost a few seconds to basically come to this. Now I hope it should be showing to you. Okay. Meanwhile, I have talked with the Edureka team, and they have informed me that you all will be receiving this video recording in a day or two. Okay. Since that was a question from a lot of people, will we be getting all this video recording or not? So you will be getting this video recording on your email ID in a day or two. So all these things will be there with you. So I think that will be a quick review for you if you want to take a look at any moment. Now, question for you. Can you explain me the process of spilling in MapReduce? This is an interesting question. In fact, think from a perspective of where mapper keeps the output, and from that you can basically make out what is this spelling. I give you a biggest hint possible here. So can you give me this answer? Can you explain the process of spilling in MapReduce? Spills to temp folder LFS, when it spills and from where it spills. Can I get this answer? Mapper phase. Very good. What usually happens is the output of your mapper task, it goes to your RAM. Now what basically gonna happen? They have kept a specific size of that thing. So let's say they keep let's say just 100 MB. Now 100 MB of data will be kept, let's say, in RAM, but they will be keeping a threshold. So it will slowly keep on filling up, Then what will happen? As soon as it will reach a threshold, let's say 80% of that RAM of 100 MB is filled, it will start filling that output to the local disk. Notice here, I am not saying HDFS. I am saying local disk. Okay, to local disk only we will be keeping this data. Local disk means your C drive, D drive, wherever you want to keep up. So this is how they have designed it. So as soon as the mapper output in the memory reaches to a threshold limit, it starts filling that mapper data to your local disk, and this phase is called as filling phase in MapReduce. Okay. So this question is also asked, and this shows basically the internal working of your MapReduce. Okay, so basically this is how internally your MapReduce work. So this is how this is filling the data. Once it's filling, it will again come down, and you can keep more and more data in it. which brings me to another question. Can you explain me the difference between block, input splits, and record? This is a very famous interview question. Can anybody answer me quickly? What is the difference between blocks, input split, and records? What is the difference between these three? Friends, this is a very important question. If you have done this MapReduce part, then you must be knowing this part. Difference between blocks, input split, and records. Very good, Jyoti. So Jyoti is answering record is a single line of data, right? Very good. Kanan is saying block is hard cut of data, just 128 MB. Very good, Kanan, right? Block is equal to 128 MB. If record is 130 MB, input split will happen. Very good. Block is based on block size. Input split makes sure that the line is not broken. So it makes sense record is single line. Block is set by SDFS. Input split is logically split. Very good. Very good. So what usually happens, right? So let's say when we talk about block, so let's say you have default space is 128 MB. So that will be called as a physical block. Okay. When we talk about input split, right? So let's say if your data is of 130 MB. Now in that case, don't you think it makes sense to have a logical split of 130 MB here? So that will be your input split. And record is when you do MapReduce programming, right? When you do MapReduce programming, how your mapper take the data? It takes line by line, right? It takes line by line. That line is called record. So one line of data which it picks up in the mapper phase is called your record. Okay, very, very famous question on this part. So you can say block is a physical division, while logical division are called your input splits and records. Okay, because the logical division is what your MapReduce program do. Which brings me to another question, again related to MapReduce. What is the role of record reader in Hadoop MapReduce? What is the role of record reader in Hadoop MapReduce? Make sure to read the complete record. No, no. How that is how mapper reads a record. Good. But Digambar, can you be a little more explicit? You are coming close to the answer. Can I get more answer? Also, Digambar, can you just be a little more explicit? That is how mapper reads and record. You are coming close. What about others? What is record? Record is single line. We have just understood it. So what should be record reader? Parsing that single line. Very good word, right? So don't you think that single write what you are reading, and how mapper convert your data? It converts into key value pair, right? So it initially takes an input as a key value pair. So when that conversion is happening, that is done basically by record reader. Look at this. See, let's say this is the data. It will be getting converted to key value pair, where key is called your offset and value is first line, right? Or second line or third line, right? So this is done by record reader. Okay, so this is what record reader do. Now, what is the significance of counters in MapReduce? Significance of counters in MapReduce. Okay, give statistics of data. Counters will be done in name node. Okay, counters to validate the data read to calculate bad records. Good. Not just bad record people, it can do even other things, right? It just bad record is just one example, right? It's just one example you can say. So what it do is it helps you to identify the statistics, right? Now basically it gives you the statistics about some operation what you want to do. You can print it in the console also. I believe that if you have done this Hadoop course, you must have seen one code for your counters, right? Where you must be doing some sort of operations and you might be printing it on your console window. Now, how you will be doing all that? So what you will do, let's say we are applying counters on this example. And in this example, as I think somebody just mentioned, for the kind of reading the bad data, this example actually bring up the same thing, but it can do even other things. I will tell you what are the things now. But let's take this example. Let's say we want to find out what all bad data I have in this. So let's say it is reading David, all good, no problem. Counter will remain as 0. Then what it did, it basically just gave the value as 0. It reached to the second line. Now this value move up. Now basically this was the bad data. I read it. I passed the statistics. Now counter value became 1. It reached to Jeff. If the value stays as 1 because this is a good data. Now Sean, again the value remains the same. Now as soon as it reaches the last line of bad data, it will again increase this counter and will return that I have 2 bad lines of code. But does that mean we can only do this operation on this? No. Maybe I can have an example where, let's say, I have data of which is, let's say, of timestamp. Timestamps are there. Okay. I want to print in this time. So timestamp I can convert to date type, right? In my program, I can convert it to date type. Now, when I convert to date type, maybe I have months being defined, right? Because in date I have months. Now, maybe I want to find out or want to calculate the statistics that in among this timestamp, how many times January is occurring, how many times February is occurring, how many times March, April and all are occurring. Let's say I want to identify all the statistics. I can do that with the help of counters very easily. Okay, so this is the purpose of your counters. Now, moving further, why the output of map tasks was filled into the local disk and not in HDFS? Good question now. Can you answer me this? Remember we talked about, yes, we have just discussed that question, right? So we have just seen spilling. Now, how can we assess counters? There are basically libraries available for that. There are classes available. Get counters is the member function to get that. This is how basically we'll be assessing it. So counter is a class in which we have member functions, predefined functions. Using that we can assess that. Because it's an intermediate output. Okay. Intermediate output, that's fine. But why we are not keeping in SDFS? That's my question. When I can keep intermediate output in SDFS? Very good, Ramya. Very good, Narsimha. So basically, if you notice what happens, if you keep in HDFS, right? Remember, there is a replication factor, right? That replication factor will do what? It will increase the number of output blocks. Do you think it makes sense to increase the replication for your mapper output? Definitely a big no, right? So that's the reason we will be keeping in your local file system. We will not keep in SDFS. Otherwise, SDFS will replicate even mapper output, which we don't want to happen to do. So that's the reason we will stop that. So we will be keeping in the local disk, not in HDFS, in order to avoid basically the replication. Which brings me to another question. Can you define this speculative execution? Can you define this speculative execution? Can I get this answer? Can we define speculative execution? It prioritizes only some tasks, coming close but not exactly right, Namsuna. If a job in a node is taking much time, very good people. So this is what happens in speculative execution. Let's say if any of your task is running very slow. In that case, your speculator, there will be a scheduler which will basically start a duplicate task of it. It will start running a duplicated task for it to ensure that basically that duplicate task runs faster, and once it will finish, it will kill all the duplicate tasks. So it is just kind of making sure that, because it can happen, right? Maybe your task is waiting due to some resource, it got blocked due to any reason. So in that case, it will start immediately a duplicate task and making sure that your job finish quickly. Okay, so this is the part of your speculative execution. Which brings me another question. Question is, How will you prevent, Jan, very good, Vipul. How will you prevent a file from splitting in case you want the whole file to be processed by same mapper? How you will prevent a file from splitting in case you want the whole file to be processed by same mapper? I want my file to be now basically to be used by the same mapper, not combined, not combine or decombine. Can I get some more answers? It's easy. Can you see this file? So what we can do here is, first of all, we can increase the minimum number of split size, which should now make it larger than your last file, right? This operation is itself good enough to make this case true, right? Because if we increase the size itself, we will be all good. But there is one more thing which you can do after that is, this is method 2 basically. In method 1, you can just basically increase the size itself, it will be all good. Or what you can do, you can go to your input format class, and in that you can just update this property. You can make this is splittable to be returning first. Usually people prefer method 1 because that's the easiest method, right? You need not update the Java code basically to achieve all this. So what you will do for this? Can you please tell a scenario where file splitting is not needed? It all depends, right? So let's say if I know that I have only one data node. I mean, let's say I have only one data node. Now, in that one data node, do you think it makes sense to divide a file multiply together? I have only one data node, right? Do you think it makes sense? Because again, it's in the same machine, right? So that's the reason there you want to basically keep one block itself so that I can execute it. So these can be few situations where you can decide not to split the file, and in that case, how you will be doing it? These are the two methods to achieve. Okay, moving further. Is it legal to set the number of reducer tasks to 0? That's question number 1. Where the output will be stored in this case? Is it legal to set the number of reducer tasks to 0? Is it legal? Definitely legal, right? Everybody have used scoop. In scoop, was there any reducer? Was there any reducer in scoop? No. Scoop only use mapper, no reducer, right? That's itself a tool, right? When a tool is not even creating any reducer, definitely I will not be using that, right? So what is going to happen here is, let's say, so what was the purpose of reducer? Purpose of reducer is when you want to do some sort of aggregation, right? Maybe you want to sum it in the end and all those category kind of thing. But it's not mandatory that all the problem statement in the word require aggregation, right? So those problems where you do not require aggregation, like I said, scoop, because in scoop what happens? You copy the data from RDBMS to your HDFS or vice versa. Now, are you doing any sort of aggregation? No, right? You're just copying the file from RDBMS to your HDFS system. No aggregation required. So in those cases, you will be having reducer as 0. Output where to store? Definitely whatever mapper output is coming, wherever you are telling, it will be stored in that HDFS location, right? So that's how you will be using it. So definitely the answer is yes, and basically wherever the mapper output you are keeping, there it will be getting stored. What is the role of application master in map reduce job? Can I get this answer? This is a very famous interview question. What is the role of application master in map reduce job? To assign the task, okay, that's it. Only to assign the task. Sets the input split, okay. It manages the application fired and keep track of sub process. That's it. Vipul, nothing else. To get the resources needed for the task. Very good, Ramya. Now you are coming here. You are coming close. To create task until it runs. Yes. What basically application master do? First thing is, application master is kind of deciding that how many resources it needs. Okay. And it can basically now inform resource manager that I require this many resource and give me this many resource to execute that. Then after that, resource manager give back the container, right? if you might have gone through a yarn architecture, right? There you might have understood all these portions. Right. So basically what happens, it first basically find out how many resources are required. Secondly, what it want to do is, it basically want to find out, once it happens, when it gets all the container, it kind of basically gets them working together. It collects the output back and return it to basically the master node. So it is doing multiple things in MapReduce. It's basically not doing just one task. It is also checking, which is a very important role of it. It is checking that how many resources I require and kind of helping the resource manager to take that decision. Okay. So this is what the same thing being explained here. The role of your application master. Which brings me to another question. What do you mean by over mode? So when your MapReduce job runs, I'm not sure whether you have noticed that or not. There is something called as Uber mode. It sometimes comes in your console, if you have noticed that. So can you tell me what is that Uber mode? Is there any advantage of switching on the Uber mode? What basically Uber mode is going to do? Runs on application master node. Very good. Can I get some more answers? More insight on this? Good people. Can I get some more answers? Yes. So let's say if you have a small job, right? If you have a small job, in that case, you're basically, again, application master need to be anywhere. Now application master will request and then it will allocate container, right? So container sending and all, basically creating container, all those things are time consuming. If the jobs are small, what your application master can do, application master can start a JVM in itself. Okay, so basically application master can decide to complete your job. Because the job is small, it may decide to complete the job on its own. In that case, we call it as Uber mode. So Uber mode basically require less, it's when you will be using, let's say, less number of mappers, let's say only 10 mappers, you have only one reducer to work on. So in those cases, you use Uber mode. Now, how to enable all that? So basically, there's a property which you can set to true, and it will basically enable your Uber mode. In which, what's going to happen? Your application master will start acting like a JVM and will finish the job. So thus, it will save you by creating containers, making your performance better. So usually, what people do is, whenever they will be having some sort of, whenever they will be having small jobs, right? And they want to improve the performance, they usually kind of enable the Uber mode. So now the application master itself start executing the task, and that way they improve the performance. But when you have a bigger job, it will not work. In that case, you need to keep the Uber mode as possible. Otherwise, you will degrade your performance. It will not even work. Okay? So this is basically your Uber mode. Another question. How you will enhance the performance of MapReduce jobs when dealing with too many small files. If you have, let's say, many small files, in that case, very good report. Yeah, that's also one thing. If you have, let's say, many small files, how you can improve the performance of your MapReduce job? Combiner? No. Coming close, but not the right answer. Too many small files are there, then now what you will do? Basically, there is something called as, because none of you give the very right answer, there is something called as combined file input format. That's the reason I told you what you are coming close but not exactly coming right. So what this do is, it kind of package all the small files together. See this diagram. See this part. Like these are some small files. It basically now combined all the files together. Now because these small files got combined together, now my execution time will be faster. This is basically one practical thing which is being represented. This performance, can you see? Like the small files was taking this much of time, and basically with this, when you combine this, it actually started taking less time. So thus improving the performance of your system. So this is how basically you can improve the performance if you have multiple small files. Now, Let's move to Hive. Hive is very important topic. Now, question for you, where the data of Hive table gets stored? The data I know, Narasimha, that is going to be in SDFS, but where is the location of that? Where is the location for that? But what is the default folder? Network version? Very good. Now you are coming close. So by default, you keep it in /user /hive/warehouse. So this is the location where by default all your Hive table gets stored. If you want to change this, you can go to your hivesite.xml and can update this setting as well. Another question. Why HDFS is not used by Hive Metastore for storage? What I mean is, you might have read in your course that you keep your Hive, basically your Metastore, in your RDBMS, right? Not in HDFS. What is the reason behind that? Why we not keep all these things in my HDFS? Why your Metastore is created in your RDBMS? Why you are configuring your Metastore in RDBMS for Hive? Why not in HDFS? Can I get this answer? Why you are keeping your Metastore in your RDBMS system and not in your HDFS? I can tell you this is the most important question of Hive. In any interview of Hive you will go, expect this question. This usually everyone asks for random access, but that you can do in SDFS also. Ramya, it needs DB catalog. What is that catalog? Because it needs to use JDBC connection? No, that's not the answer. Okay, let me ask you this question, okay, which is actually the main reason for it. So let's say if what you do is, when you create a table in Hive, what happens? It creates an entry for that table in Metastore table, right? What it's doing? It's inserting the row level, right? At a row level it is inserting. You created another table in Hive, again you are basically inserting some values here, right? Now let's say you deleted some table in Hive. What happened? It did a row level delete. Can you do this row level delete, row level insertion and all in your HDFS? Okay, you are saying, referring to the same thing, Rajesh, then you are good. Can you do this, basically this in your HDFS? No, right? This itself is a good answer to explain this, right? So, and second thing is definitely in RDBMS, the seeking time is going to be faster and all. Those are the other factors. But first thing is basically your CRUD operation cannot be done in SDFS. That's the reason we will not be able to keep in SDFS. Forget about other factors, right? They do not make any sense in fact, because my first property itself is failing of basically CRUD operation. Now, let's see some scenario questions. Usually in Hive Pig, you will find some scenario questions coming up. Now, scenario question is, suppose I have installed Apache Hive on top of my Hadoop cluster. Can you please show the last answer? Sure, why not? See this answer in the clear? Let's move forward. Now, can we see this question now? Suppose I have installed Apache Hive on top of my Hadoop cluster using default Metastore configuration. Then what will happen if we have multiple clients trying to access Hive at the same time? Can I get this answer? Suppose I have installed Apache Hive on top of my Hadoop cluster by using default Metastore configuration. Then what will happen if we have multiple clients trying to access Hive at the same time? Very good. Usually in Hive, you can only basically access one by one client. So multiple client access itself is not allowed, right? Very good, Narasimha. They have given basically the right answer for it. So usually these are the scenarios what it follows. So main thing is your multiple client access in Hive is not allowed. This is by architecture, right? Because you should maintain the read consistency. Very good, Rajeshwar, right? So that's the reason this itself is not going to work out. So basically that is what you need to keep in mind. What is the difference between external table and managed table? In fact, managed table you also call it as internal table. So can I get an answer? What is the difference between external table and managed table? Can I get this answer? External table can be a file, okay, but I want a difference, proper difference. External table where the HDFS file won't be deleted if we delete the table. When you say HDFS file, okay, I can accept your answer, Angela. External table is stored in separate location of our thread, but even internal table I can store it at some other location by defining the location keyword, and the external table keeps data when it gets deleted. Very good. That is the major factor. When you talk about managed table, what happens is if you have deleted any of the table, what is going to happen? It will delete the entry in your metastore. At the same time, it is also going to delete the data file. But in external table, if you delete a table, it is going to only delete the entry in your metastore, not from your main data. Okay, so that is the major difference basically in the managed table and external table. Another question, when should we use sort by instead of order by? If you notice, these two APIs belongs to Hive, and these two basically going to do exactly same thing. So when should I use sort by and not order by operation? When should I use sort by and not order by operation? So basically to answer this, not able to catch things. I did not get this, Ravi. When we should have only one mapper. Okay, Ravi, I think you are in 5th module, right? So that's the reason. Yeah, I can understand. You have told me in the starting itself, right, that you are still going through this course. So if you are not getting it, it's completely fine. Just listen to this, okay? Just listen to this conversation. Once you will go over these course topics in basically from wherever you are doing, you will be all compatible with it. Okay? Basically now I can understand if you will not get anything because these modules is not being taught to you yet. So these are basically the new modules which will be taught later. Now, can I get this answer? In case of numericals, no, that you can use also order by. One of it use reducer, other use mappers. Okay. When you use group by operation, no, that's not the way. Actually, what happens is if you have huge data set, in that case, you should use basically the sort by option. It usually do this sorting on multiple reducer, while order by do it on one reducer. That is basically the major difference. So when you have huge data set, use sort by instead of order by. Okay, a lot of people remain confused with this. That's why this is a very tricky question. What people are usually, if you ask anyone, right, if you do not know the answer, he will tell you both do the same thing. But actually, that's not the fact. There is a difference. Now, another question: what's the difference between partition and bucket in Hive? I think the most easiest question to answer. Can everybody answer this? Whoever has done on Hive topic. What's the difference between partition and bucket? This is the most easiest answer. Can I get this answer? Difference between partition and bucket. Simple, right? Partition is basically at the first level, right? When you split the data into different directories. Bucket is like a sub-partitions of that, right? So even for that partition itself, when you create another sub-partitions, you can call them as bucket. Like in this case, can you see the first partition is PLC department, civil department, electrical department. But after that, we have also created some sub-partitions of it. And that is your bucket. That's basically the difference. Another question. Let's say this is the scenario. You are creating a transaction table. Now, this is the table what you have. Like transaction table is the table. You have this many columns. delimited field by comma. Now let's say you have inserted 50,000 tuples in this table. Now I want to know the total revenue generated for each month, but Hive is taking too much time in processing this query. Can you tell me what the solution you are going to provide? This scenario is actually a very good interview scenario. Very good, Nasima. Can I get more answers? Very good, Vipin. Can I get more answers? You will be partitioning this table. How you will be partitioning? You will be partitioning your table with month, right? So basically, if you partition a table, you will improve your performance. So these are the simple steps. You can create a table, partition by month, set these properties to true so that you can enable your partition, insert the data, and then you can retrieve the data where your month is equal to January. So while after partitioning the table, you can improve the performance. Second thing, can I get an answer of this? What is dynamic partitioning and when is it used? Can I get this answer? What is dynamic partitioning and when is it used? That can be static partitioning also in the right. So I want to know what is dynamic partitioning. Very good. Partition happens when loading the data into table. Right now I don't know that if I do a dynamic partitioning where it is, how many partitions also it is going to create. So the value of your partition columns will be known only during your runtime when you will be creating the partition. That is called your dynamic partitioning. Okay. How Hive distribute the rows into bucket? Can I get this answer? How Hive distributes the rows into bucket? Very good. Hash algorithm. Okay. It uses the hash algorithm. To understand this part, if you look what we are doing here is, now, no, you will be using clustered by, but basically are in the how internally this is doing. That's basically how it is doing. Let's say you want to put into two buckets. In that case, it is going to do modulo of 2. Okay. So let's say modulo of 2, this output came out to be 1. So it will decide to put in bucket 1. Modulo 2, it is going to become 0. It is going to keep in this second bucket. So this is how it will be decided. Okay. It will be using basically a hash computation of this. So basically it will be using hash function of this. So let's say hash value of this value came out to be 1. Hash function of this value came out to be 2. Hash function value of this came out to be 3. Then basically it is doing this modulo operation and giving the output, and that's how it distributes the bucketing data. Now, which brings another question. Suppose I have a CSV file which is named as sample.csv present in temp directory with the following entries. In that case, how you will consume this CSV file into Hive warehouse using built-in SERDE. SERDE means serialization. SERDES, deserialization, that's basically serialization, deserialization. When you convert your data into kind of bytes. Can I get this answer? Row format delimited by comma, not exactly. I'm looking for something else. Actually, this requires some API. So let me show you this part. See this answer. In this case, you will say raw format SERDE org.apache.hive.serde2.opencsv SERDE. This is what you need to add. Okay. Now you got it. What's the mistake you are doing? So basically, this is what you need to add. Otherwise, everything is same. You can save in the TMP folder and all that. Just that the only difference will come in row format SERDE. Another question. I have lot of small CSV files present in input directory in SDFS, and I want to create a single table, Hive table corresponding to these files. The data in these files are in this format. Now, as we know, Hadoop performance degrades when we use lot of small files. So how you will solve this problem? Can anybody give me a simple answer of this? This should be easy. You have multiple small files. Now in that case, what should be the solution? Because definitely my performance is going to degrade. What should I do? Concatenate solve file, but can there be another answer? Don't you think you can use sequence file here? Sequence file, right? If yeah, one solution can be to that is from the HDFS level itself, Girish, right? I'm talking from basically Hive perspective, right? Don't you think I can convert in a sequence file? Sequence file will convert everything like 0101 kind of thing. So that's what make it better, right? Will improve my performance. So first create a table, load the data. After that, what you do, store it as sequence file. And then basically load this data from this file, what you've inserted, to this file. This will ensure now that your speed will be quick. Why do we need to do in Cerdis? Why do we, okay. So basically when you do Cerdis, right, the advantage what you get is, so let's say first thing is compression, because you are serializing the data. When you serialize the data, it makes the transfer also very easy, because we have converted like 010101 kind of entry, right? So first thing is when you convert to Cerdis, you compress the data. Second thing, since you convert to this 01 format, now the transfer over the network becomes a lot easier for me. Clearly, Kamba? That's the reason we basically use this schema. So, but remember, there is no free lunch, right? There is nothing called as free lunch. Don't you think this will also have a disadvantage? When you do a deserialization, again you need to convert it back. Don't you think it will impact the performance a bit, right? So remember, there is no free lunch. Though it is helping you in this act, but at the same time it will demand your performance. It will eat up some of your performance. Now some big questions. Can you give me this answer? Difference between logical and physical plan? Should be simple. Difference between logical and physical plans. I know guys that you got little tired because this is a big session, but don't worry, we are almost getting done. So I want everybody attention to be back now. Can you tell me the difference between logical and physical plan? This must be the first thing what you must have learned in your Hadoop course when you went to pick topic. Whenever you are executing statement by statement, okay, it is just executing the statement, nothing. In that case, first it creates a logical plan. Means, let's say if there is no error, right? In that case, it is just creating a logical plan. But when you do dump, right? When you do dump, then only the execution starts, right? Because of lazy evaluation. Then your logical plan kind of get converted to like a physical plan. Means it start getting executed. Now let's say if you have given the wrong file path, right? In logical plan, it will not give you any error because there is no syntax error. Only at the time of physical plan, it will give you an error. So physical plan is when you are basically executing your MapReduce job, when this pig is getting converted to MapReduce job, and while logical plan is at the initial level. Okay, so that is what happens. Can you tell me what is bag? What is bag? Collection of tuples. Very good, right? So basically, when you say a whole data file itself, right? Collection of tuples, if you notice. So let's say this is the data, right? If this is the data, now if you see this is one tuple, this is second tuple, this is third tuple. So collection of all these things will be called as bag. Okay, collection of all these things will be called as bag. Now, how Hive is only working with like Hive is able to deal with only structured data, but Pig is able to deal with unstructured data. How Pig is able to deal with unstructured data? Can I get this answer? How Pig is able to deal with unstructured data? It is actually happening because of schema-less part, right? Schema-less part. Basically, if you do not have schema, if you do not have schema defined, then also Pig can work. What Pig do is, let's say you do not know, like in Hive you have column names, right? Let's say column name is age, integer, all that, right? So you need to define the column names. In Pig there is nothing like that. Let's say if you do not know the column name, there is no schema being defined. You can define it like this. First column you can define by $1. Second column you can define with $2. So that's how you can also define. So basically in Pig you can define even your schema-less thing. Okay, so you don't have anything, it will treat it like null. It will start treating, if you do not define data type, it will start taking it as byte. So basically, Pig kind of converts your values to other way. So basically, that's the reason you can basically go with Pig with unstructured data. This is one of the major reasons that Pig can deal even unstructured data, while Hive cannot do, because Pig kind of converts the data or treats that data in different ways, right? Like if you don't have column name, you can define this as $2, $1, all those things as well. What are the different execution modes available in Pig? So there are two modes, right? One is local mode, one is map reduce mode. Yeah, sure, Emily, can do that. This is the same thing, Emily. Like if you have no data, it treat it like byte array. If you don't have column, it start treating like $1, $2, right? One before. Okay. This one, back. Got it now? Wait, let's move further. Now, so there are two modes available. One is map reduce mode, one is local mode. So when you go with Pig in map reduce mode, so when you just type Pig, right, it takes you to the grunt shell. By default, it takes you to the map reduce mode, which basically also states that basically if you are going with map reduce mode, you are accessing your HDFS. While if you are using local mode, what you need to do? You need to go like this: Pig -x local. It will now take you as in the local mode. When you say local mode, what basically happens here? It basically now starts accessing the file from your local file system. Now it is no more accessing HDFS, but it is directly accessing the data from your local file system. These are the two execution modes. Flattening, this is very simple, right? So basically flatten is the keyword available. If you have this kind of data, you can flatten it up, like everything will come together in the line. So flatten is just an API, right? You can see this, flatten. So basically it is just basically converting this form of data to this form of data. Okay, so this is basically meant by flatten. These are simple questions. Now, can anybody explain me this HBase components? Can anybody explain me these HBase components? Anyone who want to talk about it? HBase components? It's in front of you. Can anybody explain me these components of HBase? You can start by one. This is the last topic. So friends, I want everybody to be attentive here. So HBase keeps the data in a distributed mode, right? So distributed mode, where it keeps the data, it defines a region where it keeps the data. So like this will be your first region. This will be like the region where you're keeping, let's say, this column value, row value, right? This is a one region. Not together, just like how you define rack, right? You can define region servers, right? Where you're defining basically different regions together. So this is one region server, this is one region server, right? Now what happens? The master will keep basically will be called as H master, like active master, just like your name node works, right? Similarly, HBase uses this H master. What is the zookeeper doing here? Zookeeper is kind of helping you to execute everything. So like in zoo, what happens? In zoo, basically they keep animals, right? They keep animals. They manage multiple different category of animals. Similarly, zookeeper, like big data, also got so many tools available for you now, and basically it helps you to manage everything up. So zookeeper maintains a lot of things for HBase. It kind of helps you to basically see that consistency is maintained. It like in HBase, right? When you work basically in your big data, when you're working in Hadoop, now you have name node, data node, all those things available. But when you're working with HBase, you don't have all those things, right? So in HBase, you don't have concepts of name node, you're keeping data and all. So for that, to do this part, like zookeeper play a major role here. So zookeeper is kind of going to act like a coordinator inside your HBase environment. Okay, it will help you to coordinate all the things, because here we don't have name node, data nodes, so and there is no yarn basically here. So you can treat it like basically just like how yarn was handling things there. It is going to help you as a coordinator. It also maintains the directory structures. Can anybody tell me what is Bloom filter? Bloom filter? Anyone know what is Bloom filter in Edbase? Can I get this answer? What is Bloom filter? Basically, it helps to improve the overall throughput of your cluster. It helps you to basically improve the performance. Okay. Now, if you want to search any specific row, column, cells, it also helps you to do that. So it makes your system very fast. So that's what you need to just enable this. And if it is enabled, it kind of improves the throughput of your cluster. This is the role of your Bloom filter in HBase. Coming to next question. What is the role of JDBC driver in a scoop setup? Simple. Can I get this answer? This is basically scoop are important topic in interview. HBase, I would still say that they're not very important these days. People do not ask questions on HBase, but definitely this scoop topic is very important. Very good. RDBMS database, I want to connect. Now basically RDBMS can be of any type. It can be MySQL, it can be MySQL, it can also be your Oracle DB, it can be DB2, right? So your JDBC driver will be common and can be used for any of your things. So this will basically help you to create a connection with any sort of RDBMS system. This is a very famous question. What's the difference between --target dir and the difference with warehouse -dir? --target dir with warehouse dir. This is a very famous interview question for Scoop. Because both will basically help you to put the data in some SDFS specific location. Then what's the difference between them? Very good. Not so importing all table and all is fine. That you are giving me a use case. I want basically a proper solution. Means what's the difference between them? Is defined. No, Rajeshwari. What happens in target dir is in target UDIR, if you're defining target dir, you need to give the directory path name. Okay, so you need to give the directory name where you will be keeping data. So it is possible, let's say in your MySQL or in RDBMS, let's say you have table called as accounts, but now you want to import this table to your HDFS using Scoop. Now, if you give target dir, you need to tell the name of the HDFS directory where you will be keeping this. So now you can change this name of HDFS from accounts to let's say accounts 1. You can do all that. If you are using target dir, you can change the name of this accounts to accounts 1 and HDFS. But if you are using warehouse dir, in that case, whatever the name will be there in your RDBMS, same name will be created in your HDFS. Same name will be created in your HDFS. No change with that. Okay, so that is one of the major difference between them. So warehouse dir will maintain the same name, while with target dir you can keep the same name or different name as well. So you are forced to basically give the name of the HDFS folder where you want to import it. While in warehouse dir, that's a different story. Now, can you tell me what this query is doing here? Read this query and tell me what this query is doing here. Incremental data, no. Importing employee table, but can you see this -- where clause? It is filtering, right? It is only filtering all the employees table where your start date is greater than this value. Okay, this is what this is doing. See, this is what this is doing. Now let's say this is a question. In a scoop import command, you have mentioned to run 8 parallel MapReduce tasks, but scoop is only running 4. What can be the reason? What can be the reason? Very good, Narsima. Yes, because maybe your number of codes are not allowing you to run 8 parallel MapReduce, right? Maybe you have less number of ports itself. In that case, scope will not be able to take you up to 8 parallel MapReduce pairs, right? It will only use less number of cores. So basically, if your cores are less, in that case, this is bound to happen. Give a scope command to show all the databases in the MySQL server. Can you give a scope command to show all the databases in MySQL server? It should be simple. Serious? Scope list databases, not show databases, list databases. Become okay. Hyphen connect. Give the connections. That's it. It will list all the databases. Basically, that's it. So this will list all the databases. Okay. So those sessions will be very useful for all of you. Thank you everyone for making it interactive and a nice session.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!